Hello, everyone. Oh, wow, that was loud. Okay. Hopefully that wakes everyone up. Besides the coffee, of course. Welcome and good morning to Cloud Native Rejekts EU 2024 in Paris here today. I hope you got a little taste of the fine Parisian morning experience with the drizzle outside. I think it adds to the romance. But yeah, speaking of time, it's 2024. It's March already. And while everyone has been wrapping their heads around it, I've been behaving as if it's March 2024, as if it's March 2024 since December 2023. So it's so heartwarming to see everything come together and to see all of you today, all nice and bright and early, to kick off Cloud Native Rejekts today. So thank you and welcome at the same time, in the same breath. Yeah, I wanted to also quickly check with everyone here today. How many of you are seasoned Rejekts attendees? Oh, and proud, I love that. Yeah, that's the Rejekt spirit. And how many of you are first-time attendees? Brilliant. Okay, so it's like a 50-50 split, which is brilliant. Lots of time and scope to exchange ideas and anecdotes and stories, and I love that. Since we're in the school space, which we call the arena here at the venue, and it gives you this vibe of a game show, I thought we'd take this opportunity to quickly play a short game. It's a quick quiz, and I don't know if all of you have received your coupons for the happy hour later today. In any case, you all will. Do ask at the registration, and they'll hand them over to you. And yeah, coming back to the quiz, I have 3 questions for all of you, and I can choose who in the audience can answer that. And if you get it right, you get an additional coupon for happy hour later today. Yeah, true to the whole game show kind of format, and I'm channeling a little bit of Oprah as well, where I feel like going like, you get a coupon, you get a coupon, you get a coupon, but let's face it, this is also a community event, and we have restricted budgets, but we make do, and we'll still make you happy. So let's start off with that quiz. My first question to you is, how many Rejekts events have taken place so far? And you can raise your hand if you know the answer. Yes, Duffy. Oh, you're wrong. You don't get an extra coupon. Yes, okay, Philip. Nope. One more attempt. Yes. Close. 8 was right, whoever said 8. Yes. You get an extra coupon. I'll hand that over to you. Actually, I have it right here. Yeah, here you go. All right, and the next one. Which company is behind the organization, the main organizing team? Yes. Yes, that's right. Okay. Here you go. Yes, it's the best way to claim free drinks. And the third question, when do we have the famous lightning round, the round of lightning talks? When in the program do we have it? Yes. Yes, that's correct. But what I was also looking for was end of day 2, but very, very clear and specific for this one. Here you go. Okay, a round of applause to our winners now. I love this. I could do this for a living. Okay. I'm happy I'm able to do it right now. Yes, and so speaking of the program, of course, we have the EBPF Rejekts, the lightning round tomorrow at the end of day 2. A highlight for today at the end of day 1 is also the happy hour. So I hope you're all excited for it and you stay all day long. There's also the fabulous barista service out there. So do enjoy yourselves. And I'd like to also emphasize on plenary sessions that we'll have here at the arena, including, besides the lightning round, there's of course like a round where we will have sponsor keynote speeches for 5 minutes. Microsoft, Cisco, and SUSE will be speaking for 5 minutes about their community initiatives. I'd really, really request all of you to support them and attend it. We cannot possibly be putting all of this together without the help of our sponsors. So a huge round of applause to our sponsors. A big thank you to them. Yeah. And yes, and I'd also like you to join me in giving one last round of applause to all of the volunteers that help us put the program together, the program committee, the organization, of course, the organizational team. Like, we have Andy, we have Lexi, we have Chris, and we have Tejas, and we have so many other people who work in the background and help me and help all of us to bring this to its fruition. And you can see what it's about, and you all enjoy it. So yes, the idea would be to celebrate them and appreciate them just for a short bit, and applaud yourselves as well for making it. Thank you. Thank you to the venue and the AV teams, of course, here at eSport. Thank you so much for being so fabulous, for queuing everything up, and for keeping everything ready, and all of this action that you see, this is all them. And yes, without further ado, let's kick off the program with the first talk of our day on OCI Registry by Stefane. Stefane, go ahead.
Thank you. So, good morning, everyone. So it's so crazy to be here so early in Sunday morning, no? No? I hope you bring your cup of coffee before, because it will be intense talk about OCI Registry, how to use this OCI Registry beyond the use of container image storage. So the agenda for this session will be first something about the brief overview on OCI Registry, the specification and images, and then I will have a look on how to use this OCI Registry to store something else than than image, like image from to artifact, and how to integrate them into your supply chains, and I will apply it to a use case on air-gap environment. So before diving into the topic, I'll introduce myself. I'm Stefan Estegracias. If you want to contact me, you can use these handles at Estegra. Basically, I'm a cloud native enablement catalyst at ITQ, a European consulting company that focused on multi-cloud solutions. So I enable to connect organization, people, and platforms to bridge the gap between the technology and the business. Additionally, I'm proud to serve as a CNCF ambassador to develop and advocate the cloud-native technologies, and as well to supporting the growth of our community. So let's first have a brief overview of OCI registries in the usual use case to store container images. So OCI means Open Container Initiative, and there are 3 specifications that define how container technology are specified. So first, the runtime specifications defines where the runtime operates, the container operates, sorry. And then we have the image specification that defines how images are organized. And finally, we have the distribution specifications that defines how to serve these images. These 2 images and distribution specifications have been updated last month to promote the use of something else than container images, but I will go there later on in the presentation. Before that, I will just remind you some terminology used on OCI registries. First, the registry itself. So registry is a service that implements HTTP API endpoints to pull and push images from and to. Then here you have a usual URL used. Sorry. A URL used by registry client. So it was perturbed by the upload, sorry. So the registry URL here, the usual one. And the first part of this URL is the registry itself. So it's the server host name where the service is running. Then you have the repository that contains all images you would like to have for a specific application. So you have multiple versions on the same repository. So it represents a namespace for grouping these images. And then you have a reference. Usually this reference is a tag because it's human readable. We are human, we cannot read digest like this because it's too long. And is for the unicity and immutability of the image to use this digest. You can, most of the time, on the registry client, use both tags and references, digest, like this, but remember that when you use this, only the digest is sent to the API of the registry. In the coming slides, I will go through the topic there. So manifest, the manifest, then config, blobs, and layers. So first of all, when you try to find something in your registry, you find back with a tag. So you use this API with the name of the repository, then tag list to get the list of the tags contained into this repository. Then a tag effectively points to a manifest. We'll see just after what is the manifest. And to find this manifest with the endpoint, you use this endpoint with the namespace, the name of the repository, /manifest / the name, the tag, and you will get a JSON document that represents an image manifest. So you have media manifest. One, two, three. Yeah. Okay, it's okay. So on the registry, you have an image manifest, you have multiple parts. So the first one is config. The config points to a config blob inside the blob storage, and it's pointed by its digest. So a blob is the binary form of the storage of the images, and the config represents the configuration that the runtime used to run the image. Then you have layers part, so you have multiple layers most of the time, and here a layer is pointing to, each layer points to a layer via its digest, and you can combine these layers to create the full file system for your container image. So let's see an example with specific images. Here the Kubernetes API server image. You see how to dump it, the JSON, the image manifest, so it's a JSON document with image manifest, and you retrieve all the parts, so the config part with its digest and the layers. So here I only represent one layer, but there are more than one in that case. So here I just remember you how OCI registry is working. Now let's dive into how to use this OCI registry to put artifacts on it. So first of all, some projects already use OCI registry to put artifacts into the registry. For instance, some tools like signatures tools or SBOM tools use the same repository to store data into the OCI registry. And they use a well-known tag to retrieve them back from the registry. Another solutions as well to store in OCI registry is to use a specific repository for a specific usage, like mchart or OPA bundle. And in the new specifications, you have the ability to be more specific on what you would like to implement. But most of the implementation that has been done before is being applied to the specification. That means that the image manifest is used to reference the content, even if it's not an image stored, and it uses layers to store the binary content of the artifact. And you can use an artifact type to be more precise on what you would like to present into your OCI registry artifact. And one feature that is very interesting, and I will demonstrate later in this presentation, the relationships between artifacts in the same repository. You can use an additional keys named subject that can manage the relationship between artifacts, and to query these relationships, a new endpoint, referrers, has been added as well. To demonstrate, I will use ORAS CLI, so ORAS means OCI registry as a service. So let's put some stuff into the OCI registry. So we have a content, so is a file. I would like to push into the OCI registry. To do so, I'm using here a test namespace, a very basic YAML file. because we love YAML file, and then push it with orash push. So it's a very straightforward command, and you can imagine that you can just have to set the URL you would like to push into the registry. So here is orash test repository with v1 tag. For identifying this artifact inside the registry, you have to set the artifact type. Here is a fictive one I invented, and pass as well for every file you would like to push in this command, the name of the file plus its MIME type. After pushing this artifact into the registry, you get back the digest of the image manifest. And if we dump this image manifest, you will see that is exactly what we expect from the specification. It's an image manifest, as usual, with config and layers part, plus artifact type that the one I passed in the command before, and the layer type of every file. You see the YAML type I put in the command line before. So the artifacts are exactly the same, stored exactly the same way as the image. And the difference is that the media type used in image manifest are different. To get back this content from the registry, so is orash pool, that's very straightforward, and the URL to use to push it, so orash test v1. And orash will download the file for you and extract it on your current directory to retrieve the content you pushed just before. So it's not so complex to push whatever content into OCI registry. But let's go further by pushing more content into the OCI registry. Let's sign the content. So here is not very relevant because it's only a YAML file, but let's assume we have another content here. So let's sign it and push the signature into the registry. And because we have a new behavior of relationship between the content and another artifact, we use these relationships by attaching the signatures to the content. To do so, I will create a signature, a very, very strong signature, as you see here, but let's assume it's a valid one, just for the demonstration here, and use orash attach command to attach this to the registry. But before attaching, orash will push the signatures and then attach it to the URL I put here in the command line. And as before, you need to pass an artifact type, so here is still a fictive one for the signatures, and the type of the file I pushed. After pushing to the registry, I got, as usual, back the digest of the image manifest corresponding to the signatures. And if we dump the signature manifest, you see that it's still an image manifest as well with media type, artifact type and the layer media type exactly the same as a spice in the CLI. And on top of this, you get the subject part that reference the content I pushed just before. Remember the command I tapped just before to push the namespace file. I got the digest of the image manifest, and it's exactly that it is pointed by the subject. So here it represents the relationship between the signatures and the content. So now, how to get back these signatures by only knowing the name of the URL of the content you pushed. It's easy because you have now discoverability of artifacts that are in relationship together. So we use orash discover command with the URL orash test v1 that represents the namespace YAML file. And orash will dump you all the relationship he found. Here, exactly the signature I pushed. So remember, when I pushed the signatures into the registry, I got an image digest. And then this is the same as the one I get back by using orash discover. And I can pull, get back the signatures from the repository, yes, with the exact digest I got from orash discover. And orash will download the file for you and extract it in your current directory. So you see, you can have relationships between artifacts, and you can retrieve easily one from others. So it's not the same way as the tools used previously with a well-known tag. Here, you don't need to know the tag of the signatures or the SBOM to get it back from the registry. You just have to use the URL of your own content. So let's continue to push stuff on the OCI registry. We will create a software bill of material of this content, and push it to the registry and attach it to the content itself. So it's very similar to the signatures. So here, assume is the valid SBOM. So SBOM usually is the catalog of the component in the content. So here is a JSON file. I will attach it to the content as before, and then I have to pass artifact type. This is a fictive one as well for the SBOM, plus the name of the file and the type of this file. After pushing to the OCI registry, you know the story now. You will get back a digest from the image manifest, etc. So I won't show you the image manifest because you know exactly how does it work. And for those who are not focused, let's wrap up where we are. So we create the content, and we sign this content and create a SBOM for this content and push all of them into the registry and create relationship between the signatures and the content and the SBOM and the content. So let's be crazy more. Create a signature for the SBOM. Because we need security and for the security on your pipelines. So I would like to get these SBOM signatures into the registry. So what I will do is to push it and attach to the SBOM, because the signature of the SBOM is related to the SBOM itself, not the content. So it's why I'm using, as before, signatures. So the same signature as before. So let's assume it's a valid signature and push it by using ORAS attach command line. But here, instead of using the ORAS test v1 reference, I'm using the one coming from the SBOM pushed I executed before. So you see here is exactly the digest I got when I pushed the SBOM into the registry. And then, like usual, for ORAS, you need to pass the artifact type and the type of the file you pushed to push this into the registry and create the relationship between these SBOM signatures and the SBOM itself. So now we have everything in the registry I want. Now, how to discover these relationships by using a simple command. So remember, the command for ORAS to do so is ORAS discover, but here I will put only the URL of the content, and to get the hierarchy of this relationship, I'm using the option O3 that will show a tree like the tree command line for the file system. And the result is like this. And to follow the hierarchy, I just will put here at the bottom right the diagram I show you in bigger screen to follow this. So first, you have the content with the image manifest of the digest, the signature, the SBOM, attached both to the content, and attached to the SBOM signature. So, as I said, it's quite easy to manage content into the registry, and you can push whatever you want into the registry and put relationship between them, and you can retrieve easily by using only the URL of the content. But now, how to integrate this new artifact into your supply chain? Let's assume here is a usual GitOps supply chain. So developer create the codes, push into the Git. It triggers a CI pipeline that will scan, test, and create an image that is pushed, a container image that is pushed to OCI registry, and an mchart that is pushed to a chart repository. Then the platform team create platform configuration, push it to the Git repository, and then bootstrap the platform with a GitOps operator, such as Argo CD, Flux CD, or Rancher Fleet, to get the operator to pull the configuration from the Git repository and install the platform to get the application ready to install. So application definition follow the same. Application code is stored to Git repository, and the GitOps operator will pull information from the Git repository to install the application into the platform. But how to move this artifact into OCI registry to get OCI registry as a single source of storage. First, Helm chart. So Helm already support OCI registry to push it there. So I will get here, I will fetch cert manager bundle and push it to OCI registry with the Helm command, so Helm push with here the URL of the dir name of the repository. It's something weird with Helm push command. You don't put here the full repository name, but only the dir name, because Helm will add for you the name of the chart as the completion of the repository and use the chart version as a tag. And you will get, and because you push on OCI registry, you get back a digest of image manifest. And if we dump this image manifest, you will see this is an image manifest, again, with specific media type for M configuration, and for the layer, the M tarball, so exactly the chart content into the layers. To use this with Helm, you can use this command you use usually with Helm upgrade install, but here use OCI URL instead of the name of the bundle, and then use the version parameters as usual to pass the tag. So you can move easily configuration chart to the OCI registry, and because both images and chart are OCI artifacts, you can implement the workflow I just presented you to enforce the security and create signatures for both. So now we have to move all the GitOps operation into OCI registry. To do so, I will use Flux CD, because Flux is capable to push Flux configuration into OCI artifact, OCI registry. You use flush push artifact command line to push it to the OCI registry. And use some variables coming from the Git repository where the Flux manifests are stored. I pass the path from for the manifest I'm using for Flux. And as usual, when you push something on OCI registry, you get the digest of the image manifest. And if we dump it, you will see it's still an image manifest, but with specific types here for Helm, for Flux config and Flux content that represent the files I put in the path. I pass to the command line. And to use it from the GitOps controller, you just have to replace Git repository by OCI repository and pass the parameter of the URL and the tag as you want. Then that means the workflow I presented can easily transition to this one. So the platform configuration is stored on Git and can trigger a CI pipeline to build scan and as well add signatures to enforce the security and push the artifact into the OCI registry. And then the Flux controller, the source controller, will fetch the content from the OCI registry. And the same for application definition. You can enforce as well the security by sign everything you push on the OCI registry and fetch, pull everything to your platform and install the application. So now, how to manage to see it into your air-gapped environment? Before going through the registry ops pipeline, I will just remember you how does it work for the GitOps way. So here is the GitOps supply chain. On the air-gapped environment, the deployment is totally disconnected because air-gapped is isolated from everything. So here, you need to create a relocation bundle, but in that case, you need to relocate many components coming from OCI registry, chart repository, and Git repository. Move the bundle to your isolated environment, and for this solution, you need to create an OCI registry server, a chart repository, and Git servers to receive all the components I unpack from the bundle. So you need to install, manage, and operate those 3 servers in the isolated environment, and the operation from the GitOps operator is the same. With the registry ops solutions, is even easier because you only have one type of content, OCI component, like images, artifact, and signature. And everything is the same for the air-gapped environment. The deployment phase is totally disconnected from the production. So you need to create a bundle. But the relocation bundle here is even easier to create because everything coming from OCI registry, the image, the Flux artifact plus the signatures, move it back to your, move this relocation package bundle to your air-gapped environment. Here, you only have to install a single server, the OCI registry, to unpack everything. You don't have to think about where to put whatever tarball you create. You push everything on your OCI registry. And because you put signatures on every artifact, you can verify them before applying to the cluster. So you see, this means that you only have only one way to store images and artifacts, only one way to sign images and artifacts, only one way to validate image and artifacts. So OCI registry is very convenient to have a single source of storage for air-gapped environment to be more flexible in updating the platform. So let's wrap up what we see today in this presentation. So I showed you that we can push whatever content into the OCI registry, and since the version 1.1 of the image and distribution specification, it's now generally available for every application to implement it. So with ORAS, you can do so to create your own content, but I'm quite sure that many other applications will implement these new features in the future. I see notation, for instance, has an issue appear and ongoing for the next release. And regarding the air gaps, using the registry ops is quite easy to use because you only have to manage one type of content, OCI registry, to install in the air-gapped environment, unpack everything, and because you increase the security by applying CI pipelines to sign your artifacts, you can verify them before applying in your cluster on the air-gapped environment. So if you have any question, I will be available all the day to speak with you, or if you want to contact me, you can use that code as well to do so. I would like to thank you as well, the organizer and the sponsor for this event, and thank you for your attention.
Hello. Thank you for the talk. Question on the validation when you're in the air-gapped environment.
Yes.
What does that look like? What does that validation process look like?
So if you use Flux, you can use validation for the manifest using cosign, for instance. And in the next version, you will be able as well to use notation to validate this. For images, you can use OPA or Kyverno to validate the signature, I guess. For OPA, I'm not sure, but Kyverno is sure. And notation and cosign on the SIG-Store project are mostly used to sign the artifact. In the first SIG-Store, cosign only use the well-known tags for now. I don't see the roadmap of this project right now. But for notation, I'm more aware about this because Flux will implement it in the next release, and notation as well in the next release will implement by default the new specifications of OCI images and distribution.
Yeah, something else I was curious about was the relocation bundle. I've never operated an air-gapped environment before, but I'm super curious as to, is there like a standardized tooling for creating a relocation bundle and that?
A good question. So I found two main tools. So there is no standardization yet, as far as I know, but there are some tools that try to ease this for you. So there are one named Zarf that do the relocation for you and as well the delivery. And there are the new ones coming from, I don't remember the name of this one, is a new coming from the rancher side, the rancher security part is start with H, but I forgot the name. I can remember back and tell you what's the name of it. It's something that can pull everything from the registry, create a local registry in your file system, and push them into the air-gapped environment. And that tools as well can act as OCI registry in the air-gapped environment as well, to bootstrap the cluster. Howler, yes, this one. Thank you for reminding me.
Do you have any experience with local registries like Harbor, Zot? Any recommendations what you would use?
So usually in our customer environment, we use Arbor for all the artifacts. Here for this presentation, I'm using Zot. I'm using Zot since the 2.0 version. It becomes more stable, and the 2.2 version just released a few days ago, or yesterday, I don't remember, or Friday. And for Zot, I have no experience on production. I'm using it to see how does it work and how can be transitioned to productions, because Arbor is good for production, but if you like to create a single or small environment, it's quite huge. And Zot is very convenient to create very small environment, because the footprint of Zot could be very, very, very small. So I like this project, so I'm following to see how does it goes.
Okay, great. Thank you so much, Stefan.
Thank you.
Really great talk. Up next, we've got Andy Randall from Microsoft. He's going to talk a bit about community initiatives for about 5 minutes. It's like a lightning talk. And then right after, we've got James Leverak,
yes,
who's going to
sorry.
talk about how EBPF really works. So stick around for that.
Through. 1, 2, 1, 2. 1, 2. Okay, great. Thank you. Great to see so many folks here. This is what we call a sponsor keynote. So I'm supposedly talking about Microsoft, but it's also a little bit of a personal journey as well, because it's actually pretty close to 3 years to the day since I was working at Kinfolk. Let me see if is this. Okay, I will use the keyboard. So I was working at Kinfolk along with a lot of the organizers here of Rejekts, and we were in discussions to be acquired by Microsoft. And Kinfolk was as you may know, cloud native, open source company, and for a lot of our team, the thought of becoming part of the big behemoth in Redmond with all the history of Microsoft, well, let's just say people had questions. But we really, through the process, we talked a lot with the team at Microsoft and the part of the group that we're now in, folks like Sarah Novotny, who many know as the original community organizer behind Kubernetes, and Brendan Burns, one of the inventors of Kubernetes. And we really found that they were very open to what we could bring, and they weren't just looking to bring us in as a team to kind of be absorbed into Microsoft, but we're actually looking to us as well to help shape the future and really drive a cultural change that that they've been already started, but that over the last few years, we've really been pushing forwards. Because even within the walls of Redmond, which if you ever go to the campus, it can feel a little bit insular. It's obvious that open source is really the jet fuel that's powering all of software development today, right? So look at any of the statistics, 96% of applications leveraging open source. I mean, you cannot ignore the force that is open source. And so actually, compared to, if you go back, I don't know what, 10, 15 years, like you were not allowed, if you were a software engineer at Microsoft, you were not allowed to bring any open source inside the company. And the cultural change has just been pretty fascinating to see on the outside, but also from the inside. And we actually have now, we have the Open Source Programs Office introduced company-wide programs that really make it easy for developers to use, contribute, and even start new open source projects. And we publish a lot of those on the website. So if folks have kind of OSPO initiatives, encourage people to look at the kind of things that we've done there. And it really is friction-free. And our developers, all developing in open source, all working on Linux laptops, it's a very different Microsoft from the one that I grew up with. And across the company, we've got over 60,000 engineers now working in the open in GitHub. What kind of things are they working on? Pretty much everything. I mean, you'd be hard-pressed to find any important project in any of the major software ecosystems where Microsoft isn't very, very active. From things like Linux kernel, where we've been heavy contributors over the last 10 years, to data and AI. We have a big Postgres team. We introduced projects like Onyx, and all the way through to things like TypeScript, which Microsoft introduced and really changed a lot of web development. But we're here all about cloud native. What are we doing there? There's again just across the whole ecosystem of everything in cloud native, and you probably know of many of these projects, things like Kubernetes and Containerd and things like that. Obviously, are just ones that Microsoft contributes to. They're much bigger things. But a lot of these ones on the right where we've actually introduced these projects, things like, I was just in a call with a customer talking about Dapper this week, and they were, wow, this is fantastic, hadn't heard of this, didn't know what it does. Distributed application development environment makes it easy to build microservices. Helm, the Helm charts that you all know and love, things like that, Flatcar Container Linux, which came out of our Kinvolk team. Really across the board, we're very, very involved. And in fact, if you look at the stats over the last 5 years, Microsoft's consistently been one of the top 3 contributors to CNCF projects and dev stats. I'm looking forward to when our total number of contributions hits 1 million. That's going to be something to celebrate. We're getting close. And of course, Cloud Native Rejekts. When we talk about community initiatives, this is something we started at Kinvolk. Microsoft has continued to invest in it. The fact that we're all here with free tickets is thanks to the fact that my boss agrees to my budget request every year. So thank you, Jeremy. It's ultimately the investments that we make in open source, the things we're doing, driving the community. It's about enabling us to really both drive Microsoft forward and enable our customers to achieve more and achieve their dreams. And thank you very much for being part of our progress and culture change as a company, and we're very excited to be here and to be part of this. Thank you.
Cool. All right. Hello, everyone. Thank you for coming to my talk about EBPF. This is quite a technical talk for this early in the morning, so I hope everyone's had some coffee. Just a little bit about me. My name is James. I am a senior solutions architect at iSurveillance. I've done some stuff. I've done some stuff in the Kubernetes community. I'm a former release lead back for 124. I've spoken at a bunch of different conferences, but this is my first time at Rejekts, so hello, everyone. And when I'm not digging around in kernel code and compilers, I play weird board games. So that's what I do. There we go. Right, there is some sample code. You can get it on a GitHub link here. It's also, both the slides and the sample code GitHub repository are also linked in the schedule as well, if you want to take a look at that. So, okay, this is, okay, we might have to go back to just mashing spacebar, but that's okay, we can do that. Right, so this talk is fundamentally because most talks about EBPF that I've seen have a slide that looks something like this, where we say that we load some EBPF program and then we attach it to a syscall and some magic happens, and that's great. So this talk is about that specific part, like what actually happens with that loading, what does that do, and what does that look like. I have a little bit of assumed knowledge. You don't need to know in depth. Like, as long as you know what a syscall is vaguely, that's fine. I'm not expecting anyone to be able to explain to me kernel internals or anything like that, so don't worry. We'll be okay. The other big thing about this talk is I'm not using any eBPF libraries. There are a ton of libraries out there, libbpf, the Golang one that I forgot the name, I think it's just GoBPF, and various other ones, really help you do things. I'm not using any of them because the point is learning. But if you want to do this for real and really write an eBPF program, please use a library, because otherwise you'll have to do what I did, and it'll be awful. So, right, quick overview, just so you know what I'm going to do. We're going to introduce some sample code. We are going to compile it down into eBPF bytecode. We're going to talk about the bytecode a little bit. Then we're going to write a simple userland component, that loads it into the kernel and attaches it to a trace point so that we can get some debug output out. So like the simplest eBPF example you can imagine, and we're going to go through what's happening at each stage. So let's start with an eBPF example. Here's some eBPF code. I'm going to step through this line by line. First of all, we'll talk about that later. That's complicated. Don't worry about that. Next, we're going to do some imports. We're just going to get some helper functions. So there's two that we're using here. We're going to grab those with some imports. We're going to make a function. Then we're going to call this helper function, which is going to go get us ultimately the PID in the kernel terms is actually called a thread group ID. So we need to get the TG ID. It's weird naming. That's what it is. So we're going to get the PID. Then we are going to call this BPF print K thing. And this is actually a macro. So here's the first lovely aside about compilers. This is written in C, sort of. And most people's perception of a compiler, at least at a basic level, is you plug source code in one end and get kind of a binary out the other end. But with C, at least, oh my God, okay, this was a mistake. With C, at least, we have a preprocessor in the middle. There is something that goes and will modify the source code before we actually compile it. And that's where these macros are expanded. So that BPF print K actually looks like this. We're actually calling a function called BPF trace print K, and then we're assigning the string we gave it into a constant and setting it a size as well. This is only relevant in the sense that if you want to look at the documentation for what this helper function does, it's not called what you think it's called, because it's actually called BPF trace print K. So that's something to look out for. Oh, and yeah, technically all those includes and defines and stuff are done in preprocessing as well, but it doesn't matter. Right, so what this function actually does is it will output debug information to a particular file in syskernel so we can see it later. This isn't something you do in a real program, but it's used in a lot of debug examples. And then finally, we're just going to return 0. So that's it. That's the BPF code. Pretty simple. So we're going to start by compiling it. Compile line in its most simple form looks like this. So I've annotated it so that hopefully we can see what's going on. But the important parts are we're executing clang, our compiler in this case. We're telling it we want some eBPF. We're giving it our input file, tracebpf.c. We're giving our output file, which is the same with .o. And we're telling it where our includes are, and we're giving a couple of other things as well. And what's important is that -c, which gives it an object file rather than executable. We're not going to talk about why that is. But this is how you compile, in its most basic form, some eBPF into some bytecode. So what's clang? you might be asking. Clang is a C and C++ front end for LLVM, which is useful if you know what LLVM is. But if you don't, here's what Wikipedia has to say about LLVM. If this still doesn't help you, I think this diagram actually works really well. This is one of our blog posts a few years ago. The idea with LLVM, it is a compiler-like framework. So the idea is, instead of having to implement source code to assembly every single time, you can just implement backends for the different architectures and front ends for the different languages. And importantly, for us, with LLVM, there is an EBPF backend. So we can just get EBPF bytecode out with, in theory, any language. I don't think anyone's actually tried to write EBPF from Fortran, but I'm sure someone will try. So it means that our compiler stage actually looks like this now. So there's a whole bunch of like LLVM optimizations and IR that goes on here, and we get an object file at the back and various other things. And we're not going to talk about linkers. Those of you who know anything about compilers might be going, what about a linker? We're not going there. Right. The other question you have, if you've seen EBPF code, is what about these SEC macros you see all over the place? I don't have those in my sample code, but like real sample code and real code does have them. So what's that about? This is just another macro. It ultimately tells the compiler which section, and we'll get to that, of the object file to put various things in. And this is used by real EBPF loaders, i.e. not my noddy one we're going to write in a moment, to pick up a bunch of information automatically. We're not going to do that, so we're going to have to do a bunch of heavy lifting ourselves. So in real EBPF code, you're going to want this. In our example, again, no library, we don't need it. So, everyone with me so far? We've compiled some code. Right, let's see what we got. If we look at our object file, at least when I compiled it, you can see it is 792 bytes. And file will tell us it's an EBPF file. Great, what's in it? We can use a hex dump to actually see the data that's in there. And you can see when we render that as a string, we can see our string in there, because we had that string, that source syscall from PID%D. That's in there, so that's a good sign. We have a string, we have a bunch of other stuff, but what does any of this mean? We can use a function, or a program called readelf to get some information. Because remember, that file thing told us this is an elf format binary, which is just a binary format on Linux and various other systems. So if we use readelf, it'll tell us it has a number of sections. It has them with different names. The one we care about is the one named .text. And if we get a hex dump of .text, these are the EBPF bytecode instructions. These are the instructions. This is the thing we have actually compiled. And what's bytecode? Well, bytecode is like a fake machine language that is used by EBPF because it's compiled again later. Fake in the sense that the real hardware doesn't execute bytecode directly. There's another step that has to happen. And we could just read the BPF documentation for the instruction set to understand what this looks like. So we can actually just read this ourselves if we wanted to. So for example, we know that a single instruction is 64 bits long with an optional extra 64 bits afterwards. So we can just find that out. So let's look at the first 64 bits. That's this in hexadecimal. And if we follow the spec, it tells us that there's an opcode, there's some source and destination registers, an offset, and an immediate value. So we can see what those are. So what does this instruction do? Well, the opcode is hex 85. The documentation tells us that the 3 least significant bits tell us what kind of instruction it is. In our case, with hex 85, that is a 64-bit jump instruction. And if you read the instructions for 64-bit jump instructions, it will tell you that the extra, like, 1 bit, the 5th bit, is where the source comes from, whether it's the register or the immediate value. And then the first 4 bits, the most significant bits, are a code that tell you what kind of jump it is. And I won't bring up that table, but for us, it translates to that hex 8 translates to a call a helper function. And the 5th bit being 0 means that we're going to use the immediate value. So what this instruction means is, well, that immediate value, by the way, is 14 in this case, because I'm not going to talk about endedness in binary, but it's 14. So this means call EBPF helper number 14. That's what this instruction does. You might wonder what 14 means. Well, you can look up a list of the helper functions and their associated IDs, and we can see that 14 is getCurrentPID TGID, which means this is to call that helper function, which makes sense because that was the first thing that we did really in our source code. So this matches. This makes a lot of sense. So you don't have to do this by hand. You can use LLVM object dump to do this for you. This will decompile the bytecode to tell you what it's doing, and you can see the first line there is call 14, which is great. If you're looking at this, the thing you might be wondering is, what on earth is all this about? Why are we taking some random numbers and assigning them into register 10 minus various things? Like, what's going on there? Well, if you look at the register information about EBPF, register 10 is a stack pointer. So when we're indexing backwards from it, we're pushing memory onto the stack. So we're loading something onto the stack when we do this from instructions. Why? Well, that's our string. So if you take a look at the values, and I appreciate most of you probably can't read ASCII kind of by heart, I can't. So if you go through and you decode it, that is our string. So that's where the string comes from in this case. Which leads me nicely on to, what about the thing I said I was going to get back to? What about BPF no global data? Well, if you don't use it, what happens is the compiled binary, compiled object file, I should say, has an extra section called RO data. And if you look in RO data, well, there's our string again. And if you look at the instructions, the string isn't there. But we have a little warning from readelf saying there's relocations that haven't been applied. So what's that? What happened? Well, if you output the instructions, we can see that now instruction ID number 2 there is just pushing 0 onto the stack, which is a bit weird. So why is this happening? What's it doing? Well, if we look at the relocations, which is another section that got added, we can see there's a thing here with like an offset and a type of symbol value and some other information. To cut a long story short, you can ask it to apply the relocations for you, and it tells you here that there is like some data that needs to be pulled from RO data. So what this means is that if you compile EBPF like normally without this flag, then the constants are actually split out into a different part of the object file, and the thing that loads them into the kernel needs to create an EBPF map, and we don't have time to go into maps in detail, but creates a map. It will push all of the constants into this map, mark the map as immutable, and then it will change the bytecode before it loads it to reference the map it needs to load from. Which means in most cases, the EBPF you're actually loading into the kernel is different from the EBPF you actually compiled, slightly. Which really blew my mind when I found out about that one. So yeah, that's why I've got this in here, just to make my loader a bit simpler. So, we've compiled some code. That's what we actually got out. Let's actually load it into the kernel and do something useful with it. Again, a library would make this 2 lines, if that. Like, we're really doing this the hard way here. So don't do what I'm doing if you're really trying to do EBPF. So, we need to do 3 things. We need to get it into memory. We need to get it into the kernel, and then we need to tell the kernel to do something with it. First thing, we're going to write everything in C, just because it's slightly easier, and it's easier to interact with raw syscalls this way. First thing we're going to do is we're going to open our object file. So I've hard-coded its name here. This is why a lot of EBPF programs will let you specify the name of the object file. This is why. We're going to call open, which is going to get us a file descriptor. Aside, what's a file descriptor? It's just a number. It's usually a very low number, like 3 or 4, but is that process's mapping to a file or an open thing. This is relevant because it's going to come up quite a lot when dealing with EBPF is file descriptors. So we get a file descriptor to a file. Then we're going to use this function called elf_begin in order to start reading our elf file. You might wonder what on earth that is. This is from a utility called elf_utils, which helps you reading an elf file. It's nothing to do with EBPF, actually. It's just for the elf file format. And it saves us having to like offset into the file to try to read it manually. So what we're going to do is we're going to get the elf main header, and then we're going to go through and parse it by sections, because remember that file had sections, and the main header tells us where they are. So all we're going to do is we're going to loop over every section. We're going to get a pointer to the section in memory. We're going to grab its header, and we're going to pull its section name out as a string. Also, for those of you less familiar with C, you might be wondering what all this like char star is about. That's a char pointer. C doesn't know what a string is. So instead, we have pointers to chars, and a character is just a single byte. And if you want to come talk to me about Unicode and byte encoding, come find me later. And most functions in C will operate on a char pointer until they hit a null byte, which is kind of a null-terminated string, or they specifically take a length of a string, or they segfault or cause a security problem or something else. So that's why it's a char star. And then we just compare it with .text, and if it's .text, we pull out the data. So what we're doing here is we're iterating through the sections, we find the one called .text, and we read its data into an ELF data pointer, and do some error handling. So we have it into memory, nice and easy. Now we need to put it in the kernel. To do this, we use the BPF syscall. This is kind of the one syscall that does pretty much everything with eBPF, is the BPF syscall. We pass it in a command and a kind of block of attributes specific for that command. And the command that we want is BPF progload. So obviously we load and verify a program into the kernel. The structure we need to give it looks like this. This is from the BPF man page. We just tell it a few bits of information, and we're going to step through this in a second. So we know what we need to give it. So let's do that. First thing we're going to do is we're going to give it a log buffer. So syscalls can usually only return an integer, and if you want some feedback about why the verifier has told you it doesn't like your code, we're going to need more than that. So the way that we achieve this is that we allocate some memory, 10 kilobytes in this example, and we're going to give a pointer to that to the BPF syscall so that it can write a string output of how it verified things and how it loaded things and the error messages into that buffer, so we can see it later. That's all we're doing. Next, we're going to talk about the license. Licensing in eBPF is important because if your code is GPL, it can access, or GPL compatible, it can access certain helper functions, and if it isn't, it can't. In this case, this is dual BSD GPL, so it's GPL compatible, so no problems. But you need to tell it what license it is. Next, we're going to give it the instructions. You might be wondering what a BPF inst is. This is just a struct that maps kind of in a single instruction into that structure we talked about before. And if you take the example of our first instruction from last time, you can see this is how we would index into it. So if you index it into it by bytes, you will just get the individual bytes. Where if you index into it by instructions, you'll get whole instructions at once, and then you can do like .code, .off, whatever, in order to get information. So it's just a useful way to be able to parse things. So what we're doing here is passing in a pointer to the instructions in memory, and we're telling it how many instructions we think there are, which we do just by dividing by the size of an instruction. And then we're going to tell it it's a tracepoint program. Then we're going to do the actual syscall. So we're going to call BPF. It's this syscall thing up here. There's no like wrapper function in glibc for the BPF syscall, like there is for open and things like this, so we have to call it manually, not a problem. We're going to tell it it's progload, and we're going to give it our attributes, and then we're going to do a bunch of error handling, which is what we're going to wrap up the log, we're going to handle errors if they happen, and give the FD, because this will give us back the file descriptor to the BPF program if it's successful. Great, we've loaded it into the kernel. What did that do? So this is where we're going to kernel source code. As a note, I did all of my research for this on the 6.1 kernel from Debian 12, so there might be slight variations, but broadly speaking, this is how it works. The BPF syscall does a whole bunch of stuff. It's going to do some permissions checking. It's going to make sure that you have those capabilities, you know, those ones that you set all on your containers. This is the one that will check that you have that. There's some edge case checking for some stuff I'd never thought about, as if like you're using different kernel versions with different versions of attributes. Then we're going to copy the attributes into kernel memory, and then we're going to ask the security subsystem. So if you're using AppArmor or SE Linux, this is where that check happens in the kernel to make sure you're allowed to make this call. Then there's a massive switch statement, which just switches on all the different things a BPF call can do. And this one is ours, the BPF progload. And if you follow that down, I'm not going to copy out this entire function because it's extremely long and does a lot of stuff, but some interesting things it does do is license checking. This is where it decides whether or not your license string is GPL compatible or not. It's going to allocate some kernel memory for your BPF bytecode, and then it's going to ask security about this again once it's done that. And then it's actually going to copy everything over. This means that if you load an EBPF program and then change it in your program's memory, it doesn't matter because it's been copied over into the kernel. We're going to specify the JIT hasn't happened yet, which we'll touch on in just a second, and various other things like that. And then, three very important things. We're going to run the verifier, we're going to run the compiler, and then we're going to allocate a file descriptor. The verifier, I really do not have time to go into like full detail on it. It's an entire like talk by itself, but in short, it will just exhaustively check statically that your eBPF code isn't going to get into an infinite loop or isn't going to access memory it's not allowed to. All the things that would cause your kernel to misbehave, and the whole reason why eBPF is better than writing a kernel module. Once we've done that, we're going to actually run the just-in-time compiler down to the machine code of the thing you're running on. So this is a platform-specific thing, necessarily. It ultimately calls BPF into JIT compile. And if you follow this down, here's the x86 example, just to give you a taste of how this works. You can see, ultimately, we are just doing a switch statement on EBPF opcodes and emitting x86 opcodes that look equivalent. So you can kind of follow this down. So this is a kind of a bad way of doing this, I've been told by many of my colleagues, but you can turn on a debug flag in your kernel to make it emit to the kernel log the JIT kind of compiled bytecode when it compiles anything. So if you set this on, then you load some EBPF. I got this out as my output. And there is a helper program called BPF JIT disam, which will disassemble this so you can read it. So this is, in my case, x86-64, because that was my test environment, assembly code equivalent to our BPF code. And we don't have time to go into like x86-64 opcodes, but you can see the general thing. We're calling a function, which is probably going to be the first helper function. We're loading the string in a very similar way, and we're calling the helper function. So it's ultimately a very similar structure, just expressed in the way that the actual processor in this machine will be able to run it. By the way, you can use a BPF tool to do this a lot easier, rather than having to do this like janky debug method, but there's a good way of doing this. So that's what that does. So all of that happens when you've loaded the program. We haven't even attached it to anything yet. Now we need to actually attach it, which is the last step. We're going to put it on a trace point in our case. The BPF man page will helpfully tell you that the method of attachment is entirely dependent on what you're attaching it to. In the example of a trace point, we need to get a reference to its, we need to get a file descriptor to it first. The way we do that is we are going to read this file, which is in syskernel debug tracing event syscalls, sysenter xsieve, which is the syscall we want to enter on. That's the trace point we want, ID. And in this file is the string representation of its ID, which is what we need. So all we're going to do is we're going to open it, and we're going to read it in, and then we're going to use A2I in order to parse it as a string into an integer. So relatively standard stuff here. Then we're going to make another syscall called perf event open, and this is the one which will actually create the trace point. So we're going to give it the trace point ID we want. We're going to tell it that we want a perf type trace point, and this will give us back a file descriptor to that trace point that we've created. The perf subsystem in Linux is an entire system by itself that more or less only coincidentally does eBPF. It does a whole bunch of other performance monitoring stuff, which again, we can't go into. But the important thing is that it gives us back this file descriptor, and then you can use that with either IOCTL or PRCTL, which is good because we're using IOCTL. So this is our final syscall. We're going to do IOCTL. We're going to give it the trace point ID. We're going to sell it perf event IOC set BPF, which assign the BPF program to this trace point, and we're going to give it the FD to our BPF program we got from the BPF syscall. But what does that do? Well, if you follow this down, we are going to ultimately call perf event set BPF prog. That is going to then ultimately call perf event attach BPF prog, and to cut a very long story short, effectively, this adds a reference to that eBPF program in the kernel to the trace point. And the way syscalls are executed is platform-specific, but that platform-specific method, if a trace point exists for a particular syscall, will be modified, so it will ultimately call into the tracing subsystem, and then that will invoke the eBPF call before it actually executes this syscall. So there we go, we've attached a trace point, which means, at long last, we can compile our code. We can compile our eBPF code. We can compile our loader. We can run it as sudo, of course. We can get a bunch of output, and then in a separate terminal, we can get our tracing output, which can tell us it's our syscall. And that's it. And I have a bunch of references and special thanks and those sort of things.
At some point, you said something that I found super exciting about how eBPF was safer than writing kernel code, and just that sprung this question: are there parts of the kernel that would make sense to be rewritten in eBPF, or is that just silly talk?
I mean, I'm not a kernel core developer, so I don't really know what the attitude to this is. The one of the big justifications for eBPF was that if you want to extend its existing functionality, your choices boiled down to getting a patch accepted into the kernel, which took a long time. You had to wait for it to be percolated into main distributions, or write a kernel module, and you can quite easily crash things if you do that, and trying to compile them, you have to do it for a specific kernel. It was complicated. So eBPF was designed as an easy, pluggable way to get new features into the kernel without having to go through all that. Whether or not we should go down the route of rewriting stuff, I don't know. It's certainly a very fast way to get stuff in. That's good.
Hello, I would like very much to appreciate the navigation, which language you are talking about in the upper right corner. This was very helpful for me because I was confused in a few slides. But I wanted to ask about very high-level question. If we do have a bytecode that is eBPF, how can we validate if the kernel version is supported? This is when it is inserted through the validator to kernel. This is the step that would break at this point if the code is not valid for my particular version of kernel, or is there a tool to do it?
So the way I compiled it there was specific for my kernel. I gave it my kernel headers. There is a whole body of work, which is like co-re, which is around compiling kind of generic eBPF bytecode for a kernel. That is way beyond the scope of what we can go into here. But it's something that's definitely been worked on. It's something that is possible, just not in this very simple way that I've written it.
Okay, so the way you showed means that this is just for the specific kernel version. Oh, okay.
Yeah, this is the dumbest way possible, which means that it is specific to a kernel version.
Still pretty cool, to be honest. But if I would try to run this on a different kernel, in the validator step, when I would try to insert the code into the kernel, that would break? Is that the point, or would
if it's been compiled for a different kernel? So if you compiled it again for your kernel, then it would work. If you compiled it for a different kernel, like it's part of the stable Linux kernel API are those like functions that we call the helper functions. So this particular eBPF program is relatively portable. You just need to compile it every time. If you're going against like extra kernel functions, or you're doing kprobes or things like that, those aren't as guaranteed to be stable between kernel versions.
Okay.
Anybody else? Time for one more.
Thanks for the talk. I've seen that you had, like, with the licensing stuff, this was like kind of necessary to get that running. Is that correct?
I think in my example, the functions I was running weren't GPL required, actually. So I probably could have done mine without GPL, I think. But there are a lot of very useful... You need to... Oh, okay. There you go.
Okay.
Live with no. Yeah, no, I needed it.
And the actual question was like, how do you take care of the exception handling? Is that the part where you said, okay, the verifier takes over on that? Or how you make sure that the kernel is not compromised by the code you're writing there?
What if I try to load code of the wrong license?
Yeah. Or anything else, or even with a...
I believe the verifier checks.
Okay.
I think it's a verifier that will make sure that you don't call the GPL-only helper function if your code is not GPL compatible.
Thank you very much.
Great. Thank you so much, James. Really fantastic. like on time.
I'm gonna bring it back. I'm gonna bring it back.
All right.
Yeah. Oh. Meow 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 meow. Here we go. All right. Ow! So that's weird, but hey, so hey everyone. This is a sponsored keynote yet again. This is it's a little talk I like to call OpenSSF Scorecard. Wow! Oh my God! Rejekts edition. Here we go. So have you ever? I'm going to do a little audience participation, hopefully. So have you ever thought about using a project? I think James's talk was a great example of, hey, here's all this crazy stuff I did. Don't do that, right? So like pretty much every time I think about writing some code, I say to myself, do I actually have to write this? Someone smarter has probably written it in the past, right? So one of the things I consider is it safe? And like, show of hands, like, what do you think about when you're trying to pick up some code? Is that something that you consider? Anybody? Cool. Thank you. So what do I mean by safe? And I think we're all going to have a slightly different definition of safe. For me, and I think in my role, there are a lot of things that I consider, right? Is the project licensed, right? And EBPF is a good example of looking into like, oh, we've got licenses for things, so we can do X, Y, Z, right? Is the project maintained? This one's big for me. Right? Am I going to be able to pick up this project and know that it's going to have some support long term, right? Do we have a security policy? Are people actively reviewing the code? Are we running CI? Are packages being released? Do we have contributors actually from different organizations? I know this is a hot topic if you've heard of a little thing called the Cloud Native Computing Foundation. And is the project maybe attesting to the fact that they're secure or good, right? Whether it's hey, we do our code real good, we do all the linty things, hey, it's here's a best practices badge, et cetera, right? So these are the quick things. These are things that I feel like you could probably figure out in a few minutes, right? And then we go a little deeper, right? It's stuff that you can do on a quick investigation, right? If you know exactly where to look, right? What about vulnerabilities? Are we signing the releases, right? Are we updating dependencies? Do we know how the project is updating its dependencies? Are they pinning dependencies? I know, again, this is a hot topic, but we're not. Static code analysis tools, right? And checked-in binaries, right? All kinds of important things that you might want to consider if your project is it safe to use, or is the project that you're considering safe to use, right? And then we go even deeper. And these are things that you might not be able to discover about the project because you're not a maintainer, right? Maybe you need to be behind the wall of understanding what security vulnerabilities are out, like what advisories are open for the project. Is the project using branch protection? What's going on with like coding patterns, GitHub workflows, et cetera, et cetera? Are they using the right workflows, right? Is the project doing fuzzing? Some of the fuzzing information is, again, kind of behind a login, right? Chats about webhooks too, right? So, show of hands, does that seem like stuff that you care about? He's like, oh, come see, come saw, right? So, I have great news for you. Have you met my friend, OpenSSF Scorecard? This is a tool that will automate some trust decisions that you might want to make for projects that you're considering and for projects that you're releasing. Right? So if you go to scorecard.dev, we've got a very lovely website that's been put together. Also github.com/OpenSSF/OSSF/scorecard. Give it a second for cameras and everyone again. Okay. So who am I? Some of you may know me, but quick highlight reel, I guess. Stephen Augustus, head of open source at Cisco. I'm an OpenSSF governing board member. I'm a Scorecard user and maintainer. I'm currently one of the co-chairs for Kubernetes SIG release and founder of the release engineering subproject and reasonably competent release engineer, right?
And if you want to view more about what I do and what I'm up to, and it's that is actually not relevant here, whois.augie.dev. Now, I mention all of that. Because all of those roles, and I'll go back for a second, all of those roles have me thinking about how to release code safely, how to use code safely, and especially as working on outbound open source. I was looking for a project that was going to be able to automate a lot of the process that my team spends before we release code at Cisco, right? So this is seeing folks from Google's OSPO work on this, seeing folks from Cisco's OSPO work on OpenSSF scorecard, as well as lots of other OSPOs kind of like poking around the edges. So I have a few humble requests if scorecard seems really cool and hot for you. One, provide us some feedback. I'll leave this up as my clock runs down. So there is a link available on the README at github.com/OSSF scorecard for a survey. We're looking to do some analysis of personas and actually build in what people want out of this project. And then second, if you are attending Open Source Summit in Seattle, we've got a day of fun activities planned. It's Sauce Community Day. Get lost in the sauce. It's a Securing Open Source Software Community Day, and we will be doing a new contributor workshop for OpenSSF scorecard, as well as lots of fun like security incident response tabletop exercises. So if you're into that kind of stuff, and I know a lot of you are security-minded, please come check that out if you're attending Open Source Summit Seattle. Thank you.
Break until 11:10. There will be 2 talks going on at 11:10, one here and one upstairs in the VIP room. So,
thank you.
And we're live here with Nick Young. He's going to be talking to us about common errors in CRDs and how to avoid them. Nick, I'm going to give you 2 extra minutes because we're actually starting 2 minutes late.
Oh, okay. Thank you.
All right, I know.
You're very kind.
Generosity.
Yeah, you are.
It's all about
Generosity personified. That's you.
Take it away.
Hi, everybody. My name is Nick Young. I am talking to you today about why you shouldn't do what Charlie Don't does. Exactly why I'm using that, I will explain in a minute. But yeah, so I want to talk today about avoiding anti-patterns in CRD design. I'm going to try and keep it a little lighter by using this guy, Charlie Don't. But before we do that, so who am I and why should I be talking about this? I started using CRDs early in 2017 when they were called third-party resources before they got renamed. I spent a long time building out Contour's HTTP proxy resource that replaced the other CRD Ingress route, and I have been involved in Gateway API since its inception at the start in KubeCon San Diego. So I have been doing CRDs for a long time. I have made many, many, many mistakes, some of which are still extant in the Gateway API. So I'm trying to, I mean, we're human, we make mistakes, but what I'm trying to do is to make it so that not as many people have to make the mistakes that I did. So, but why all this business about Charlie Don't? Well, I'm thinking The Simpsons. So in this episode, Bart gets a knife and he's reading the 10 do's and 500 don'ts of knife safety, and he has a whole section called Don't Do What Donnie Don't Does. And so, I really liked the alliteration there, and so I wanted to, present you with the 10 do's and 100 don'ts of CRD design. No, I'm just kidding. But what I am going to present you with, oh, hang on, it is not updating. Come on, you can do it. There we go. So what I am going to do is walk through some CRD design anti-patterns using Charlie Don't. You see how I've chosen the name carefully to have the letter CRD in it, as our strawman, and I want to give you some tips about how you avoid it. So, why is this showing on my screen? There we go. Okay, so this is Charlie Don't. Charlie works on a custom controller for Kubernetes at BigCo. He has the worst luck and always manages to choose the absolute worst design option. So, sucks for Charlie. But benefit to everyone here because you get to find out from his mistakes. So, let's learn about what Charlie Don't. So, Charlie Don't doesn't know about the API conventions and API changes docs. These are the most important docs for Kubernetes API design. There are 10 years of API design experience relatively condensed into only about like 10 to 15,000 words for you to read. But it's a lot of text, but it's really, really, really dense, very good information. That is the basis for most of what I'm going to tell you today, right? Like, I am standing on the shoulders of giants here. I have injected my own personal experience where possible, but really, if you are doing CRD design, you need to have these 2 links bookmarked, and you need to be like referring back to them often. I do all the time. So, but Charlie Don't also doesn't stop to figure out how users are going to use the CRD. If you are building a CRD for a controller in Kubernetes, this is the #1 thing you've got to think about, right? Like, at the end of the day, a CRD is about the people who are going to use it. If you are not making your thing such that the people who are going to use it find it easy and want to use it, then your thing will not be used, right? Like, this is basic humanity. The questions I like to ask myself are, if I was using this, how would I understand if it's working or not? And another one that I like to use, I call it the troubleshooting distance. It's how many kubectl commands would I need to type to understand what's going on, right? Like, and you want that number to be 1, right? Like, that's the ideal number is 1. You type 1 kubectl command and you're like, oh, now I see why this thing that I just didn't work. The 1 kubectl command told me exactly what I needed to know. But, so thinking about your users. So you want to use spec and status unless you have a very good reason not to. Spec is the intent that your user wants, and status is the result that they have got. You don't need to use status when it's used as an input for another thing like secret and config map, or when the intent and the result are stored in separate objects like persistent volume claim and persistent volume. Those are perfectly valid patterns, but almost always, if you know why you need those things, then you know why you can ignore what I just said. So, like, yeah, I think it's really important I think that VS Code thing is going to stay there bouncing for the rest of the thing. I'm sorry. Lesson for everybody, make sure you close out of everything before you start your presentation. Status should also have a condition standard using the condition type. Now, you'll see conditions in lots of parts of the API. Nodes have conditions, pods have conditions, a bunch of other stuff. They are a list type map, which is it's a list of objects, and they are a map by type. Okay, look, it's bothering everyone, it's bothering me. Go away, thank you. Okay, sorry. Okay, so conditions are a list of objects where they are effectively a map by the type field in the object, right? So they have a type reason and a message field. The type is something like, on a node object, you have, out of memory error, or more often, most things have a ready condition that just says everything is okay, situation normal, you have nothing to worry about. If that condition has status false, then you know that something has gone wrong, and you need to look into exactly what the problem is. So yeah, you should, when you're making your own CRDs, you should also use this pattern. It's a really easy way. People know to go and look at the conditions. People have started building tooling around parsing conditions, and it's a standard upstream struct that you should use. One thing that is optional that you should also use is the observed generation field. This takes the auto-incrementing metadata.generation field from every Kubernetes object, and the rule is when you set observed generation inside a condition, what that does is say, this condition is relevant for generation X of this object. So it's like a staleness check for the status. And so that means that when you look at the status, you can also look at the object, because you have to get the whole object to get the status. You can look at the metadata generation field and the observed generation, make sure they match. If they don't match, then the controller either is broken or hasn't reconciled that object yet. So it's like a checksum that lets you know that the status you're looking at is up to date. That's why it's really important that if you're writing a controller, you should use it. And so because conditions are a standard, there's you can write tooling that will duck type them. Duck typing is when it looks like a duck and quacks like a duck. And so you can take a condition stanza and write tooling that will look for status.conditions and parse any object that has the field status.conditions in this thing, and you can write tooling that will print the conditions for you. Okay, so next one. Come on, I need my picture of Charlie. I went to a lot of effort to make Charlie. So Charlie don't makes all fields required. When a field is required, you always have to specify it on input, and fields are required by default. Now, if anybody has ever written a Kubernetes YAML, you should understand why having to specify every single field every time would completely suck. Nobody wants to have to specify the things when every field, when probably you may only a couple of those fields will be relevant to what you're actually doing. So what you should be trying to do is to make as many fields as possible optional and consider adding a default value. However, the default value thing is a little bit tricky because it also depends on whether or not the zero value for a field is meaningful. So for some things, say you wanted to have a, close to near and dear to my heart as a timeout field. If you want to set the length of a timeout in seconds, sometimes a value of 0 means don't have a timeout or disable the timeout. Now, for a Go struct, if you have an integer field, then a 0 is the empty value. So if you don't supply in that case, if you set the field as optional and you don't set a default, then the default value will be don't have a timeout. Probably you don't want that. So in that case, you should probably look at adding a default. Now, there is an important point about pointers, is that if you have a field be a pointer, that lets you have like 3 effective things. Not set to the 0 value, or set to some other value. And so that can be really relevant for when you're designing a thing. If you want to have a distinction between unset and set to a 0 value, then you should use a pointer for that field, for a basic field. Okay, that was a bit in depth. Sorry. But now there's another great thing about making fields optional, and that is that you may have noticed that lots of fields, when you do the JSON tags, you can put emit empty inside the JSON tags for a field. Those two fields imply each other. So if I make a field optional, Kubernetes will automatically make that add emit empty to the JSON tags for that field. And if you put emit empty, then it makes the field. Then Kubernetes will make that field optional. Technically, optional means you don't need to put this in on input, and emit empty means on output, if there's nothing in here, don't output the field. And the idea is here that if you want one, you basically always want the other. And so that's why Kubernetes will just do that for you. Okay, so let's talk defaulting. You can set defaults for any optional field. You can set defaults for a required field, but they will never do anything because you have to supply a value on input, so there's no point supplying a default value. When you're using kubebuilder annotations, you just use plus kubebuilder default. Setting defaults for scalar values like strings and integers is reasonably straightforward. Actually, one of the sort of slightly hidden rules is that you probably should consider not using an integer value unless you really need to, because parsing of integer values can be weird. You're better off using a string that you then parse into an integer later, most of the time. But you can also set defaults for structs, which includes values for fields inside those structs. So in Gateway API, we actually use this for Gateway. You can see this is the default for Gateway status for conditions. We add 2 conditions by default, type accepted and type programmed, with a message of waiting for controller. That's because every controller that implements a Gateway API is expected to touch these conditions and update them once the gateway is reconciled. And so once your controller Gateway API implementation has touched the gateway and has reconciled it, you have to update these 2 things. That's why we populate them always, so that, again, going back to making your users understand how the thing works, if as a user you look at a gateway and it still says waiting for controller, then no controller is reconciling that gateway at the moment, and you've probably made a mistake somewhere. And so again, that's where this sort of thing comes back to. As an author, as you can see, it's super verbose, right? It kind of sucks having to specify it like this, but it's better to be able to specify it, trust me, than not being able to specify it at all. Okay, where are we at? So, okay, this is one of my favorite, most esoteric things about defaulting. And we need to talk for a little bit about storage in Kubernetes. So when you create a Kubernetes object, the object at some point is persisted into the storage version inside etcd. Okay, that's like step 1. When you do that, any field that is defaulted is not actually saved into etcd. So if I have a timeout field, to use that example again, and it defaults to 10 seconds, and I don't specify it, stored in etcd, there will be no timeout field stored. When you when you say, please get me this object, Kubernetes will give you the timeout field set to 10 seconds, but it's not actually stored in etcd until, or while you leave it unspecified. However, if you get an object and say, oh, I'm going to get this object, and now I'm going to make a change in some other field, and then you put the object back, because Kubernetes gives you the defaults, when you put the object back, you have now taken that default and set it as a value. And so now that default has been sort of crystallized into an actual value, and Kubernetes has no way of knowing that you actually just wanted the default. So this is like a real classic gotcha about defaults, is that if you set them, you have to kind of assume that at some point someone's going to poke the object, and that default is going to get crystallized in there. So as an author, if you update the default, some resources may change their default value, and some won't, because it depends on whether or not they've been accessed and had an apply cycle put to them. So this is one of those things that I like to tell people and watch them sort of go, oh, what the? But yeah, so defaults are not always defaulted, right? Like, so as a CRD author, you need to know that when you set a default, it's kind of like more of a guideline, right? Like that you can't guarantee that every value that used to be the default is actually going to be updated when you update a default. Okay, so the most important thing is updating the default changes the value only as long as no one's read it out and put it back in. Okay, so Charlie also doesn't structure his data enough. So this goes back to, if you actually look at the API conventions, there's a section called, I can't remember the exact name, but if you go back, it goes back to like an issue in Kubernetes that's like number sub 1,000, right? Like, so sub 1,000 in KK is very old. And this is a discussion by a bunch of people who were making Kubernetes in the early days being like, okay, so we need to be able to have arbitrary fields, and what sort of fields are good and what sort of fields aren't. And I think it was Joe Beda who said, we want to preserve the invariant that every value on the left of a colon is a field name, not a value. And so what that means is, what it comes down to is, don't use map string anything, right? Like, generally. You shouldn't use a map string, a map of mapping string values to something else, except for annotations and labels. That's the only time when you can use a map string in any Kubernetes object. Otherwise, it's very hard to tell as a user, is this a map or is this like an object that's a struct that now has string values on the other side? There's no way as a user for you to look at the YAML and tell. Using this convention means that you never need to ask that question. The way that you need to map is you use list type equals map and list map key equals field. And looking at this slide, I really probably should have given you an example of what one of these looks like. But what this does is you have a list of objects, and each object has a set of fields, and you say, okay, this list is actually a map, and the map key is one of the fields. So conditions are a great example, but what the most important thing here is that if you push a new object, a new element onto that list, and it has the same key as an existing entry, the new one that you just pushed will actually overwrite the old one because it's a map. Right? The API server treats it as a map that just happens to be stored as a list. And so it's really useful to be able to do maps, but it also means that when you deserialize the map, you actually get a list. So you need to look for fields that look like this when you're using them, but when you're writing them, it's really handy because it means you can actually make a map without actually having to violate that invariant. Okay. So, have I lost anybody yet? Are we good? No, we're good? Okay. Thanks for the vote of confidence, as always, Stephen. Okay, so Charlie Don't uses bool types and bounded enums, with the reason being both of these types are super hard to extend. Poor guy, it makes all the wrong decisions. So, bool fields. Every time you think you want a bool, you don't. Right? Like, you don't actually want a bool. What you actually want is a choice between two options, right? Like, almost every time you want to put a bool inside a CRD, you're saying, do behavior A true or do behavior A false. But when you're not doing behavior A, that means you do want behavior B. So the much better thing to do is to have a string field and just explicitly say behavior A or behavior B, right? Like, or setting B, setting A, like you can make this as just a string field. I say use an enum subject to the caveats I'm about to say about enums, but which is really what you want is a string field with a set of constants for the different values that you could possibly choose, because then you can add more values. So, about that, let's talk enums. So, if you supply an enum with a set of fixed values, technically adding a new value to that enum is an API breaking change, and guess what? You now need a new API version. That is a very big deal. Adding a value to an enum means you need to go from v1 alpha 1 to v1 alpha 2. Now you have two types of resources you need to watch. You have a storage migration to do. You have a bunch of different Go structs you've got to do. It's a very big deal. You don't want to do it, right? So you want to keep your changes backwards compatible. Now, so the way around this is when you make an enum, instead of actually making an enum using a kubebuilder directive or an open API thing, you just make a string field and you say the only values for this are the following values, and then you supply constants for all of those things in your Go types. When you do that, and as long as you say, hey, this enum is not bounded, we may add new values later, you need to handle unknown values here. If you do those two things, then adding a new value to that enum is no longer a breaking change because it's not actually an enum, it's like a pseudo enum. So this one burned us pretty early on Gateway API. We had think it was the protocol field that we had to sort of walk back when we moved from v1 alpha 1 to v1 alpha 2. That was one of the changes we had to make. We had to like change the protocol field in the Gateway API listener from being an actual enum to doing this, typed string with constant supplied value, and it sucked. I really don't want anyone else to have to do that. So please remember, use a string alias as the type. So type some setting string is your type definition, and then provide constants with all the correct values as part of your definitions. That is the way to do this safely so that you can add more constants later. Okay. Now, this one is a favorite of mine. Charlie Don't allows arbitrary cross namespace references. This is terrifying, right? Like, this is like one of the worst things you can do for a CRD in terms of security, because a namespace is the most important security boundary in Kubernetes, right? Like, there are other security boundaries. You don't have to grant access to a whole namespace. You can do a bunch of cool stuff with RBAC, but practically, when most people think about Kubernetes security, the fundamental unit is namespaces, most of the time. So you can cross namespace boundaries with references if you do the right thing. What's the right thing? Well, coincidentally, in Gateway API, we had to learn how to do this because we needed to be able to do it for a bunch of things. So the only way to make cross namespace references safely is for both sides to agree that it's okay. So the person who is making the reference, the referrer, needs to make the reference, and that's the thing that starts off the process. But the person who is receiving the reference, the referent, needs to do something to allow the reference, right? Like, so it needs to be a handshake. Both parties need to agree. It's effectively a contract, right? Cross namespace references must not be allowed by default, because otherwise, I, as the CRD user, could accidentally refer to something that I'm not allowed, that the person who owns it doesn't want me to, right? Like, you need the person who owns the thing that you're referring to say it's okay that for incoming references to do this. And then the owner of the referent must have to take direct action to do this as well. You can't default to accept all namespaces. You've got to default to only take stuff within my local namespace, don't accept any cross namespaces. If the owner then chooses to say, hey, no, I want to allow all namespaces, like, that's on them. You've made it hard, you've had to jump through some hoops, but it's a valid choice for them to make, but they need to take direct action in order to do that. Okay, so here's some examples. Gateway API route to listener binding. So Gateway API has, for those of you who don't know Gateway API has gateways. Gateways have listeners and addresses. Listeners have ports and protocols, and a gateway binds an address or multiple addresses to all the listeners. Right? So a listener is like a listening port plus the protocols that are on it, and a listener is a bucket for routes to attach into to then take that port and funnel traffic off to somewhere else. So routes specify a parent ref, and they say, I want to attach to a gateway. And then the gateway has a thing on it that says, I will allow routes that look like this. And so there are two keys, a kind, which means that a listener can say, I only will allow HTTP routes, not TCP routes, or something like that. And there is a namespace selector that lets you do stuff like any namespace in this list, any namespace that matches this label, and a few other things like that. But the idea here is that the owner of the gateway has to make the namespace, take a definite action to allow this thing. By default, gateways will only accept routes attached from routes inside the same namespace. Okay, the other one is reference grant for secrets. This one is even more easy to understand. So this use case is, I have a TLS listener, I need a key pair. I need a certificate and a key, right, to terminate TLS. For this to happen, the TLS key pair needs to live somewhere. Maybe as a platform team, I don't want everybody who has access to the gateway's namespace to be able to read my www.company.com key pair, because I've paid, before Let's Encrypt, I would have paid thousands of dollars for that. But even so, I don't want people to be able to impersonate my web server. So I want to keep that in some super secure namespace, but I want gateways to be able to use that key pair without people knowing the value of the key pair. And so what we do is the gateway listener can point to a TLS secret in another namespace. There's a namespace field there. But in the secret namespace, there is this extra object called a reference grant, which the owner of the secret creates that says that the access, you are allowed to use this secret from namespaces that are called this. So a gateway that is in namespace foo is allowed in a reference grant, and then a gateway that is in namespace foo, when you try and make that reference, the gateway API controllers have to say, okay, yes, that reference is allowed, you're good. A gateway in namespace bar that tries to reference the secret in namespace, the secret that allows it from namespace foo, it says, sorry, you can't do that, you can't use that. So reference grant is a really important tool that gives you the means to be able to do the two-way handshake even in the absence of having having secrets be able to support that thing natively. Now there is an important effort going on. Oh yeah, sorry. Reference grant is actually used in SIG storage. The SIG storage folks wanted to do that for a certain type of snapshot config, but KEP 3766 is adding a new concept of referential authorization to CoreCube. Now what this is doing is it's going to be arbitrary reference grant for any Kubernetes object in core Kubernetes, right? So what it will be is that when this is complete, you won't need reference grant anymore because core Kubernetes will be able to, you'll be able to create an object next to a secret that says allow access to this secret from namespaces that look like this to users that look like this. So you'll be able to say only allow access to this secret from gateway implementations and some other cool stuff like that. So it's a really cool KEP that, my name is actually on, but I haven't done any work on it for like 8 months, because, bandwidth. But Rob Scott and some others are doing some really interesting, cool work there. And hang on, there we go. There is the QR code for that, for the PR that is currently working on updating that KEP. Okay, so we are down to near the end here. Charlie don't makes breaking API changes without incrementing the API version. Man, this is like one of the worst things you can do, right? Like, so please don't do this. But the API version is usually something like V1, V1 Alpha 2. Now, I tried to write this down in as short a way as I could. A change is not breaking if a valid object after the change was also valid before the change, assuming you discard unknown fields, right? Like, basically, if you add a new field that defaults to doing nothing, then that's not a breaking change. If you add a value to a field that, if you don't know about it, doesn't do anything, that's not a breaking change. But the exact list of all of those things is really complicated. That API changes doc is a few, like many thousand words, all about exactly what constitutes non-breaking API changes and how you should do them. But yeah, here's some examples of breaking changes. Adding a new required field. I mean, seems pretty obvious that that would be a breaking change. Adding a new field that changes the meaning of an existing field. This one is a bit subtle. So if you add another field that says, oh yeah, that other field that timeout field that you added, it now means client timeout, not backend timeout, right? Like, that is a breaking change because you've changed how the API works. But one that has caught us a couple of times is that tightening field validation is a breaking change, but loosening it is okay. Because if you tighten the field validation, then values that used to be valid are no longer valid. If you loosen the field validation, then values that used to be valid are still valid, right? So the lesson is, when you are doing field validation, make it as tight and as small scope as possible, so that then, if you need to loosen it later, you can. Okay, and that's the API changes doc. Okay, why is that? Okay, let's recap. Okay, things are working. So, read the API Bibles. Again, I've harped on this, but it's for a good reason. Think about how your users will use the CRD, use status and status conditions. Make as many fields as possible optional, with defaults if you can. Avoid maps, except for labels and annotations. Use list type map instead. Avoid bool types and boundary nums. Avoid cross namespace references. Make them a handshake if you do use them. Hopefully, soon, KEP 3766 will be in and you'll be able to just use that. Don't make breaking API changes without an API version bump. Because an API version bump is such a big deal, basically that translates to don't make breaking API changes. You can, you just got to be careful. So, questions? And thank you.
Thank you very much. As someone who wants to get started with authoring CRDs now, I go home, I have this talk in mind, and I'm sure I will make half of those mistakes anyways. So especially regarding breaking API changes, is there some tooling which statically checks whether common mistakes have been made or anything?
I would love for there to be.
Okay.
It is a wish list of mine to build something like that, but it requires an amount of bandwidth and time that I have not had. But yeah, there should be, I agree. It would be really nice.
Thanks.
Yeah.
Any other questions? No? Okay, great. Thanks so much.
Thanks
Nick.
very much, everybody.
All right. Up next, we've got Victor Farsik and Whitney with another Choose Your Own Journey. Fantastic talks. While they get set up, just so that everybody knows, if you have luggage or bags of sorts that you've brought with you, or you know somebody that does, there's some space just around the corner here where you can leave them this afternoon. Victor and Whitney are going to take us on a Choose Your Own Journey adventure into production. If you haven't seen their talks, they are fantastically fun. So they'll get started in just a minute.
Passage to production. Now, full disclosure, we didn't get rejected from KubeCon. We're going to do the next chapter of this talk at KubeCon on Wednesday, so this will be continued. But we're some pinch hitters, I think, for someone who dropped out. So here we are. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users. And today, right now, we're going to help Hero live their dream. We're going to help Hero navigate hundreds of CNCF projects, maybe not all of them right now, and choose the ones that we are interested in learning more about, integrate them with each other, and get Hero running in production. I am Whitney, this is Victor, and together we host a show on Victor's DevOps Toolkit YouTube channel. Our show's called You Choose, and in every episode we help the community make a system design choice. So we gather all the relevant technology for that choice. We invite experts on to present about each technology. They only get 5 minutes to present, and at the end of the episode we call for a vote, and whichever technology the community votes for is what we implement in our ongoing demo. So, for example, our application source code needs to be a container image. We presented about these texts. The community chose cloud native build packs, and then we leveled up into a container image. Once a container image, we needed to be in a registry. We had these to choose from. Community chose Harbor, and then we implemented Harbor in our demo. And that brings us to today, right now. Get your phones out, scan this QR code. We are in a basement, so when we practice this, it may take a while for it to come up. Worst case scenarios, we'll do a show of hands. But get this QR code, and we're going to make system design choices today and build a live demo today based on what you choose. So we're going to provision a production cluster, we're going to configure synchronization with GitOps, we're going to implement Ingress, and we're going to define and deploy our application. So let's do this. Let's help our hero live in production. Look how happy they are. Aha! So first we're going to provision a production cluster. Our choices are, oh man, I'm having trouble with this clicker. Okay, our choices are Crossplane and CAPI, Cluster API. So first, why do we even need a technology to help us provision a cluster? Well, no matter where you deploy to, whether it's the cloud or whether it's on-prem, no matter what bootstrapping tool you use, it is complex. We have to worry about node sizes, subnets, VPCs, cluster authorization, node groups, roles, come on, policies, security groups, gateways, route tables. It goes on and on. So no matter which tool you choose here, it's never not complex. So then we need a tool to help us manage the complexity. And what else are we looking for exactly? So what we need is definitely we want to define our clusters declaratively. And more specifically, we want to define them using Kubernetes resources. So then we have the benefit of the Kubernetes API that's always making sure our desired state is in sync with our actual state. It also has the benefit of you can use any other tool in the Kubernetes ecosystem, like, you know, a GitOps tool. Spoiler alert. So first off, we have Cluster API. Cluster API is a focused tool. It does a great job. You define what you want your cluster to look like with Cluster API resources, and there are providers. It's going to provision that cluster for you, and also you can manage the cluster lifecycle. It works with all the major bootstrapping tools, all the major cloud providers. It's excellent. Then we have Crossplane. With Crossplane, you can take any API on the planets and pull it in and interact with it via the Kubernetes API. So that can do some really cool things with that. For one thing, with Crossplane, you can, well, you provision clusters with it, obviously, it is one thing, but you can provision all sorts of things. And then you can present it behind a simplified interface. So you can offer a really simple API that does some complex stuff in the back. And then with Crossplane, you can also make compositions of resources. You can provision not only a cluster, but that cluster has a database, and it's already running Knative, and it's all together, hidden behind one simplified API for, say, developers to use. So those are our choices. Crossplane, it's great, but there's a lot of complexity to deal with. And a Cluster API, which is also great and much more straightforward for our purposes. And so let's see how well our voting works. And if it doesn't work, we'll do a show of hands. I love how you haven't said a word this whole time.
I'm wondering, what am I doing here? I'm unsure, kind of like, why am I here? And by the way, your choice is going to get me fired.
You know.
I see, that's the design. Okay.
All right.
Well, if anybody's hiring, I'm available after this session.
All right, the people have spoken, Victor. Cluster API. Let's see it.
Cluster API. Can I reject? No? Okay, Cluster API, right? So here's a manifest of Cluster API. I'm using AWS today, so it would be AWS CKS, right?
And that's because that's what you voted for in a past episode of You Choose, yeah.
Yes. So Cluster API, usually use CLI to generate this manifest, contains the information about the cluster and a few other things. I have not enough time because Whitney talks too much. So I'm just going to go and say apply it, right? Apply -- file name, copy AWS CKS, right? Now I cheated a bit. This is the only thing that I did in advance. I did both of them simply because it takes 20-something minutes to create stuff in AWS. Blame them, not me. So this was already done. Execute the same command. I got Cluster API. I knew what you're going to vote. And if I do kubectl blah, 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 you can see copy resources over here. cluster is provisioned, machine pool is provisioned, everything is up and running, my cluster is up and running. It took 25 minutes, give or take. Now, to prove that that's really working, I'm going to copy get kubeconfig.aw. This is a simple script that retrieves the credentials for EKS from copy, and I'm going to export those credentials. Export kubeconfig equals pwd kubeconfig. Cool. And kubecat will get nodes. I should have 2 or 3 nodes. 1 node in my cluster. No, wrong kubeconfig. Prod. 2 nodes in a cluster. Excellent, right? And I'm going to kubectl create namespace production just to be ready for whatever is coming next.
All right.
Let's go.
Give me my slides back, please.
I don't care anymore. I'm depressed now after people chose copy.
Next up, we're going to configure synchronization with GitOps. Our choices are Argo CD, we have Flux, and Carvel Cap Controller. But first of all, what is GitOps? So there's 4 principles of GitOps. First, you have to define your resources declaratively. Second, they need to be versioned and immutable. And that's almost always done with Git. Third, our software agent needs to continuously be pulling from that repo and having the freshest changes possible. And finally, that should always be reconciling desired state with actual state. And that is GitOps. And our GitOps tools are Argo CD. Oh, we're like way off.
That's the speed with
now.
which you should speak, otherwise we'll never finish. There we go.
Our tools are Argo CD. Okay, Carvel Cap, which is has a great UI. We have Flux. Flux integrates tightly with Helm and with Customize, treats them as first-class citizens. And we have Carvel Cap Controller, which you don't have to give root access to your whole GitOps tool. Also, it integrates well with the other Carvel suite of tools. And with that, vote please, if assuming, there we go, vote please. Oh, this one, this can be pretty exciting. Again, this is not a popularity contest. This is not a winning thing. This is just what you want to learn more about.
Absolutely. Sorry, the previous one was not the popularity contest. This one is.
All right.
Flux?
Looks like Flux. I don't think it's going to change.
Okay.
Interesting.
Flux
Cool.
it is. Let's do Flux.
Let's see it.
Okay, so since I don't have enough time, I will be skipping today's setup, you know, Helm install and stuff like that, because that's frankly boring. So I'm going to just execute GitOps Flux sh. This will execute Helm install and the stuff that is required to. Oh, GitHub user is this DevOps paradox. Okay, I set up Flux. You haven't seen it, trust me, it's just Helm install, and you need to give it credentials to your GitHub account because it creates a repository, does stuff, and so on and so forth. So let's install it now for real. Bootstrap, actually. Bootstrap, Actually, I never use this terminal. I don't know how to do code complete. Flux Bootstrap, GitHub, and then owner is DevOps Paradox. That's one of my GitHub users. Repository. If I make a typo, tell me. That would be CNCF demo. And what else do I need? Branch is main, and the path should be infra. That's where I'm going to store my stuff, and it's going to be my personal account. And frankly, if this works, I will be surprised.
Woo!
Stay away, there's still a chance it will fail. Don't worry. Whitney's going to tell you a joke while we're waiting.
Why did the man fall into the well? Because he couldn't see that well.
Too late. Okay. I bootstrapped a repository, meaning that everything required for Flux to manage stuff in that repo is over there. I'm going to pull the changes. Those are the changes that Flux CLI itself pushed. So I'm going to install a couple of things, right? First of all, I have here the directory schema hero that contains manifests for schema hero. Database schema stuff, nothing really important. I mean, we might use it later. But what does matter is that I'm going to copy Flux schema hero YAML into the infra directory. That's the directory that Flux is watching. And actually, I didn't show you the file, Flux schema hero. This is Flux way to define and say, okay, use the default repository, the repository that was bootstrapped before, look at the path for schema hero, and apply whatever is defined there, right? That's the one that I copied to the infra directory, and there's going to be another one. Flux, what am I? Cert manager, right? I will need cert manager for later. Again, similar thing, except that this time files are not coming from my repository. They're coming from the Helm registry JetStack, and over here I'm specifying which Helm I want to run my cert manager, right? And I'm going to copy that one as well. Flux cert manager into infra directory. And I'm going to add stuff, and I'm going to commit stuff, something, and I'm going to push it to the Git directory, to the Git repository, right? Now, if I do kubectl -- namespace Flux system, I believe, and I want to get Git repositories, and what else? Helm repositories, okay, and Helm releases. All those should be now synchronized, or it will be running. One is unknown. Soon it will work. Maybe it will not. We'll find out. And if everything works, if I do --ctl namespace schema hero. There we go, get all. Schema hero should be running. There we go. It's running. And kubectl --namespace cert manager, right? Get all cert manager should be running behind me. There we go. And that's about it, I think. I'm going to export here GitOps app going to be Flux because that's what you chose for later. Go, Whitney. Oh, here you go, slides.
Awesome, cool. So we have our production cluster made, we have GitOps installed, now we need to think about Ingress. So as things stand, we have Ingress Nginx, Contour, and Emissary Ingress are our choices right now. So why do we need Ingress at all? So as things stand, once our application is running in the cluster, the end users can't get to it. So we need to add Ingress to get defined rules about how traffic from outside of the cluster is allowed to come into the cluster. And it can do a whole bunch of advanced stuff too. But in the end, we want our users to access our application safely and with minimum downtime. So there we are. The saying that our Ingress objects can do all this advanced stuff, it's not quite right. The Kubernetes native Ingress object is actually kind of limited in functionality in a few ways, but the one I'm going to dig into now is that it uses annotations to add these functionality. Gateway API fixes a lot of that. We'll get to that. But
if only the previous talk mentioned how we could improve.
I know, right? If only the person right before us talked a lot about how great it is. So adding this functionality with annotations isn't great. Annotations, unstructured data. There's no standardization about how that works. And then we have projects making their own CRDs about how traffic will come in before Gateway API. They're all choosing different ways to be able to control all this advanced functionality. There's lots of different networking layers, and then some people still are using the native Kubernetes object and doing it with the annotations, or both. It's a mess to navigate. So we have our Gateway implementation, and that helps things considerably. So if you weren't here for the last talk, Gateway API is a collection of resources in Kubernetes that models the way service networking should be done in Kubernetes. So let's get into it. Ingress Nginx is maintained by the Kubernetes project. It does add that additional functionality with the native Kubernetes object. It doesn't support Gateway API yet, I don't think. Does it? No. Okay, I'm looking. Soon, okay, it's working on it. And then, as implied in the name, it uses Nginx as the networking layer. So an Ingress is going to provide a human-readable way for you to configure what you want your Ingress to look like, how you want traffic to come into the cluster, and then it outputs configuration for your data plane. And then the data plane, like Nginx in this case, is what's doing the actual work of routing the requests. Next up, we have Contour. Contour uses Envoy for the data plane. It is a Gateway API implementation, and it uses its own custom resource called HTTP proxy. Some of the Ingress object problems that are solved is you can see status now for when things go wrong. It's much easier to debug. And what else? It separates concerns between different personas. Developers care about much different things than operators do. And then, again, as Nick talked about in great detail in the last talk, you can reference secrets and other namespaces with the reference grant. And then we have Emissary Ingress, which also uses Envoy as the data plane. And Envoy, instead of having one, has a collection of smaller custom resources. It has a mapping, which is developer-facing. It has a host, where you decide the host name. And it has a listener, where you say where you want to listen and what port you want to listen on. And so those are our choices. And spoiler alert, these all support the native Kubernetes Ingress object. And Victor's going to implement the native Kubernetes Ingress object, no matter which one you choose. And there we go. Ingress Nginx.
Okay.
We can get a little, ooh,
okay.
Contour.
Okay.
Oh.
Contour.
Woo.
Excellent. You will not get fired.
wait, no. We gotta. They can still vote right now. They're gonna be.
They can vote, but
yeah, okay.
Who cares? Okay, so here we are. First, I'm going to copy Flux contour YAML, right, to the infra directory. That's where Flux is watching for stuff. And I'm going to add that, and I'm going to commit that, something, and I'm going to push that. Cool. Now, what I just pushed there is this, right? Contour YAML. Basically, again, similar thing like with Cert Manager. This is the registry with Helm chart. There's the Helm chart itself. I'm too lazy to put any values because the default is always so correct. And Flux will synchronize it with the cluster, right? And if everything worked fine, there's namespace project contour not there yet. It should start working. Get NS, let's say, project contour, not yet. Did I mess it up? Git status, that's fine. Infra, did I copy it? I did. Am I impatient? Probably. Yeah, there we go.
Woo!
Namespace, project, contour, get all, it's over there up and running. Right. Now we have a slight problem. And that problem is that AWS does not like IPs. It likes domain, and you need an IP for what do I need it for? To use it with NIP.io because I'm too cheap to get the real domain. Host name, I'm going to store it here for later, and I will need to do export ingress IP equals, how I'm going to do this, dig, that's short, and ingress host name, right? This should give me the IP, and echo ingress IP. I need the IP of the service, load balance service. It will take a while. It will take 2 minutes. So let's jump to the next one, and then I'll get back when AWS wakes up.
Will you give me my slides back, please?
No.
Okay. The last thing we need to do.
You know it. You don't need slides.
Is come up with some configuration for our define and deploy our application. So there are lots of different configuration tools to use. We have Customize, we have Helm, we have Carvel YTT, and CDKs. So why do we need a tool to help us with configuration anyway? What's a little YAML? Can't we all just write that? So we have to worry about container images and updating them. We have to worry about application-specific configuration. We have to worry about how it integrates with the underlying infrastructure, and then how we're going, probably some Kubernetes objects in there. By the end, and especially since we're deploying across different environments, it's a lot to deal with. So first we have Customize to help us out with that. Customize is natively built into kubectl with the apply-k command. It uses a patching strategy to update application configuration. So you have a common base configuration, and then you make patches for what things you want to change between deploys. And then those patches get overlaid onto a common base when you actually deploy. And that's Customize. Helm uses a templating strategy to do this. So for changes between deploys, it's going to template, it's going to factor things that are likely to change out into a values.yaml file. And then you can also add dynamic configuration with Go templating. Carvel YTT, the YTT stands for YAML Templating Tool. It can do the patching strategy of Customize, and it can do the templating strategy of Helm. And then it adds the dynamic configuration with a Pythonic language called Starlark that gets added into the YAML comments. So it's always YAML and can always be processed and validated as such. And then finally, we have CDKs. The CDK stands for Cloud Development Kit for Kubernetes. So with this, you can write configuration in any language you want, as long as that language is TypeScript, JavaScript, Java, Python, or Go. So you import it into your IDE like you would any coding library. Your company's best practices can be part of that library. You have more simplified Kubernetes abstractions, and then once you're done writing code in whatever language you want, you run the synth command, and it synthesizes the CDKs code into plain vanilla Kubernetes YAML that you can apply to any cluster. And those are the choices. If my clicker, vote please. What do you want to see? CDKs. Oh, Helm, come on, do you really need to see Helm demoed?
Let's be serious for a second.
Awesome, I think we have a pretty clear winner. What do you think?
CDKs?
CDKs.
Now,
let's do it.
We're going back to the Ingress demo, and let me see whether I got the IP. Yes, I got the IP. I got too many IPs. So I'm going to keep only one of those. That's enough for me. And I'm going to export, no, what did I? Yeah, Ingress, because I cannot remember. Class name is going to be contour, that's the one, yes. And I'm going to store domain for later. It's going to be ingress ip.nip.io. That's what I will do. Now, the easiest way at this stage to demonstrate Ingress is to open a web UI of a GitOps tool that you chose.
Yeah.
Flux.
Yeah.
Well, it's not going to happen. You chose wrongly. We're skipping that, exactly. No, I mean, you chose right. I mean, you do, who needs browsers? You do everything from a terminal. What did they choose for the last one? What was it?
CDKs?
CDKs. Okay. Okay, let's do CDKs. How much time we have? 4 minutes. It's not going to happen, but let's try. Flux, CNCF. I did prepare some things. CDKs. There we go. I have a file here. It's going to go to YAML prod, right? I cannot instruct Flux to use CDKs, but what I can do with CDKs output YAML, right? So that's what I'm going to do. So I'm going to copy that file, and I'm going to paste it to the apps directory. That's where I keep my application, CNCF demo.yaml. Okay, I'm going to, I need more actually. Let's go to CDKs. There we go. In my code, I'm using some environment variables to decide whether something is production or something else. Environment is going to be prod, not project. Okay. What else should I do? Yes, I need to change a few things. You see that I practiced. Not the first time I'm doing this. Image.tag is going to be whatever is the tag of my image. It happened before. And app.prod. There we go. I'm going to put the tag of the image that I want to deploy. You will see the code later. And what else do I need to do? Yes. Okay, cool. Ingress host is going to be, there we are. What did I use? The Ingress domain, right? Oh, fuck, what's going on here? Okay, again, YQ in place Ingress host equals tab, and CNCF demo dot ingress, not ingress, domain. Right, that's what I used, and close it, and the file is up prod. Okay,
I think you have two closing.
What?
It's right. You're good.
Are you sabotaging?
Sorry.
She finished her part. She's finished. She can go home now. Okay, what else? Yes, the last thing, Ingress, class name. We need to say contour, right? Class name equals tab, contour. Is that how you write it? Yes, okay, up prod. There we go. Okay, now it should work, and I can demonstrate that. CDKs, sint, that's a command to convert code into YAML. I'm using Go today, and I want to output it to YAML prod. There we go. That's what I want to validate, whether it works well. It should output my Go code, which I might not have time to show you, into YAML, synthesizing application. All the warnings are always ignored unless they are errors. And if I go back, and if I output YAML prod, what is CNCF demo, that's the YAML of my application. From the Go code, no time for anything, git add, git commit, something, git push, there we go. And now if I say kubectl namespace, production, get all, there is nothing, right? Because it takes a bit of time until Flux figures out. 1 minute. That's how much it takes. Huh? Yeah, okay, sure. CAD, CDKs, there is multiple files, let's say main Go, right? Here's the Go code. And wait, you want even Go code? There's more Go code. Here is, want more Go code? Or you're fine? Wait, depending, if it works, then no more, okay, more Go code. Here's a database.
Yeah.
You need to have a leap of trust that eventually it will work. I think that they will kick us out, no? We're good. Nobody leaves. Until this works, nobody leaves.
So we're presenting at KubeCon on Wednesday afternoon, I think around 3:15 or something. So we're going to do this choose your own adventure style talk with the voting, but it's around security tools that we've been covering in our stream. So we'll have 4 security system design choices for that.
Yes.
And we're live streaming the finale of our You Choose at the Tanzu booth on Friday morning. So come hang out with us during KubeCon. Yeah.
It will work eventually. Oh, yeah. I'm giving free books of Crossplane to one person who voted for Crossplane.
Can we show them the QR code if they want to get to the CNCF repo? Or is it too late?
Oh
You
yeah,
have
no,
to
no,
plug
no.
it
There we
back
go.
in.
There's a QR code. Oh no,
Yep.
too late.
You unplugged it. Okay, never mind. We have a repo of all the projects we've integrated with all the other projects.
Basically, if you go through repo, you can choose any path you want, and you will get commands for any combination that you can imagine of any tool that you ever saw in your life.
So good luck finding it. Yay, thank you.
Thank you.
Okay. Hey, everyone. Welcome back from the lunch break. And not talking too much because we have an awesome next speak planned. I want to welcome Oshrat Nir from Armo. Yeah. And she's going to talk about a topic we all love, security, in this case, context-based security, what your cloud-native apps really need. So I say, welcome, Oshrat, and let's go.
Thank you. Thanks so much, Engin. So yeah, as mentioned, today we'll be going on an exploration of context-based security for Kubernetes. So basically, what does that mean? In 2 words, or a sentence, security that accounts for the workloads running on the clusters. So my name is Oshrat Nir. I'm a storyteller. I'm a lifelong learner. I'm a self-professed yogi, but I am more flexible in mind than in body. And I'm the developer advocate for Armo and KubeScape. In case you've never heard of Armo or KubeScape, I'll do another short intro. So KubeScape is the first Kubernetes security scanner that was accepted by the CNCF. And in the past year or so, it's been a sandbox project. It's evolved into much more than a security scanner. I'm just going to say this so that everybody knows. We're in a bid for incubation this year. So if you're using KubeScape, please add yourself to the adopters list on GitHub so that we can get to incubation. Thank you. So many of the things that I'll be talking about today are in KubeScape, and Armo platform is the enterprise version of KubeScape, and it even takes that to the next level. It takes all of KubeScape's insights and gives more context and guides to users through the maze of security alerts that we all know and love, right? So, you may have caught on by now. I'll be talking about Kubernetes security. But I won't be talking about shifting security left. Okay, you've heard that. It's a great idea. Don't stop doing that. But as Timo once told me, you need to look right in order to shift left. And understanding workload behavior is crucial to getting the correct context for securing Kubernetes from left to right. An interesting quote I found from Shane Lawrence from Shopify. He spoke at KubeCon North America in 2020. He said, no matter how good a job we do on the left, there's always going to be an issue that prevention didn't catch. And I think this is the crux of the issue. Security on the left is typically best practices based, which is great. We've got our benchmarks, we know what to do. But today, I want to show you how context elevates it. But let's take a cartoon break. This is a little story that I want to clarify what I mean by contextual security. In this cartoon, we see 2 people. They're being attacked by a lion. One is working off the absolute assumption that running away from the lion will save his life. Another knows that her life will be saved if she managed to outrun the other guy. She just needs to ensure that the lion gets to him first. So it is a gruesome story. It's not a really good example. But what I'm trying to illustrate here is that there's no absolute security. We have to take the context into account in order to understand the security posture of a system. Now, let's bring that back to the context of my talk. And yes, I did intend that pun. To tell if a vulnerability or a suboptimal setting can be exploited to breach a system, you need to have a full picture of how the system is put together and how it is actually being used by the workloads. If not, you may find yourself fixing security issues that don't matter and maybe not fixing the ones that do, and thus you're wasting 2 of your most important resources, time and money. So, Kubernetes security is complex because Kubernetes is not simple. It's dynamic, it's intricate, and it moves all the time. So as an orchestration platform, Kubernetes manages numerous containers, each running different applications, often across various nodes, namespaces, etc. This decentralized architecture offers the scalability and flexibility we all know and love. It also introduces multiple layers of potential security risks, from the workload down to the infrastructure. Kubernetes, many security features may be a little deceptive because you might get the impression that they cover all bases. While they do address most problems related to platform security and offer some extensions around applications and networks, such as Kubernetes secrets and native network policies, these don't automatically translate to securing everything layered on top or below. Securing these other layers are included in existing domains such as AppSec, platform security, and cloud security, and you know the drill. If everybody's in charge, nobody's in charge. So, to get effective Kubernetes security, it requires a comprehensive approach that encompasses the application, infrastructure, networking, access control, and an awareness of the constantly evolving threat landscape. Using all these information streams to provide context to Kubernetes security yields the best results. It provides users with a better understanding of the system's overall security posture. To put this in perspective, let's use an example. Think about an application that has a vulnerability that can be exploited by an attacker who has network-level access to the application. If we know, sorry, there's my slide, that this application can only receive requests from other applications inside the cluster, that's one thing. If it can be accessed from the public internet, then the problem is in a whole different ballpark. Now, if we add on to that the default behavior of RBAC settings, which allow a pod to get a service account token, which gives it access to the Kubernetes API, this situation potentially leaves you open to impersonation, lateral movement, etc., which is not only a different ballpark, it's now a whole different ball game. The good news is that a Kubernetes cluster has access to plenty of data streams that can be used by security practitioners to ensure the security and integrity of the environment. So let's talk about them. I'll start with the Kubernetes API. The Kubernetes API, as we all know, is the central nervous system of a Kubernetes cluster, offering comprehensive insight into the state and management of cluster resources. Security practitioners can monitor the state of the cluster using the API, making sure that the configuration is secure, and to detect unusual patterns in the state of the cluster. This information is also invaluable to put other information streams into context, since people aren't working with classical constructs like TCP connections or only processes, but in the context of Kubernetes workloads. The next stream we'll be looking at is logging, which is not only important for operations and governance. Kubernetes audit logs are invaluable for security monitoring and forensic analysis as well. They record a chronological account of requests made to the Kubernetes API, detailing who made the request, what was requested, and the outcome of the request. This data is crucial for detecting and investigating security incidents, ensuring compliance, and understanding the context of operational changes. The third data stream I'll talk about is role-based access control, or RBAC. I already mentioned RBAC in an example earlier. What I'd like to stress here is that it is fundamental to enforcing the principle of least privilege. By examining RBAC configurations, security practitioners can ensure that users and services have only the permissions necessary for their function, minimizing the risk of privilege escalation and unauthorized access. While it's possible to maintain and audit RBAC through the CLI using kubectl commands, that is a very long and involved process. As a result, there are many solutions on the market, like Armo Platform, that help with this by offering RBAC visualization, making this whole search of who's who in the zoo, like the example here, show subjects with all privileges on a resource, making it much easier to find. Okay, another data stream is the awareness of what's going on around us. So that would be vulnerabilities or CVEs in this case. So these are the main sources of alert fatigue. The graph on the slide shows an analysis I did with the ARMO security team, the ARMO security research team, sorry. We took a look at some of your favorite images and found them to be riddled with vulnerabilities. This is old data, it's like maybe a year old or a little more, but you get the idea. Security teams must stay informed about any vulnerabilities within these images to take timely action. Tools that scan container images for known vulnerabilities and provide detailed reports are essential to maintaining a secure container environment. I think this data stream is the most used one, and I think it might be the one that causes everybody the most angst as well. So, another thing is that the security of a Kubernetes cluster also depends heavily on the security of its nodes. You should basically adopt the same security strategies for securing Kubernetes nodes that you would to use to secure any type of server. This includes understanding the operating system details, ensuring they're up to date with patches, validating installation configurations, monitoring node health and security posture is critical to safeguarding the underlying infrastructure that supports the cluster. So, node information is a key data stream that security can use to build context. This isn't a data stream. This is a tool. Anybody heard the buzz about EBPF? There was a talk this morning, right? So yeah. EBPF enables detailed observability and security monitoring within a Kubernetes cluster. It provides deep visibility into processes, file activity, network traffic, system calls, and all of this at the kernel level, without modifying the kernel or the applications. So while eBPF itself is just a tool, it's a very good tool to extract data that is applicable to security. This allows for real-time security monitoring and performance troubleshooting. And it offers security practitioners a powerful tool to observe and secure applications running in the cluster. So, I just listed a bunch of problems and possibly only hinted at solutions, and I know that can be annoying. But I come equipped with solutions. So give me a few minutes. Remember those CVE-riddled images from before? Well, the solution lies with CVE reachability. It's a new approach in container security, newer, I guess. It leverages the power of eBPF to enhance the accuracy and efficiency of vulnerability management. At the core of CVE reachability is the understanding that not all software packages in a container are actively used in runtime. We know this from how we build containers, right? Traditional vulnerability scans of container images often flag all known vulnerabilities in every package included in the image, regardless of whether those packages are in use or not. And typically, the best practice these days is to say, okay, no criticals and highs. But maybe that's just a waste of time and effort as well. So because this approach often results in a large number of false positives, and that burdens the security teams with the task of sifting through these results to identify the genuine threats or work through all of the high and critical CVEs. By employing eBPF, CVE reachability highlights the software packages that are actually used during container runtime. It monitors and records the file accesses made by the container, provides precise data on which parts of the container image are active. With this information, security practitioners can then filter the results of vulnerability scans to focus solely on the vulnerabilities that are present in the active packages or are running in memory. So this approach offers benefits such as reduction in false positives and focusing on threats that are real today. It presents a more precise and efficient method for managing vulnerabilities. And it significantly reduces the burden on security teams and enhances the overall security of Kubernetes environments. EBPF observability also extends to network interactions. By monitoring which external entities a workload communicates with, EBPF can help in creating accurate network policies. These policies restrict network access to only those communications that are necessary for the workload's operation, thereby reducing the attack surface and preventing potential lateral movement of threats within the network. System calls. They are how a program requests a service from the operating system's kernel. EBPF can monitor the system calls made by the workload, providing exact insight into its interaction with the operating system. With this data, security teams can create SecComp profiles, or by their full name, Linux Secure Computing Mode profiles. I dare you to remember that. That precisely define which system calls are permitted for a given workload. This can get lost in the mix due to it falling between the cracks of DevOps, security, and dev. No one group mentioned has a holistic view of what an application actually uses. Hence, this level of control is typically hard to achieve manually due to the vast number of potential system calls and the difficulty in predicting which ones an application actually requires. And is there anybody here that wants to break an application in production? Huh? No. Nobody wants to break an application. By observing which capabilities a workload actually utilizes, security teams can tailor the permissions to fit the workload's specific needs, ensuring that only necessary capabilities are enabled. So those were a handful of disparate use cases, and they all use eBPF explicitly. When we're talking about attack paths, it doesn't rely on eBPF explicitly, but it does provide that holistic view that I was talking about. The concept of attack paths in a Kubernetes environment revolves around the identification and analysis of routes an attacker could potentially exploit to compromise the system or its assets. Detecting these attack paths, requires a multidimensional approach, considering various aspects of the cluster's configuration and state. To effectively identify potential attack paths, it's necessary to integrate and analyze information from multiple sources within the Kubernetes ecosystem. This includes data from network configurations, workload behaviors, security vulnerabilities, access control, and more. Consider a Kubernetes workload that is configured to receive traffic from the public internet. This configuration detail can be gleaned from the Kubernetes settings, such as Ingress rules. We haven't talked about Ingress for a while, right? Or service types. Suppose the same workload is identified by a vulnerability scanner as having critical security vulnerabilities. This information adds another layer to the security assessment. Combining all of it results in flagging a heightened risk for that particular workload. Furthermore, let's say the workload has a mounted secret, which could be sensitive data or credentials necessary for its operation, you choose. This aspect introduces the potential for data exposure or unauthorized access if the workload is compromised. By looking at all the information collectively, the public internet exposure, the identified vulnerabilities, and the access to sensitive data, a holistic security system can deduce that the mounted secret is at risk of being compromised by external threats. This realization forms the basis of an attack path. An external actor could potentially exploit the vulnerabilities to gain unauthorized access to the secret. So this method of combining multiple data sources to identify attack paths can be applied to various other scenarios in a Kubernetes environment. Each scenario will have its own unique configurations, vulnerabilities, and access controls. But they collectively indicate potential attack vectors. This approach underscores the importance of contextual security analysis in Kubernetes. By integrating data from multiple sources, security systems can map out possible attack paths, thus enabling security teams to preemptively address vulnerabilities, tighten configurations, and safeguard sensitive data. Such proactive measures are vital in mitigating the risk of attacks and maintaining the integrity and security of Kubernetes clusters. Since I have a few more seconds on this slide, I can also tell you the neat thing about attack paths is that if you break them in only one place, you're good. So you don't have to go through the whole 9 yards and solve all of the problems. It's enough to break the attack path. So you have all the holistic view, and then you have the attack path, and then you know where to block it, and you're good. Of course, you keep monitoring, you keep looking, and you keep checking, because security is a moving target. So, to conclude, there are many information sources that inform Kubernetes security. Looking to industry benchmarks is a really good start, but it's just a start. Adding a layer of context onto those best practices is the only way you'll be able to create and maintain secure Kubernetes infrastructure in a way that is applicable to the workloads you are running. Many of the things I mentioned are really hard and resource-intensive to do manually. This toil is begging to be automated. KubeScape automates much of what I mentioned. Armo platform takes it even a step further. So thank you for listening. Does anybody have questions? Because I left time for questions. 1 second. Okay, so thanks. So thanks for listening through my speed talk. If you'd like to keep in touch with me, Oshrat, and on all of the socials I exist on, because I'm not on all of the socials, you can follow Armo or on LinkedIn or X, which is Twitter, by the way. And if you're interested in Kubernetes security, you're more than welcome to join the KubeScape community. You can check it out on X or GitHub. There are also KubeScape channels on the CNCF Slack. If you'd like to continue the conversation, I have plenty of time, so I'm good. I'll talk slowly, I'll make 5 minutes. If you'd like to continue the conversation, you can come visit the Armo booth at KubeCon starting Wednesday. And on Wednesday and Friday during the second shift at the Sandbox projects, you can speak to KubeScape maintainers at a KubeScape kiosk at the CNCF project pavilion. And if you're using KubeScape, add yourself to the adopters list. Thank you so much.
Thanks, Oshrat. We will make a break until 2:35, and then we continue with security. Rory will speak, so please join again. Thanks.
That was fast.
Okay, welcome back, everyone. Today, back-to-back security in 2 talks. So I'm welcoming Rory McCune with Beyond the Surface, Exploring Attacker Persistence Strategies in Kubernetes. So welcome.
Hey. Good afternoon, everyone. Yes, so the talk today, Beyond the Surface, Attacker Persistence in Kubernetes. Now, a lot of security talks will often look at how do attackers break in. What are the things they're going to do to attack your applications, to attack your clusters, and what might they do afterwards, and how can you protect? The idea of this talk is instead to say, what happens after they've successfully compromised your cluster? What might they do to try and hang around? Because attackers getting initial access is just the first part of it. They want to retain access to environments, they want to continue exfiltrating all your data as long as possible, and they want to get access to as many parts of your environment as possible. And for persistence, that's what you need. The other thing I wanted to do with the talk today is talk about some of the areas of Kubernetes security that are perhaps a little bit less well known, and some of the things you can do. And at the end, we will also talk a little bit about how to stop them, because it wouldn't be a good security talk if I didn't, leave you with something useful. Who am I? Why am I doing this? I have been in information and IT security for a while now. The fact I don't call it cybersecurity should give you some idea to how long I've been in. That's too new for me. I've been doing container security for, I believe, 8 years. I didn't believe this. I went back and looked. I started doing talks on this in 2016, so yes, it has been 8 years. I'm a senior security advocate for Datadog. If you've not come across Datadog, we are a SaaS provider of observability and security services. In the community, I do a couple of things. I am one of the authors of the CIS benchmarks for Docker and Kubernetes. These are vendor-neutral hardening guides. If you use CSPM software or KSPM software, you will essentially be using the CIS benchmarks. You might not know it, but you are. I'm also a member of Kubernetes SIG Security and CNCF Tag Security, which, if you're interested in security, well worth coming along to our meetings. And lastly, I am very proud to be a member of the only unofficial Kubernetes SIG to have ever keynoted KubeCon, which is SIG Honk. And we are essentially a group of people who just like playing around with the security of clusters. This talk is very much in the spirit of SIG Honk, or at least it's intended to be. So let's set the scene. There are many ways that an attacker might get access to a cluster. You might accidentally, as an admin, check your credentials into GitHub. I have seen this. It has happened. You might get malware on your laptop, and someone might know about Kubernetes credentials, and they might steal them from you. For the purposes of this story, however, our intrepid Kubernetes administrator is partaking of coffee in one of Paris's lovely cafes. They have then stepped out to take an urgent phone call outside and have unfortunately left their laptop unlocked. And very unfortunately for them, there are some shady attacker types who are waiting for this because KubeCon is in town this week, and they thought, here's an opportunity to get access to some clusters. And they have stolen the administrator's credentials, and they have half an hour, the duration of this talk, to try and persist in the cluster and to try and creep access. So let's think about what they could do. Well, the first thing they want to do is they want access to one of the cluster nodes, right? Because once we've got access to a cluster node, we can start running our own code. So how are they going to do that? Well, we also have to think about where they're going to hide, though. Because they might hide in the cluster, they might hide in the container, and they might hide in the node. There's lots of places to hide. We're not going to talk about cloud today, because I could do a whole talk just on cloud, probably do several talks on cloud. We are going to focus on clusters, nodes, and containers. But how are they going to get access initially? Well, in my old pen tester days, I used to have a manifest I used a lot. I called it PrivPod, and it basically gave me full access to a cluster node by running a pod manifest. It was based on, if anyone's ever seen, Ian Meal did a blog called The Most Useless Docker Container Everywhere. It was 2015, the most useless Docker container. It was my favorite Docker container as a pen tester. It was one command that basically drops you in a privileged container with all the host namespaces. Fantastic stuff. Then Kubernetes came out with kubectl debug node. And I was thought, wow, this is my pen test script. It literally is a manifest that does the exact same thing as I did with a pen tester. It drops you into a privileged shell on the node. So our attackers can just use that. If I'm a cluster admin, I can just do kubectl debug node, and I then have a privileged container with access to host namespaces. So the first step in persisting access is pretty simple. I can get access to kubectl debug, and away I go. One thing I always remember when used to do a lot of cluster reviews, is that sometimes people would say, we've locked down the access to the cluster. We've removed all SSH access. We only give people kubectl access now. And I had to give them the kind of bad news that that's basically the same thing. In a lot of ways, that's actually more powerful than just SSH access.
But that's what our attackers are going to do. They're going to use kubectl debug node, getting them a privileged container. Next thing, we want to retain access. Well, this is kind of a fairly basic and obvious technique. We've all been told you don't use password logins for SSH anymore. You use authorized keys, right? We use key-based login. If I'm an attacker and I have a root shell in the node, I can just concatenate a key onto the end of authorized keys for any user. And at that point, I can then SSH to the node as them. Now, of course, SSH, as I said, may not be exposed to the internet, but it might be. It's not unknown. And if it is, that's my access, right? I just put a key on the end of SSH keys, and away you go. But even if SSH isn't exposed to the internet, this technique is actually pretty useful for a reason I'm going to explain in the next slide. This one, I would hope, I'm hoping everyone's running node security agents on all their clusters, right? If you are, I would hope this got spotted. If it doesn't spot this, that's probably not great, because like I said, it's a classic technique. It gives attackers persistent access. So this one, I'd hope they're going to spot it. So now I have access, my attackers, they've got access to the node, they've got their debug shell, and they've got their key and SSH authorized keys. They're well on the way to keeping and persisting their access to the cluster. But the next thing they need to do is they need to execute code. If I'm an attacker, I want to actually execute code inside the cluster node, because that's going to help me persist. It's going to help me do things like call back to my command and control systems. Now, as an attacker, you might just think, well, I'll just run a binary on my cluster node. And that may or may not work, because a lot of Kubernetes distributions have actually started locking down node operating systems and actually removing the ability of people just to run any binary on a node operating system. I'm using GKE for all my demos today, just because it's the one I had access to. But I noticed GKE are now using container-optimized Linux on their nodes by default. And if you try and just drop a binary somewhere and run it, you're probably going to run into the fact they've run no exec on the file system mount, or they've got it read-only, so you can't do that. So to an extent, attackers' life may be more difficult. But our attackers here, they are container aware. And they thought, well, it's a Kubernetes node, and it's got a container runtime on it. That means I can always run containers, right? If I've got a Kubernetes node, there's no time I won't be able to run containers, because that's literally what Kubernetes nodes do. So I can just run a new container in order to persist my access. And to do this, I'm going to make use of a perhaps lesser-known feature, which is containerd namespaces. So if you don't know about containerd namespaces, they let you organize all your containers into different sets. If I create my own namespace, then my container won't be visible if you just look at all the ones, for example, in the kates.io namespace. You won't see my container running, because it's in a different one. Somewhat confusingly, containerd namespaces have nothing to do with Kubernetes namespaces and nothing to do with Linux namespaces. So naming is definitely hard, because everyone uses things namespaces, and they all mean something different. So I can actually do that. So let's, in the spirit of, let's see how the dark gods of demos are treating me today, let's do this live. So I have got my access to my GKE, and I've got my debug shell, which I've got ready to go. Now, the first thing is, I'm in a privileged container. So could I run CTR, which is what I'm going to use, to launch a new container from my debug shell? And the answer is no, you can't. In the old days, I hate saying old days for this, when Docker was our CRI of choice, if you had access to the socket file, you could always use Docker to hit the socket file and run a new container. If you try accessing the containerd socket from inside a container, you're going to have a bad time, because it relies on the client having certain things in common with the server, and it won't work. I've seen like an idea of a really weird container that you could run that will run containerd inside it, but nope. It's not as good, it's not easy. So what I'm going to do is, I did SSH authorized keys. So let's go and get a full proper shell. We'll just SSH back to ourselves, 127.0.0.1, easy. Awesome. We're on, and we can just do sudo bash, because I picked a user who's got sudo bash rights. Now I've got a real proper full shell. I can do whatever I want. So because I'm not as brave as Victor, I'm not going to try typing all of my commands. I'm going to copy-paste them. I'm going to create a new containerd namespace, and I'm going to use CTR as my client. So I could use nerdctl, but nerdctl doesn't come with containerd. One of the great things about CTR is it's included with every single containerd installation. As an attacker, the fewer things I download, the less chances there are that someone's going to detect what I'm up to. So I'll use CTR. So I create a new namespace. I'm going to call it sysnetmon. Let's not make it obvious. Let's not call it attacker was here or something. Let's call it sysnetmon. Then what I can do is I can go and pull an image. So I'm just going to pull an image off Docker Hub. And I'm going to call it systemd-netmon. If I'd had a bit more time, I would have changed my name as well, called it systemd-netmon. Now, this image has got nothing to do with systemd. It's got nothing to do with network monitoring either. Docker tags can be anything you want them to be. They don't describe what is in the image. But my attacker is going to call it that. So cool, I now have my image downloaded locally. And then what I'm going to do is I'm going to run it. So let's clear that off, put that in. Oh, that's when it's decided it doesn't want to be exactly right. Let's try that again. What's it done wrong? I know what it's done wrong. It has decided to break it on a new line, which it should not have done. There we go. Awesome. I now have my container running. Now that container did a couple of useful, interesting things. One, it uses host networking, so it now is not restrained by network policies. You've got network policies in your cluster, they don't generally apply to host networking. It also mounts the entire file system from the node inside the container as /host. This means I've got access to everything there is on the node file system as an attacker, including things like the kubelet creds. So I now have access to anything the kubelet on that node can do, I can do, because I have got access to the kubeconfig file that it uses. I also probably have access to every single secret for any container on that node, because I've got access to all the file systems where those secrets live. So as an attacker, this is a good first step. I've got access to quite a lot of useful stuff. And I can actually then just execute a shell inside my container. Awesome. So I'm now running in a container. I can pull any code I like down to this because I'm running in my own container, and I can run it. And there's nothing that, read-only file systems are not going to block me. No exec is not going to block me because I'm running a container. As an attacker, my day is getting better. So what are we going to do next? What's our next step? We could have done this a different way, just to mention before I move on. We could have used Kubernetes static manifests. These are a really useful tool for Kubernetes. They're used as part of the bootstrap process. So before the Kubernetes API is up and running, if the kubelet wants to start a container, for example, in kubeadm, all of the control plane components get started this way, you use a static manifest. You basically put a pod manifest into a directory, and it runs it. You can also amusingly put it at a URL. The kubelet has the facility to read static manifests from a URL if you want it to, which is another nice way of doing it. But as an attacker, if I just dump a pod manifest in, then the kubelet will handle running it. And the kubelet will handle things like restarts. So if the node gets restarted, the kubelet will say, yeah, of course, I'll just restart that thing for you. So again, the attacker could have gone down the static manifest line. There's different ways of doing it depending on how he wants to work. This time we've just gone for CTR. That's another way of handling it. So now I need to get access back out. I need to do a reverse shell. I need some way of saying, once my credentials are no longer valid, I can still get back into this environment from anywhere in the world. Now, there's lots of software out there. There's lots of attacker software you could use to use this. There's Cobalt Strike, there's Metasploit. There's lots and lots of them. Most of attack software or pen test software will get picked up by anti-malware agents or XDR systems or EDR systems. What might not is Tailscale. Tailscale is an amazing piece of software. I love Tailscale. It's so useful. But one of the things you can do with Tailscale is you can have it run just over 443 TCP. So you can say, if I execute Tailscale inside a container, it just has to be able to get to what they call their DERP network, which is a network of relays that Tailscale maintain on the internet, or you can run your own DERP server if you want. And then as long as my attacker VM can get to it over 443 TCP, and my node essentially, because we're using host networking, can get to it over 443 TCP, I can retain access. Another fun thing you can do with Tailscale is you can rename the binaries, so you can call them systemd-netmon. And then if someone does a process list on the node, they'll just see that systemd-netmon is running. The question I would have is, does everyone know all the processes that are meant to run on their node? Like if you looked at a Kubernetes node for a managed distribution, would you know what all of those processes did? Would you spot it if something called systemd-netmon was running? I'm not sure I would. But we can do that. Tailscale, I'm going to put a blog. I didn't have time, unfortunately, for the demo for this. I will write a blog with exactly how you can do this, because Tailscale has some really neat features, like access control lists, so your controller can talk to the bots, but the bots can't get back out. It's really quite nice. There will be a blog coming on that one. But we can use that, right? So now we have executed code in our thing. We've got our container running, and we have our persistent access. So once we get kicked off our half an hour, not even half an hour now, he's got 15 minutes left to go. Once we get past our 15 minutes, we're still going to retain access. This is all cool, but we're missing something. Because I've said that the admin's credentials are going to expire in 15 minutes. We haven't got any creds. That's a problem. We need creds, because otherwise we're going to have a bad time. How can we get creds? And how can we find some nice way of perhaps getting access to Kubernetes functionality without being spotted? Here, we come to the Kubelet API. Kubelet API is great fun. the kubelet API essentially runs on every single node, 10.250 TCP, and it lets you do fun things like execute commands in every single container running on the node, which is really nice. The kubelet API is also interestingly in that it's not actually documented really anywhere. There is some documentation if you know where to look, or the source code if you want to go and look, but it's not that heavily used. From an attacker's perspective, there's two very interesting properties that the kubelet API has. It is not in the audit log. If you do stuff with the kubelet API, the audit log does not capture it. It will capture the request for a check for credentials, but it won't capture what was done. So that's useful as an attacker, because I don't like audit logs, because people might find me if I turn up in those. It also doesn't affect by admission control. Admission control does not affect the kubelet API. So if you're using admission control to stop people doing things, if someone can go to the kubelet API, then they're good. So the question, of course, is, for my attacker, how do I get access to this kubelet API? What credentials do I need? The answer turns out to be somewhat not that well known, perhaps. You need access to sub-objects of node in the main Kubernetes API. So there is a page on this on the Kubernetes docs, but the main one is node proxy. If I have a user that has node proxy rights, or you have any user that has rights to node proxy, you can talk to the kubelet API directly, bypassing the main Kubernetes API. There are some legitimate software that uses this, but we can use this as attackers too. So let's see if we can actually do that. For this, I'm going to go back out to another shell on my attacker machine that has got creds. And we are going to go to our next command. So I'm going to create a set of credentials, and I'll explain how I did this on the next slide. But I'm basically going to create a set of credentials for a user called KubeAPI Server. This is a user that's part of GKE, so every distribution tends to have different users that are defined in it. I found one that was useful for this demo. It's called KubeAPI Server. Doesn't exist in other demos, but there's usually some user you can use for this. This one's got node proxy rights. So we're just going to create a new kubeconfig file for that. So we've done that. Awesome. We're now going to cat out that kubelet user file. And if I was using my Tailscale LDOT setup, I'd bring this across with that. But instead, what I'm going to do, if I can persuade this to copy. I know, this is a nice little kubeconfig, but that's got I'll explain how that worked in a second. There we go, we're going to Control-C that, and then we're going to go back into our shell. So we're back inside our cluster, and I'll just call it kubelet user config, and then we'll just paste that in, and then we'll do escape quit. And then once I've got that, so I've now got my kubelet config file, oops, we're going to go back to our text file, and we're going to get that command. Even with the power of copy and paste, I can still make a mess of it. Oh, I called it the wrong thing. Okay, awesome. That did not do what I wanted it to. Oh, I know what happened. I scrolled down too far. Awesome, that's better. So this is a command called kubelet-cuttle. If you want to get to the kubelet API, you could do it manually with curl, or you can use kubelet-cuttle. And that is a kubelet-cuttle list of all of the pods running on that node. So I've got credentials now, which give me access to that node and all the pods running on it. The good thing about those credentials is they also give me access to every other node and all of the pods running on it too. So I've got 100 nodes, the same credentials would work, and I would have access to do not just list the pods, but execute code inside every pod in the container. So as an attacker, I'm having a pretty good day at this point. I've got access to run, execute commands every time. And a couple of people are probably saying to me, well, Rory, how did you do that? How did you create those credentials? Because famously, Kubernetes doesn't have a user database. But Kubernetes does have users, and you can create new ones just using Kubernetes functionality. How we're going to do this is the CSR API. Certificate Signing Request API. This allows you to create new credentials for any existing user who is defined in RBAC, or actually ones that aren't, and it just won't work. But basically, it lets you create new certificate users for any user in the cluster. This is enabled by default in Kubernetes, and it's always there. Interestingly, from a security standpoint, this would go in audit logging, as long as you're logging requests to this API. But there's nowhere else in the cluster that this information is retained. So once I create a credential, if you don't have audit logging turned on, there's no information that I created the credential. I can also create credentials for any user, and I can create as many credentials as I want. So I can have 10 credentials all for the same account. No problem at all. Works just fine. And this is part of how Kubernetes has, this is one of the APIs Kubernetes has. So you might say, you've gone to a lot of effort there, Rory. You've had to create containers, you've had to copy and paste credentials, you've got the Kubelet API. Is there an easier way? Well, if the API server is exposed to the internet, then you can just create credentials using the CSR API and use them over the internet. Now, would anyone ever put their API server on the internet? Last I looked, there's 1.4 million Kubernetes API servers on the internet. Because the default in all of the major managed distributions, GKE, AKS, EKS, is to put the API server on the internet. And somewhat unsurprisingly, people tend to follow defaults. If you read the hardening guides for all of those distributions and any other one, they'll typically say don't do that. But the default is that's what you get. So as not a surprise, there's lots of them on the internet. There are various search engines that you can use to find them. If your cluster is on the internet, all you need to do is use the CSR API to create a credential, and then it'll give you what you want. And I've got a little demo of that. So let me get to back to my demo script. And here we go here. So what I'm going to do, we'll go back to this shell here. And then we'll do that. And we're just going to use this command here. This is something I wrote because I'm a lazy pen tester. You can manually use kubectl to use the CSR API. I got tired of doing it manually, so I just created a little program there, which is the Gaelic for certificate. And what it does is it uses the CSR API, issues a new credential, and then creates a kubeconfig file for me. Because it just literally automates 3 commands. It's nothing magic. And I'm going to create I'm going to use a different user account this time. I'm going to use system GKE common webhooks. And I'm going to output to a file called webhook.config. Now, an important point about this credential as it gets created is the expiry date, which is 2029. So by default, in GKE, you get 5 years validity. This credential will last till 2029. This is variable depending on the distribution. AKS, I seem to recall being 1 or 2 years, but it's a while. It's not that short. So you get access, and also to revoke this credential, if you, for example, knew it had been created, you have to rotate the certificate authority for the entire cluster, assuming that you can do that. In AKS, they note this as being possible and say it's a disruptive operation that will take your cluster offline for like 15 minutes. So it's not something you're probably going to do too lightly. But as an attacker, this is great. I can now create a credential called system GKE common webhooks, and any access in the audit log comes from system GKE common webhooks. So all you will see is requests to that endpoint, or from that user, essentially. An important point to note, though, there are 2 places where this doesn't work. Amazon EKS, they disabled this API. For a long time, it was not documented why they had disabled this API. There was just a GitHub issue with people saying, hey, this broke my stuff. Eventually, they put in the docs to say this is deliberate. We don't allow this for creating credentials that can be used to authenticate to the cluster. We have other uses of it, but not that. They've never said why, but I'm pretty sure the answer is security. The other one is GKE Autopilot. GKE Autopilot tries to block this. It takes a different approach. If I try to use this exact command on Autopilot, it'll fail because I'm trying to create a certificate for a system account. It'll say, no, you can't do that. You can still, I think, create them for other users. I haven't dug into exactly what their block list looks like, mainly because I can't find exactly where their block list is documented. But that is blocked there as well. So I think there's a perception, at least in some distributions, that the CSR API is a wee touch on the dangerous side. But however, in the vast majority of clusters, if you're cluster admin, that works just fine. And you get your credential that lasts till 2029, which is very nice. Or you can generally specify a max time. There can be a restriction on it, but it's typically measured in years. The best practice is obviously not to do this. If you have to use client certificates, make them short-lived. But again, defaults matter. And if the default is years, it's going to be years. So I've got, I think, just over 5 minutes left. Yes, 5 minutes. Okay, we're doing well on time. Awesome. Another way of doing this, there is another way of creating credentials in Kubernetes. Token request API. Token request API, it can be used to create service account tokens. In the old days of Kubernetes, again, I hate saying old days because it's 1.22 or earlier, which doesn't feel that old to me, service accounts got unexpiring secrets. If you still have any 1.22 or earlier clusters, that's not cool. Because essentially, if you can get access to secrets in an earlier cluster, you get tokens that never expire for any system account. You just dump the secrets once, walk away, you've got all the tokens, you can come back whenever you like, no problem. It's better now because you have to use the token request API to create them. However, that is something that works as well. So I've got another one that I've got another tool that essentially creates kubeconfig files in the same style. This is not as good from an attacker's perspective because there can be a maximum time limit. So for example, GKE limits you to 48 hours. So the attacker has to come back every 48 hours, create a new one. EKS is 24 hours. You have to come back every 24 hours and do a new one. So it's a bit more visible, a bit less useful. AKS actually, I think last time I checked was a year. So they don't have the same set of restrictions. So one of the problems about talking about Kubernetes security is which distribution and which version am I talking about matters. But typically that will work. Also GKE Autopilot, credit to them. If you try and do that for kube system accounts, it'll say, no, go away. You can't do that. Autopilot, again, recognizes this as a bad thing. However, if you're on the internet, and again, 1.4 million clusters, this will work in the vast majority of them. So you can just create a new kubeconfig file. My favorite service account, and I know it sounds really sad to say I have a favorite Kubernetes service account, is the, I know. It's the cluster role aggregation controller service account. Because it has, and again sad, my favorite Kubernetes verb in its RBAC, which is escalate. The escalate verb in RBAC says I can get to be whoever I want. If I have escalate verb, I get to be cluster admin anytime I like. That is the thing that has the escalate verb. It has to have the escalate verb to do its job. So it will always have the escalate verb. So if you get a copy of its service account token, you have cluster admin. Simple as that. So 3 minutes. Okay, we're at the good part. I'm going to tell you how to stop all of this. Kind of. So how do you detect this? How would you spot people doing this? First up, Kubernetes audit logs. I hope we all have Kubernetes audit logs turned on all of our clusters. If you don't, there's lots of things I've done today you will just not spot. You won't see the CSR API, you won't see the token request API. Like I said, there's no persistent record that those have been used. Kubernetes doesn't have user accounts. It won't tell you how many credentials there are for a given user. Can't do it. You must have audit logging turned on. Retention is important. If you want to go back further, you have to have the right retention. Now, note with managed Kubernetes, you can't change the configuration of auditing. They will detect most of this. The only downside to that is you might gather a lot more than you want, and obviously there's a cost implication there. I don't want to pretend that's simple. There's a cost implication to retaining audit logs. But if you want to spot what people have done, then that's what you need. Node agents, you need to run a node agent, right? If you want to spot things like adding keys to authorized keys, you need something running on the node that knows what to look for. Very importantly, whilst there are bypasses that can detect things, make sure whatever you're using knows about Kubernetes, or you'll get tons of false positives. Because containers do lots of odd things as far as standard Linux is concerned. So unless your node agents know what Kubernetes is and what Docker is, they will make mistakes. And you'll get a wave of false positives and you'll turn it off. Node logs, make sure you're logging all the things from your processes and make sure the logs don't stay on the host. Because if I'm an attacker, one of the first things I might do is just delete all the logs on the host. And then, so make sure those are getting streamed somewhere central. And know what good looks like. So if someone ran a new thing on your cluster nodes called systemd-netmon, would you notice that's not meant to be there? This is tricky right enough, because when you go to each distribution, they have their own range of things that run, right? GKE has its own range of things, which is different from EKS, which is different from AKS. So it's not as easy as it sounds. It sounds super simple, that, but actually worth doing. Benchmarking what you expect to be running gives you some better chance at saying this shouldn't be running. How do you block it? Take your clusters off the internet. I keep looking at this, and it's kind of powering out at 1.4 million, so I'm hoping that's people taking my advice. Take your clusters off the internet. It's not the default, but it's well worth doing. And least privilege. Try not to use cluster admin for all your admins. Imagine this story, except the admin wasn't cluster admin. Maybe he only had rights to like debug pods, and he had a break glass procedure if he needed something else, right? This story could have ended very differently. To use the great words of Ian Coldwater, we are all made of stars, but your RBAC should not be. And that's my talk. If you have questions, I'm on socials. I think I'm out of time. I'm almost out of time. I think I'm just genuinely out of time.
I mean, what percentage of organizations now, roughly, have proper audit logs and know how to use them? I mean, you don't know the exact percentage, but what I'm asking.
That's very hard to say.
What I'm asking is that an easy access or an easy access? Is it often missing?
Well, it's not the default. Again, defaults matter. So it very much depends on your default. Kubernetes by default won't put audit loggings on. You have to go and configure it. Managed distributions, it's variable. So I would say it's getting more common. However, are people looking for things like that in their audit logs? Again, comes down to the software they use. This is the challenge I come back to a lot. There's so much variety. that are actually assessing current practice. I'd say audit logging is getting better, but I'm not sure people are looking for this. A project I would like to do more of, though, I will say.
So that's a pretty, I mean, actually I didn't phrase the question correctly, I don't think. But what I meant was, it's not that common to properly utilize these audit logs.
I think you're right, and that's the problem is you won't see, like CSR API, token request API, it's 2 requests, unless you spot them, bad times.
Any more questions? Yeah.
I'd just like to say thank you on behalf of Ireland for including a Gaelic word in the presentation today. Lá féile Pádraig, gachtainna.
Cool.
Okay, with this, I would say in 5 minutes we continue with another great talk from Lucy from Uber. So I'm really excited for this one. See ya. Okay, welcome back, everyone. I'm really excited for this talk because I sometimes fly to America and use Uber, as I call it, public transport there. And I'm really interested in Lucy's talk, migrating 2 million CPU cores to Kubernetes. So welcome, Lucy.
Thank you. So yeah, I'm Lucy. I'm an engineer over at Uber in Denmark. So I work in the Denmark office of Uber, which probably most people in this room have never even heard of. But we have 120 people in a small Danish city called Aarhus, and we build all of the stateful and stateless platforms that are used across the company. And so the TLDR, the long and short of our job is that we exist to make other developers not have to care about their infrastructure and hosting, and they can just focus on getting working code and move on with their lives. And we have a lot of infrastructure, actually. I think most of you will know what Uber is already, especially if you're from America. So it translates to a huge amount of stuff. We're doing, we're counting trips nowadays in like billions of trips we do. And then under the hood from that, we have 4,500 microservices being deployed out by about, I can't remember now, it's like many thousands of engineers. And they all do this through this Up platform. Up is meant to be the go-to platform for all of the stateless services at Uber. You can deploy onto it, and then we will deal with your infrastructure, and etc. We're strong believers in, or Up will deploy it for you if you're using continuous deployment, which we're strong believers in, which is why we have about 31,000 weekly deployments to production. So it adds up to a lot. That's annoying, that image broke. Anyway, so under the hood, the way Up works is that service owners will tell us what their requirements are in terms of how many containers they need, what sort of placement options they need, what CPU and memory requirements they have, what underlying hosts they need. They might need specific GPUs. A lot of these images are actually broken. They might need specific images, GPUs. And we take that and we apply it to all of the clusters across Uber based on decisions we make. The idea is that service owners can give us quite basic, high-level goal states for what they want their service to look like, and then we will translate that into something much more in-depth specification for what we will actually deploy across our fleet based on policy and based on what they've asked us for. So I'm actually going to just refresh this tab to see if I can get the images to return. Ta-da! Yeah, see, this is why I'm a senior software engineer. So previously, Up has been using a system we built called Peloton, which is built on Mesos. Back in about 2017, we looked at using Kubernetes, and we saw some people showing like, hey, we've managed to get this cluster going with like, it took us a load of hacks and it's like really broken, but we managed to get 1,000 hosts on this Kubernetes cluster. And we looked at that blog post in 2017, and we looked at our like 10,000 servers, and we decided, yeah, maybe not, maybe now's not the time. So we ended up using our own system built on Mesos, but over time, obviously, Kubernetes got better and better. We saw more small and medium companies pick it up. We saw half the Fortune 500 have picked it up now. And Mesos has, it became harder to reach out to the maintainers of Mesos or to maintain it at all. It became a bit dated, and we were also finding it quite hard to actually get specialized knowledge in Mesos. So we ended up deciding that we were going to move to Kubernetes. When we were moving, we had some pretty key requirements. We wanted this to be something that is touchless, so something that our engineers in America and all over the world don't really notice is happening, and it doesn't require disruption to their service. It's something where we wanted to be able to do it bit by bit rather than just a huge leap of faith. So we wanted to be able to run both the old system and the new system side by side and gradually shift our infrastructure bit by bit onto Kubernetes. And we didn't want our engineers to have to do anything. So when we thought about that, we thought that we're going to have to define what we need to do to actually do this migration in that way. And we ended up saying that it's this idea of portability. And portability, the idea is that the services across Uber then become independent from the orchestrator they're on and the host that they're on. Previously, this may not have been the case for quite a lot of services, and that was a big story in its own right. But portability is super important because it means that we can, it means a few things. It means we can do this migration touchless, as I said, where we can just shift people to the new orchestrator without them having to do anything or notice. It means that services don't have to come down and come back up because services would be resilient to working on the new orchestrator and should work out the box. And it also means we can do more migrations in the future. We didn't want to just build this portability concept once, use it to migrate to Kubernetes, never enforce it again, and then the next time if we want to move to, I don't know, in like 12 years, Kubernetes 2, or whatever the heck that is, that we'd have to use it again. That's already coming useful. We're also migrating from on-prem to multiple cloud providers, and we're using this same portability concept there. So portability is built of two things, really. Movement tolerance, which is the idea that we can move services between different orchestrators and different platforms without it causing disruption. That's one end. And also its concept of distributability, that we can have services running on different hosts, and those services, as long as the hosts are within the bounds of what that service needs, for example, if it's a GPU service that needs like an RTX 5000, then it will get that. It shouldn't matter what host, in what rack, in what data center that's on. So that took quite a while, but we got all of our services to a state where they were portable, and that meant we could move on to the migration. So this is roughly what our actual platform looks like. A long time ago, before we moved to Kubernetes, this would have all been Peloton clusters across here, but right now it's a mix. This is actually shows it half and half. It's more like 80%, 90% Kubernetes, 10% Peloton now. But we have a lot of stuff now. We've got, yeah, I think I just updated that number today, 2.7 million CPU cores across our fleet. They're distributed in multiple regions. So one of our regions is the US East Coast, one's the US West Coast. There's a region in Korea for complicated laws they have that's kind of like GDPR-like. And inside each region, there are multiple availability zones. And you could think about those similar to an AWS availability zone, or like or like one data center. The idea is that availability zones, one going down shouldn't mean the others go down in the same region. And then inside each zone, we can have multiple Kubernetes clusters, multiple Peloton clusters. They could be on-prem, they could be on Oracle Cloud, they could be on Google Cloud. It depends. And then where we slotted in Kubernetes in this is we always expressed the concepts of what we wanted to deploy in quite abstract and generic ways in terms of we had the idea of a job and then a pod. And before that would be translated into Peloton commands, which would then run on Mesos through the Peloton backend. And we just slotted in a new backend called the Kubernetes backend, which took those same generic types from before, so the whole system didn't have to be rebuilt. And it then translated them into Kubernetes specifications that were then pushed to our Kubernetes clusters. But it wasn't just as simple as that. There were a lot of challenges, but I'm going to go over a few. We had some issues with risk, we had some with reperformance, we have some container snapshots. So let's talk about risk. So one of the big risks we had is we didn't want, midway through this migration, to cause a big incident. And so there's two sides to how we made sure that we reduce risk in this. The first one is how up controls the rate of change when it deploys services. So in some places before, I've seen the head of the mainline of source code is reflected as quickly as possible across infrastructure. And that's great in that you get immediate feedback, but if you break something, then you get immediate feedback when your service goes down. Our system is a bit more complex. A bit more complex. So what up does when service owners make a deploy request is they tell us what they need, so CPU, RAM topology, etc. We look at their actual state across the fleet, not just against Kubernetes here, but against Peloton too, across all of our clusters. We take those together, and we diff out what's different between what they asked for and what is actually running right now. We then take those changes, and we and we turn them into a set of steps that we need to do to go from the current state to the state that the user has requested. Each step is then an operation, and it's a set of gates that decide whether that operation was successful. So in this case, for example, I've got a step here, update the deployment spec on this Kubernetes cluster, and the gates for it are that the new container is deployed, alerts didn't fire, and we wait 10 minutes to make sure the alerts aren't just going to fire a minute after it's deployed, for example, when it got requests. Oh, that should... No? OK, that worked. OK. Yeah, so this is actually what that looks like in our system. You can see here these steps have already finished running. And then this one is running right now. It's upgrading this Kubernetes cluster copy of the service. And it's going to then watch its alerts. It's going to wait for about 2 minutes. And it's going to check that the instances become reachable in this thing called UNS that I won't go into. If something goes wrong, for example, I start rolling out my service, I apply this step here to apply the new service version with a gate the container is healthy, and that gate fails because the container is not healthy at all. Then we perform a rollback, and damn it, let me just, if I do this, maybe, ooh, hey, they should give me a promotion. Anyway, so when we do that, we build these, we end up doing these rollback steps. So when we roll back, we look at all the steps that we have executed or began executing, because we only execute steps one by one. And we generate a rollback step for them, which is based on the previous state of the system, which we saved before when we assessed what we were going to change. So in this case here, this is rolling back. So all of these steps that have already ran have got corresponding rollback steps that are going to bring them back on the clusters where we changed stuff to the state they were in before. That normally solves the problem. Of course, if the existing setup was already broken, then there's not really much we can do. But most of the time, changes are what actually caused the bugs to appear. So yeah, so the rollback step is then to apply the previous service version. That runs, and then we're back to healthy. The other thing we do to make this migration a bit less risky is service tiering. So inside of Uber, all of our services are given a tier, and a tier essentially indicates how important the service is to the business. So at the high end, we've got tier 5, which it doesn't really matter at all. I know that there's a bot that runs an internal foosball league in that tier. And on tier 0, we've got, if a tier 0 service is down, then the app just doesn't work. So it says critical path here. When we say critical path, we mean the minimum set of things that need to be up for you to just be able to request a ride, get in the car, get to your destination, get out. And obviously, if those are down, then people can't earn a living, which sucks. So when we performed our migration, we started with these higher tier services first. And so, there is actually an image there of a Kubernetes logo, but you're just going to have to pretend it's there. We started with we started with these higher tier services first. And then that gave us confidence that, and then they were effectively the first ones that soaked on Kubernetes. They were where we ended up finding bugs in our placement logic or bugs in how we did this migration, because of course nothing's error-free. And then as we got more confident, we moved down and down through the lower tiers until we had everyone onboarded. There we go. Yeah, and that's basically how we worked on reducing risk. But there's also some features that engineers at Uber are quite used to that we had to bring along with us. One of which is container snapshotting. A lot of engineers at Uber debug their failed services by looking at container snapshots. They look at the service logs, but they also look at what was on the file system. When their container crashed, to understand what went wrong. Right now, before on Peloton, they could just access that really easily because Peloton keeps all of the container artifacts for a really long time before getting rid of them. Obviously, Kubernetes is a bit more efficient and cleans up quite well, so we had to do something here. What we ended up doing was we built our own artifact uploader and had that upload to a blob store we have called TerraBlob on container exit. How that looks is it's a sidecar container on each of the pods that we run on Kubernetes. That sidecar container waits for the pod above it to exit, and before that it can exit, it stops the pod, snapshots it, takes that snapshot, pushes it to the blob store, and then it allows the pod to kill itself and go away. That then means that end users can go on our blob store and get their container snapshot, and they're not mad at us for taking away a feature. Other thing we found is that we send a lot of requests to our clusters, both engineers and the platform itself, to assess the state of everything. Particularly on Kubernetes, most of the requests we get are things like, tell me about every container for this service, which has to mean that you then have to branch out to every single cluster every time you do that, because you need to make sure that you capture everything. We found that when we did this on the test cluster, etcd started stressing out, so we ended up having to put a shimmy in the middle. So we put this little, there is a person in the missing image. We ended up putting this service in the middle. It has an informer on all our clusters, so it then becomes, instead of a pulling-based system, it becomes a push-based system. Events go into this system. They get indexed in there as well, which is quite nice. And then users make requests to that, and that's where they serve their data from. Obviously, that means that this system is not necessarily up to date with the actual source truth on the cluster. So the way that we ended up fixing for that is, luckily, our servers are really synchronized NTP-wise, like within 0.01 seconds or something like that. So we just use time. I know resource version exists. I know it's a number. I know that maintainers keep saying do not use it as a number, even though it's the etcd resource version underneath. But we ended up using time instead because it's just a lot easier for especially when our NTP clocks are synchronized, it's just a lot easier for end users to just give me data from right now, and then to wait for that data to come in. Okay, so putting this all together, this is actually what it looks like in our production system. So say I am over here. This is my test service that's currently not on Kubernetes at all. The cluster would say Kubernetes if it was. It's on the system called Peloton. So I am going to try and migrate it to Kubernetes. I just have to type the service name in. Okay, default. Oh, no, not Peloton. Kubernetes only. Yeah, make it larger, sorry. That could, really? I'm not signed in, so you're going to watch me sign in now. Am I going to be allowed to sign in? Hopefully I am. Let's see. I am now I thought I signed in earlier, apparently not. Okay, so the command itself isn't important. Okay, so now if I refresh here, so now this service, it's doing what I said before. It's looking at the current state of the service across our fleet. It's looking at what I just asked it to do, which is move it to Kubernetes, and it's generated all of these steps here that it's going to execute. So the first one here is it's doing a thing called make before break, where it's going to make all of the new containers on Kubernetes, and then it's going to delete the old ones from the old Peloton system. If this break, so in the end of that, you end up with something that looks like this. This is one I made earlier. For the record, those aren't like timestamps from when it started. I just made sure this worked at midnight last night, so you know, always prepared. So then you can see it's created all the things on Kubernetes and dropped them from Peloton. And as I said before, if something goes wrong and we need to roll back, it'll look at the steps that it's already started doing. It will it will make corresponding rollback steps for those, and then roll back onto Peloton. Is this going to work? I hit the button. Let's see. Did I actually hit the button? Yes, now I did. Okay, now it likes me. And now it's creating corresponding steps for the things that it did do to roll back onto Peloton, so it's coming off of Kubernetes now. So yeah, that's how the system works. And so, next slide. No, I don't want to play the contingency video. So, so what did we learn at Uber? So Kubernetes wasn't the silver bullet that's the be-all, end-all solution to all of our problems forever. I wish. We had to build a lot of stuff on top, especially because there was a lot of making the system feel and look like the old system and bringing across old environment IDs and old behaviors from the old system. There were also a few features on Kubernetes that just didn't exist for our use cases. So we used a lot of CRDs to do this. But that flexibility was super useful to us. It's not, Kubernetes isn't very opinionated about what you run on it. You could run pretty much anything. You don't even have to run services on top of Kubernetes. In fact, there's a few people in our company now who are just using Kubernetes for things like, what is it? They're using an operator to do network routing and things like that. And that flexibility is super cool to us. And it makes this a whole lot easier. And the first million calls were the easiest. Most services were pretty basic, didn't have a dependence on the underlying systems, weren't exotic in any way. But we found that a lot of our end users had built a lot of dependencies on documented and very much undocumented features of our old system. One of the ones that annoyed me the most was that some people had realized that some people didn't want to do leader elections, so they'd realized that the first container of their service always had -1 on the end of the hostname, so they were directly reading the hostname and looking for that -1 to actually do anything. That was annoying. So yeah, they use actual leader elections now, and they can't do that anymore because we don't expose that behavior anymore. But yeah, our ability to move services bit by bit and to very easily roll back because we're doing these small changes, it reduced the risk significantly so that we weren't having to effectively do these big leap of faith changes where we just move the service, and if it broke, we're just screwed. So in terms of migration status, we're pretty much there now. We're like 88% done. We've got some pretty big clusters, about 5,000 nodes. It's not that we couldn't go above 5,000 nodes, it's just that we don't really want to get into the packy territory of running huge clusters, especially when we've got prod on it. So we're probably going to stay around there and just flesh out more clusters if we have to. Our largest clusters now, yeah, are about 50,000 pods and 7,000 deployments across 5,500 nodes. The nodes won't go up from there, hopefully, but we'll see. Yep, and now we've moved our stateless fleet to Kubernetes. We have a load more stuff. We have our stateful stuff, which is up next, which obviously has its own very unique challenges. And do come talk to me if you want to hear me about that. And also, I'll be at the Contributor Summit on Tuesday saying about that as well. And we also have our batch workloads and daemon set workloads, but they will be moved eventually. So a lot of stuff to go. And yeah, and that's it. There are QR codes there. Yeah, that is basically where we are in our migration journey. Thank you for listening. And yeah, any questions? Let me see. Oh, are these QR codes going to come up now? There we are. Cool.
Do we have any questions? And not about wading through your how do you call this, Uber builds or something like this, or questions around this?
So would you change anything about a migration process with the experience you have now, or would you add all those behaviors?
I mean, I'm not sure we would. We kind of had to do the portability stuff before the migration, and I think it was so worth it, because before we were at the point where in the past, service owners were very much hard-pinned to underlying hosts, and getting them off that wasn't just good for the migration, it was just good for the resilience of their services fundamentally. What else? What else though? I think maybe we should have, I think the only thing I would have changed is I might have been harsher on service owners about being portable, because it took over a year to actually get everyone 100% portable, and most of that was a long tail of 5% of services, which took 6 months of us basically saying, we're just going to move you then and your service is going to crash and it's going to be all your fault. So yeah, that's, beyond that though, it was, yeah, I think we went as fast as we could without risking things.
I have another one. How much did you rely on the rollback feature?
I mean, we use it quite heavily. The other thing that we had though, even if your service crashed after moving to Kubernetes, is we could just run the inverse of that command I just ran in my terminal to set your placement mode to not Kubernetes, basically. So the rollback feature and that command to just place you back were effectively, they're cost-free, because all they do is move one service off of the Kubernetes clusters and back onto the old system. So that definitely quite heavily de-risked it, that we had that option, and that we could run in that dual mode where we had both systems available to us.
Thanks for the talk. You mentioned about stressing etcd.
I'm curious, like, were all engineers directly querying the Kubernetes API, or did you have any sort of backend where you also were able to get that data from, like an observability or anything like that?
It was a mix of both. So every time, for example, if I go back here, when I'm on this page on the front end, this is having to query every cluster to work out where I'm running, for example. But also there's a few things, for example, to optimize how many CPU and memory footprint you have, for example, things like that. And there's another one that looks at how much your service is costing us. And they're all also doing big scans across everything. And all in all, that's what ended up adding up to cause us to go, okay, we can't just do direct reads against etcd or we're going to cause issues.
Okay, another question. Congratulations on the milestone, firstly, migrating that. But you've stated that common resources like deployments and stuff weren't feasible for you. Could you go with an example?
Yeah, sure. So one of the things that a lot we do is what we call in-place upgrades. And one of the parts of that is prefetching. So one of the things that we found particularly annoying about the default behavior on Kubernetes is that you upgrade to a new image of a service. The new pod has to basically wait for a really long time to pull the image, especially when this is more for the exotic services, but there were definitely services I saw that had like insane, like 20 gigabyte images, and that would take so long to come up that our system was like, it's not coming up, it must be unhealthy. So one of the things our CRD does, for example, is it prefetches a new image before starting the rollout of the next version of the service. Behaviors like this. There's also some stuff that I can talk about a bit more, maybe if you want, about C groups and things, but we'll get into that. I'm actually going to talk about that as well at the Contributor Summit. Anyway.
Yeah, thanks. So you touched upon this a little bit, but I see like the portability stage was probably the most taxing because you probably had to deal with other teams.
Yeah.
Could you go into more detail of how you actually dealt with that? Seems like 80% of the groups were already portable, we're using 12-factor app and what have you, but it's the next 20% which is the most difficult.
Yeah, so the way we approach portability is the first thing we did is we marked every service as not portable, and we used the fact that we have this gradual change system, and we used a very similar thing to the Kubernetes thing where each service had a portable or not portable flag, and if you marked it as portable, it would make sure it was distributed across multiple machines to see, is it really portable? We used that same concept for the portability drive. We started everyone as not portable. We made a change to say that you are, saw if it got rolled back. If it got rolled back, you went onto a long tail of services we need to look into more. Once you're on that long tail, it depended on the service, but there was mostly like a grouping of things it could be. It was dependence on host. It was something about latency. And we just had to work with service owners to get that through. It required a lot of buy-in from leadership because it pulled people off of, rather than improving their end product, they're now having to spend ages building a new leader election system because they were using a hack before. But no, in the end, it was definitely so worth it because not only is it the resilience point, but I mean, yeah, we're also migrating all of our stuff to cloud providers right now, and we don't have to really do anything because, we don't have to really moan at any service owners anymore because they're all resilient to both their control plane and the host they're on.
Okay, one question regards networking. So how you achieved to switch over load balanced from old workload to new workload?
The switch over from what, sorry?
From the old system workload to the new system workload. How you switched over the network traffic and so on.
Oh, yes. So that is done by a system called Muttley. And Muttley is basically like the load balancer that sits in front of services. Can I see it on here? I probably can for my test service. So, of course I can't. Okay, let me actually get a real service then. This is the one that does the re-performance thing I said about. So Muttley looks across all of your clusters across our fleet. And it works in a similar concept to how I said about up, where there's generic representations that then get translated from both Peloton and Kubernetes, right? Muttley then discovers where you're running. It builds out this big group here. And then when requests come in for your service, they get distributed across there. There's also some other stuff here. There's like a restrict region thing. And that just basically means that when it can, you'll stay in the same region, because that's cool for latency. But that's how does that answer your question? Cool. Yeah, this is all us. This is all, all we built it. Yeah, I know. Look, we've got open source stuff too. If you use Zap, that's us. Anyway.
Any more questions? Are you planning to release this as open source, your IDP? Or?
Okay, so this is a long thing. So I want to, there's also some other people who want to. What basically ends up happening is we go, wouldn't it be awesome to open source this? And then we go, yeah. And then we go, okay, so who's going to flesh it out from the, the Uber repo and turn it into an open source product? And everyone goes, not me.
We have one question, just a second.
Not a real question, though, but could you put up the last slide with the QR codes again?
Yes, I can.
Thanks.
There you go. Do the images work? Yes, they do.
A part of this, thank you, Lucy. And we continue at 4 p.m., so see you later. Okay, everyone, welcome back. We continue with Chris Kuhl on creating a common framework for EBPF data collection. I'm very excited for this one and say welcome, Chris.
Hello. Mic check, mic check. Is the mic working? You guys hear me? Okay, good, thanks. Yeah, so my talk's about basically making EBPF easier to use. And sometimes you do that using a framework and other tools. So we're going to look at that. My name is Chris. I am a principal technical PM at Microsoft. I'm also one of the photographers for this event. I'm also a founder of this conference, and so I've been to all of them, and this is definitely a very interesting venue for this, so awesome. Great location though, right? Okay, so this presentation is basically going to be divided up into 4 parts. We're going to look at some definitions, so what are we actually talking about? I want to give a short intro to an overview to EBPF. And of course, we had a very detailed presentation earlier today, so I'm going to kind of build on top of that. And I want to talk about why an EBPF data collection framework is needed. And then I want to show Inspector Gadget in the context of a framework. By the way, yeah, I kind of threw that in there here. But you know, we're building this framework, and it's called Inspector Gadget, but I'll get to that in a little bit. Yeah, definitions. I want to talk about what is EBPF, what is data collection, what I mean by data collection, and what is a framework. And so on the EBPF IO website, we have this definition, which is, you know, uses superlatives like, you know, revolutionary technology, and then it kind of goes into with the origins in the Linux kernel. In this context of this talk, we're only going to be talking about the Linux kernel. It's become so popular that, you know, other operating systems, including Windows, is implementing something very similar. And also you can run, you know, there are also things called uprobes, which allow you to run EBPF in user space. And so, but we're going to be talking about the Linux kernel stuff here. And so the next part of that is they can run sandbox programs in a privileged context, such as in the Linux kernel. And it's used to safely, efficiently extend the capabilities of the kernel without requiring to change the kernel source code or load kernel modules. Now this is the revolutionary part. So because now we can dynamically add features or functionality to the Linux kernel. So one can say that, oops, sorry, I went the wrong way. So basically, the Linux kernel is now a runtime for EBPF programs. And I don't think that's really an exaggeration. You can do so much with it, and that's why it's being used all over the place, and people are talking about it. And so, but what is meant by safety? So EBPF programs cannot harm the kernel. So they cannot crash the kernel. They always run to completions, are limited in size, and they must be of finite complexity, and they cannot directly access memory. You need a helper function for something like this. And so how do we know this? As the talk earlier discussed, it uses what's called a verifier. And also, as that talk discussed, I'm not going to go into that because it's very complex. Let's just trust it. And it also requires privileges. So you can't just load these being a normal user. You need to have privileges. So note, this does not mean that EBPF programs cannot do harm to your system. For example, if you load a EBPF program in there that randomly routes your packages or drops them, you're probably going to run into issues. And so it does not crash the kernel, but you should, just like with any process that you load onto your computer or your server or whatever, you should know what it's doing and not just run random things there. I went the wrong way again. So why is EBPF efficient? EBPF programs run in the kernel space. They're just-in-time compiled to native machine code. That means they're just as fast as the code in the kernel itself. They're event-driven, so they don't run all the time. They just run when things happen. And it avoids expensive context switches between kernel space and user space. Now, this is very important for the data collection part, because often you would have to send all this information up to the user space and then do the filtering there. And so that's a lot of context switches that you have. With EBPF, we can actually do the filtering inside the kernel. And this limits the amount of stuff we have to send up to the user space, making it way more efficient. So there's some popular eBPF projects that you probably know. For example, Cilium, Falco, and Pixie. These are used for different cases. Sometimes they overlap. But basically, you can use them in eBPF in a lot of different ways. What we're going to focus on this time, well, actually, what I want to say is Inspector Gadget itself doesn't really care what you do with the data. It collects data. If you want to build a security tool on top of it, you can. If you want to build an observability tool on top of it, you can. Or a detection tool, alerting tool, it's up to you. And this is, so now, what is meant by data collection? Now, I'm exactly talking about the extraction and augmentation of systems data. So when I talk about extraction, that means pulling it out of the system. Augmentation means there's some kind of, you need to add something to it. It's not data analysis, it's just adding something to the data as it comes out. And we'll talk a little bit about that in just a second. So we are not talking about storage or analysis of data. And so what does it mean when I say a framework? And actually, I wanted to ask you folks that. And you can just shout it out. What is a characteristic of a framework? What should a framework do for you? Okay. Plugins, accessibility, maybe? Okay. I'm sorry? Okay, one at a time. Okay, I assume that means removing boilerplate instead of adding boilerplate? Okay. More? An abstraction, yes. Okay, anything else? Huh? Framework laptop, he has a framework laptop. Thanks you for the advertisement, sir. Okay, anything else? All right, so all of those things are kind of saying it should make things easier, right? So let's take a look at how BPF is right now. So we had a discussion, talk, it was, I think, the first one. That went really deep into things. And it kind of left for the audience to look into the libraries that load these. So actually, that's what we're going to look at right now. And so, first of all, this is a BPF program. It's a very short one. It's not as short as the one that was shown earlier today. But basically, what this does is it's telling us which processes are being exec on our system. So, but I think it's better to look at this inside of inside of here. Let me get to my demo. Okay. So here, I need to make it bigger? Yes, bigger. Okay. Let's see how this works. Okay, that's going to be, yeah, okay. So here we have a few files. The only ones that are really part of the logic here are the kprobe file here. This is going to be our BPF program, and the main Go file. Now, what I'm going to be using for this is the EBPF Go library that's developed by the Cilium folks, or isovalence folks. And so I'm using their let's look at this real quick. Oops, sorry, it's doing some updates. Okay, so here we have a BPF program. It's defining a map. And the talk earlier talked about this SEC, where it basically puts it in a section of the ELF file. And this is the section. And so it's basically just looking for a process that's being exec and putting it in the map. Okay, very simple. So if I go, oops, here, this is the Go code. I'm not sure why this is not, here, let me do this. There we go, that's easier. And so if we go here, we'll see that we have some libraries. Now, interesting enough, so this library actually uses Go generate to actually convert this, to basically make this suitable for this Go code. And so that's why we'll use Go generate in a little bit. But basically, what I want to show is basically, I don't need to go into this code at all. But basically, you have to do this for every BPF thing BPF program you have. It's a lot of like boilerplate is what we're saying. And so then here at the bottom, what we do is we attach it to the kprobe for that. and then we are basically saying we're going to return the result. I think it's every second here, basically using a ticker every second. It's going to basically read this map where that information is being put into from the BPF file. And so you can see it in user space. So let us close that. And if you look here at the make file, oops, sorry. You can see I'm going to be running this build here, go generate. And okay. And so let's do make build. And so this basically has given me a Go program that I can then run. And so as we saw in that make file, we have, let's just run that again. So if you see here, we're going to do sudo because we need permissions to run this. And so let's do make run. I have to put in my, oops, I put in my wrong password. This is a VM I'm running on because obviously it has to run on Linux. And so if I go into here and I go, word count, make file, and go back over here and I see that there's been things executed. So we can see that. And so this helped us get this information from the kernel. You can kind of see this basic process. So let me get out of here. Okay. And let me go back to the presentation. So what have we done here? What have these EBPF and this helper libraries given us? They've given us a very powerful and performant mechanism for getting systems information from the kernel. It's a means to programmatically load EBPF programs and an interface for retrieving the data from the maps in user space. But there are many things that you likely want to do with this data. First of all, and very importantly, which is a whole thing into itself, is you want to relate that data to your system. So when you get information from the kernel, it has no idea about Kubernetes pods or even containers, because that's not really a concept in the Linux kernel. They'll give you things like mount ID and things like that, and then you have to relate that yourself. And we call this enrichment, and we'll get to that in a second. You'll likely need to augment this data in user space. And this might be because when you take the data out of the user space, you want to add something to it before you send it on to your services or logs or whatever. And so it could be that you want to send something from like a service that you have or whatever. But it could be that it's necessary because BPF programs, like we talked about earlier, are kind of limited in what they can do. And doing like string manipulation or something like that, sometimes you can't, and sometimes you just don't want to do it inside the kernel. And so you might want to do that when you get into user space. And so, for example, we have a DNS gadget, which you can see in this repo it's one of the tools we have. You can go check it out. Because the DNS requires some string parsing, we actually need to do that in user space. And so that's what I mean by augmenting the data. And we might need to send this to a service. We want to send this to our logs. We want to send it to our time series database, or we want to send it to wherever, or trace server. And you want to share, you might want to share these, right? You want an easy way to give what you created to somebody else. Or, in the next point, you probably don't want to become a Linux kernel. Not everybody needs to be. And so if we can create a mechanism like a framework, for example, where you can basically just find some off-the-shelf programs, have a framework where you can like easily run those and do all this stuff that you need to do outside of the BPF world itself, that would be very nice. So this is, okay, make sure I don't have anything else there. So this is when I want to introduce Inspector Gadget as an eBPF data collection framework. Now I say introducing as a framework because you can actually use it directly using these gadgets. And you can use it as a tool to inspect your system. So we're going to look at it as a framework. And so what is Inspector Gadget? It's an eBPF tool and systems inspection framework for Kubernetes, containers, and Linux hosts. When we originally created Inspector Gadget, it was only for Kubernetes because there was really a gap. Like there was this really cool project called BCC, which had a bunch of BPF tools that you could run. But how do you do that inside of on a cluster on all your nodes? And so we created Inspector Gadget for that. And these these BPF programs were kind of built in, and right now we're moving to making these image-based. So basically OCI images we'll talk about in a second. So let's look at the concepts. There's some things that are in development, and I put an asterisk on those. So gadgets are they encapsulate EBPF programs in OCI images so that we can reuse common container workflows and tooling. So basically, if you know how containers work, you can kind of know how this works, because they're the same images. And they include EBPF programs, metadata, which we have one, but we're still defining it because we're trying to figure out all the capabilities that we can define there. And then an optional WASM module. Why WASM? Because we need the user space processing, and we'll get to that in just a second. So we talked a little bit about enrichment. And so this is the process of mapping low-level stuff from the kernel to higher-level things. Right now, we support Kubernetes. We support the various container runtimes. We even have a PR open for systemd, so you can see which unit or service it's associated to. And it's interesting that this is not only Kubernetes anymore. I want to emphasize, because this has been over the last year and a half or so, we've made this generally available, because we got the question of what happens when your Kubernetes goes down. And you basically want to sometimes get under that, and so you can see what's happening there. But this also works in the reverse, right? We're not only enriching data that comes out, we also want to filter data on those high-level concepts. We want to say, only show me the things from this container. And so we need to translate that into the BPF kernel world. So user space processing. So we chose WebAssembly for this. And so currently, WebAssembly is great because you can write it in any language that WebAssembly supports, and it provides a sandboxed environment, kind of similar to BPF, where we can basically embed this in our workflow, and you can include that in your gadget and just make it a part of the data processing pipeline. So data export, and this is like our next big challenge, is to make this work really nicely. You can configure gadgets. The idea is to configure gadgets to send the data in various formats to various services. So it might be a time series database, it might be logs, it might be traces, it just might be the CLI. But you should be able to decide. And so when we talk about this metadata that I said was in the process, this is one of the things we're working on is basically having the ability for gadgets to define their capabilities, and so you know what kind of data is coming out and where you can send it. So I'm going to show a demo of building and running a gadget. Let me get over here. So this is actually, if we do this, I'm inside of the inspector gadget source code. This is in the subdirectory gadgets, and then we are specifically in the trace open gadget. And you can see here, if we do this again, that we have a gadget YAML. This is the metadata, and we have a program.bpf.c. This is the BPF program. This is by convention, we name them this, and if you name them this, you don't have to add an extra build.yaml file, which I think it's called, where you specify it, but you can actually override. For example, if you got this and you wanted to add something, you could add that and then add a build.yaml file and then point to your source code and then rebuild it. So we're going to show basically the process for building this. And so I don't have to type so much. I have made these make files. And so first we're going to start with build. And so yeah, we're going to basically IG image build. And so IG is the Linux command line tool. We also have a command line tool for kubectl gadget. That does not have the build functionality. That should be local. It should be in the cluster. And so this is why I'm using this, and I'll also use it for the demo. You can assume when I'm actually running these things that you can do that just as well in a Kubernetes cluster. So, right, let's run this. So make build. So, and I have my... You can see we have this behind an experimental flag because currently we have the default is the built-in ones. That'll be converting in the next months, actually, pretty soon. So we successfully built this, and if we do our make list, we see that we have this in there. It's called Chris Trace Open. And just so I don't expect you folks to remember everything here, because I don't. And so we're going to do the run, okay? And when we run it, you can see we've done IG run. We reference this, and because it's local, I don't have to do the whole repository. 10 minutes? Okay, good, thanks. And then I specify that I want to filter on the test trace open container. So I'm going to say I want only information from this container. So let's do make run. Good. It's waiting. There's not anything that's happened in that container. You know why? Because that container has not yet existed. And so if I do make test, actually, I think, yeah, I don't think I can. Let me run this directly. And if you see something that's obviously wrong, let me know. Man, why am I not able to leave? What's that? Oh yeah, shoot, that's right. So let's go in here. Yeah, I think when I tested this, yeah, okay. So let's go in here and just remove that, because I just want to get a terminal, right? Damn it all. Okay. Okay, so let's do this. So this is working now, and if we go, I just want to go back over here. Nothing's really happened, and if we open a file, let's see what we got here. What do we want to open? Oh, I know what we can open. We can do Word, we can do less, and then we can do etc hostname, right? Boom. Oh, I didn't need to do that. I could have done cat, right? But that should serve our purpose. And you can see right here now, it shows us that we opened the host name. This might be interesting, if, for example, if you want to see if somebody's trying to open a password file or whatever. But that's just a demo of how this basically works, right? It shows the filtering. Actually, I have a whole slide about what that showed. So let's do that. All right. So let's review what we did, exactly. So we compiled the EBPF program. We built an OCI image that includes our program and the metadata. We enriched the EBPF data with high-level resource info, but we also did it the other way. We filtered based on that. We ran an EBPF code, filtered the data based on these high-level resources, and we returned the data to command line. Now, like I said, we were working on the export stuff, and that should be able to send it anywhere. And by the way, you can already send it pretty much anywhere, because you can get it as JSON and do what you want to with it. And so how can I use this? Well, you can use this directly with the IG or kubectl gadgets tools. You can use it via a library. So you can actually consume this inside your application as a library and just use these gadgets. It's available, and I'm not actually sure what the status of this. I need to ask the team. Kubernetes CRDs and config maps, that's how you can deploy them and you can interact with them. And we're working on an API for this, and we actually basically have a plugin we're working on for the headlamp in the headlamp project that'll basically be utilizing this. So some Inspector Gadget users, there was a presentation earlier from the ARMO folks. They're actually using Inspector Gadget underneath for their BPF needs. It's in Microsoft Defender for Cloud, so it's running on lots of machines inside of Azure, and actually because they actually support other clouds, I presume, and other Microsoft teams. And there are others, and we actually need to start collecting users. So if you are a user or you know some, please let us know. Yeah, so to learn more, you can go here. I think I have a typo in here, but you can figure it out. Yeah, I got 5 minutes. And Slack is probably the best place to communicate with us. And we'll have a booth at the pavilion, the project pavilion, on Wednesday and Thursdays. I think Wednesday full day, Thursday afternoon. And then I will be presenting with the Microsoft Defender folks on and giving a small part of the Inspector Gadget part of that. That's the end. And questions, comments? There's a microphone right here if you want to take it.
First of all, thank you very much for the talk. When you ran your command line to build, it needed root. Why did it need root to build the image?
What I do?
In your build command.
So it's basically putting it in var. I probably don't need that, or we probably change it. Like I said, this is very early. But when I was doing my demo, I needed it, so I just added it. so yeah, I think that's completely okay to do sometimes. But yes, thanks for bringing that up.
Thank you.
Okay, without any further questions, I say thanks, Chris. And next talk will be Marcus Noble in 4:35. See ya.
Okay, thank you.
Can I have your attention, please? Please stand up. Please, no. Okay. Okay, we continue for the real Markus Nobel. Okay. Especially happy now to announce the session of a good friend. So Markus Nobel going to talk about from fragile, thanks for using this difficult word, from fragile to resilient, validating admission policies, strengthen Kubernetes. Sounds great. And yeah, welcome, Markus.
All right. Thank you very much. As Engin said, I'm Markus Nobel. So quick introduction about me. I'm a platform engineer at Giant Swarm, currently working on release engineering and CI/CD infrastructure. At this point, I've got maybe about 6 years or so experience running Kubernetes in production environments. Over that time, I've had a bunch of different roles. So I started off as an app developer building TypeScript, Node.js applications, deploying to Kubernetes. I was running three clusters, dev stage and production for a single team. I then ended up building out, moving into a more R&D style, building tools for the rest of the organization, and then finally moved into more platform engineering and ops for other companies and things like that. So I've dealt with a lot of different aspects of Kubernetes and the different personas that work with it. So hopefully what I say kind of embodies some of that. If you want to get in touch with me anywhere, generally Mastodon's the best place. I'm marcus@kh.social. Or if you want to get me on any of the other platforms that I'm not as active, they're all on marcusnobel.com and find me wherever you like. So, dynamic admission control in Kubernetes. So validating admission webhooks, mutating admission webhooks. Those of you that already know me may know that I've got kind of a love-hate relationship with these APIs in Kubernetes. The uses of these APIs are quite core these days to running production Kubernetes clusters. So they allow for things like defaulting of values, policy enforcement, so don't use the latest image tag, always use a non-immutable image tag within your clusters, enforcement of best practices, making sure PDBs are enabled, things like that. And also some cool problem mitigation solutions. So there's a nice one that I like, the log4 shell exploit from a few years ago. The way to basically turn off that code path that was exploitable was through an environment variable. You could use a mutating webhook to enable that in every single pod within your cluster to effectively make them safe from this exploit in one go. All sounds good, but while they are powerful, they do come with some level of risk. Now, this isn't the talk for today. This is actually the talk from Rejekts in Chicago of last year. I gave a talk all about webhooks where I went into the ways that these can go wrong and have gone wrong, and ways that I've seen them go wrong in production clusters and had to deal with. If you're interested in that, take a look at that talk from last year. Ask me about it afterwards, whatever. But today, we are here to talk about something else. So while these are powerful, there is this risk. Wouldn't it be great if we had a safer alternative? Well, yes, it would. And as such, we actually do, or kind of almost do. So I'd like to introduce you to validating admission policies. This was introduced as an alpha in Kubernetes 1.26, became beta in 1.28, and is going to go GA in 1.30 that's coming out next month after, something like that. Like the code freeze has just happened, and I've seen that the PR's gone in. So these are going to be available for use soon. So what are they? They are a declarative in-process alternative to validating admission webhooks. Now, by that we mean declarative in that they are defined by Kubernetes manifests, and they are in process as in inside the API server. So you don't rely on an external pod running your validation code or an external service or whatever. They use this thing called Common Expression Language, which I'll refer to as CEL, for their policy language. We'll come on to this in a short moment. And they use two main resources to define all this logic. So there is a validating admission policy, which describes the policy logic, and then a validating admission policy binding, which links the above policy to the actual resources you want it to apply to. All sounds good. So let's quickly take a brief pause and introduce Cell, just so we're all on the same page. For those that don't know, Cell, it's this language that's used for the policies, but it's very similar in the way that it does expressions to C-based languages. So if you've done any Go, Python, the syntax is relatively familiar. So here we've got an example of like self.min replicas is less than or equal to self.replicas, and self.replicas is greater than, or it's meant to be the other way around, but you know what I mean. No, it's not, max replicas. It's designed to be embedded inside other applications and other languages, and really it's a focus on like one-liners, so short bits of code that's not like hundreds of lines of code. It has a short number of built-in functions, so things like split, has, stuff like that, and these functions can actually be expanded with your own custom macros that you can add. And in Kubernetes, they have added several additional functions through libraries that you can make use of in validating emission policies. You may have already seen Cell in some other cloud-native tooling. So Caverno, for example, uses it for some of their policy expressions. Tecton uses it in their Tecton triggers to define matching logic and stuff like that, as well as a bunch of other places you may have seen it. One thing that's quite interesting about it, it has this concept of a cost per operation that can be calculated ahead of running the actual function. So if your policy expression is actually considered too expensive to be run, the API server can decide not to run it and block that operation. So we're not risking potentially locking up the API server doing an infinite loop, for example, or something like that. So it's quite nice. So with that out of the way, let's have a look at how we can make use of validating emission policies today. So we're assuming now that 130 isn't released yet. This slide will change as soon as that's released because it will be generally available. But until that point, as of 129, validating emission policy is not enabled by default. You must enable first the validating admission policy feature gate on your API server, and also the admission registration.ks.io/v1beta1 API. You need to enable both of those, and then you can start making use of this. If you want to try this out in a kind cluster, you can use this little config that I've got here on the right that enables these two things, and then create a new kind cluster with that config, and you can try out these as you like. So let's have a little look at what they look like. So I'm going to show you, I'm going to walk through an example that I've got here, which is a policy that will block the use of the latest image tag throughout our cluster. So we don't want anyone to use latest, we want them to always use a versions tag, for example. So first off, we've got the name of the policy. This is what we'll refer to later in our binding. So here I've called it prevent latest image tag, very imaginative. And then we've got a failure policy. So what we want to do, what we want to happen if it fails to run this policy. And the other alternative here is ignore. You'll want to use ignore if you want to maybe disable the policy temporarily, whatever. Generally, this defaults to fail, and that's what you'll have it as. Next, we've got a series of match constraints. These then allow you to define what your policy can work against. So in this example, we are defining it against deployments, daemon sets, and stateful sets. One thing to be aware of here is the resources you pick that your match constraint can match against kind of need to have the same spec API so that your cell query doesn't get massively long where you have to check, does it have spec.whatever? If not, spec.whatever, you know. So in this example, deployments, daemon sets, stuff, they all have a very similar spec.template.containers. Within the validations, we've then got a user-provided message. This gives you a human-friendly error message that can be displayed to the user when using kubectl or whatever. I highly recommend using one of these always in your policies, because if you don't, the error that is shown is the entire expression that has failed. And it's not very friendly to the user. You just get this big blob of like cell expression. It's like not great. And then we get on to the actual cell expression here. Now, one thing to be aware of that still now constantly catches me out is you are defining what an allowed resource looks like, not what you want to block. So in this scenario with the latest tag, we want to match against things where the tag is not ending in latest, rather than the tag where it is ending in latest. So just be aware of that. So what does it look like? We've got this thing called object. So this is a variable that's provided to us from Kubernetes. An object refers to whatever the resource is that we're matching against. So in our example, it will be a daemon set, a deployment, a stateful set, one of the three, against whatever this API request has been made against. We've then got, on that object, we are looking at the spec.template.spec.containers array. And we want to say that all, which is one of the self functions, for all of those, we want to check that the container.image does not end with latest or no tag at all, which then implicitly means latest. And then we also want to do the same for init containers. So because init containers on our spec is an optional property, we need to first check whether that property exists on our object. So we'll use the has function here. And if it does have init containers, we then perform the same check for the latest tag on the init containers. And then obviously we may also want to do the same for ephemeral containers as well. But these expressions get long pretty quickly. Once we have that, we then want to work with our validating emission policy binding. So as I said, this binds our policy to specific resources, to API requests, things like that. Until we have a binding, our policy does nothing. It just sits there looking pretty in our cluster. It's very minimalistic as to what we've actually got in here. So first up, we've got the policy name. So this is the name of the policy that we've just seen, so prevent latest image tag. We've then got this array of validation actions. So there's three possible options here. There's deny, which, if not met, will prevent the API request from happening. There is warn, where, if met, it will still let it happen, but it will show our error message to the user. And there is audit, which creates a record in the audit log. Now, the reason that this validation actions is an array is that you can provide both warn and audit at the same time, so you can have that. If you provide deny, you get deny and audit explicitly. You just need to provide deny. And then finally, we've got match resources. So this here is where we can use label selectors and things like that to specifically match against a certain namespace or a certain set of labels on our resources or whatever. For our example, because we want to do cluster-wide and make sure it matches against any pod or any deployment or whatever that we're creating in the cluster, this is just going to remain empty, which implicitly matches against everything. If we didn't want to match against everything, we would do something like this. So in this example, I only want this to bind against labels that bind against namespaces that have the label environment prod. So effectively only applying it in our prod environment. So this is what it would look like. So here on the left, I'm trying to apply an Nginx deployment using the latest version of the Nginx image, which we don't want to do. And as you can see here, kubectl apply, and we then get an error message. And the underlined here is our user-friendly error message from earlier. If I hadn't provided this, this is going to be like this big with our cell expression shown and very confusing as to what's gone on. So we've blocked latest image tag within our cluster. Nice and easy. Not reliant on any external services. No worries about network going down, pods restarting. As long as our API server is running, which it has to be to do an API call, our validation can be applied. Very good. Nice and safe. So let's have a look at some of the more advanced features that this can support. The example I showed was pretty minimal in terms of what it can do. There is quite a bit more. So there are more context values that we can use. So I already shown you the object that is the reference to the object of the API request. You've also got available old object, which if this is a patch or an update or a delete operation, refers to whatever the previous version of the resource was. So you can compare what it was versus what you're trying to apply. And you've also got a request, which gives you some more information about who is making the API call. So for example, I may want to have a policy that only gets applied to people, to real users, to humans. The kubelet gets an exception. Kubelet can do whatever it wants. I don't care about that. It can do whatever it wants. So in this example, I've got a match condition here where I say I want to exclude kubelet requests. So the kubelet I know has the user info group's system nodes. So I want to match against if it's not system nodes, the policy applies, whereas if it does have system nodes, i.e. kubelet in this case, ignore it. The policy doesn't apply to them. We've also got parameters. So one of the nice things about having the policy and the binding means that we can have a generic policy, but have dynamic bindings in terms of how it's applied. So different namespaces could potentially have different variations of the policy applied to it. So we have this concept of parameters. On our validating emission policy, we defined a param kind, and we give it the API version and kind of a CRD within our cluster. This can be whatever we want. In this example, as you can see, it's just an example on rules.example.com, and it's a replica limit, which is what I've got here. This is a CRD that we've created. And then we can use that parameter in our cell expression through the params property that we get available. So in this example, I want to make sure that the number of replicas is less than or equal to the max replicas as defined in my parameter. Now, how we then end up using that is in our policy binding. When we are binding to that policy, we give it a param ref, which tells it what custom resource to go and apply to get those parameters from. In this example, my parameter is in the default namespace. And the parameters itself just look something like this. Nice, simple resource that just has a property max replicas, and in this example, it's 3. So my policy will say that the replicas has to have less than or equal to 3. Now, in a different namespace, that could be 30, and a different policy binding could then use that with a different value. But the policy can be shared across all of them. We've also got variables, not to be confused with parameters. Variables are defined on the policy and are ways to make reusable bits of cell expression. So as I said, cell is designed to be quite a short language, ideally, but it's very easy for these to get very long very quickly, and you don't want a very long expression within your nice, tidy YAML. So you can make use of variables, which can then be referenced within your expression to simplify things. So in this example, I'm defining a variable called team label, which will, if found, use a value from a label on the object and otherwise default to no team. And then I can use that within my expression as variables.teamLabel. Now, one thing to be aware of here is that the name of the variables has to be a cell valid name, not a Kubernetes valid name. So things with a hyphen in them will fail, whereas things with camel casing like we've got here are okay. One thing just to be aware of, because that's caught me out in the past. Another thing we could do is audit annotations. So as I said, one of the things that policies can do is provide additional data into your audit log, so you can make sure that your validations are being audited when they fail and stuff. You can use audit annotations to add additional metadata to your audit log, not just that the request was passed or failed, but you can add expressions using cell again to add more values, more data to the metadata that is shown in your audit log. In this example, we are using the actual number of replicas that was trying to be used and having that available in the metadata of our annotation, in our audit entry. You can have this as whatever you want, obviously. And finally, message expressions. So as you saw earlier, we use message just to give a nice human-readable message to the user when something goes wrong. Alternatively to that, you can use message expression, which is a cell expression that you can use to create the message that gets shown. This is useful, especially when using things like parameters, where you may want to show a more dynamic message to the user for when something goes wrong. For example, you can let them know that the max number of replicas is, params, not max replicas, rather than just saying your deployment needs to be below the max replicas. And they're like, what is the max replicas? So that's very, very useful in that case. So, how are we doing? That's validation covered. What about mutating, which is where a lot of the nice use cases we saw earlier with webhooks come from? Well, let me introduce you to KEP 3962 for mutating admission policies. As of right now, there is no version of Kubernetes that has this available. It is in the theoretical stage, let's say, at the moment. There is a PR open to add this implementation, but it didn't meet in time for the 130 code freeze, so it is likely going to be alpha version 131, which should be the first version where we can try this out. The general idea behind this is the same idea as validating admission policies. So it will run in the API server, it will be created using resources within your cluster, but it will be able to perform mutating actions on your API request. And similarly, it introduces two resources, a mutating admission policy and a mutating admission policy binding, and supports two patch strategies, apply configuration and JSON patch, whichever makes most sense in your scenario. For phase one of the release of mutating admission policies, it will only support adding and updating of values. They are planning for phase two to also allow unsetting, removing of values, but Cell itself doesn't actually support that in the language. So they're trying to get a bit creative in how they're going to actually do that. It may be that some functionality is tried to introduce upstream to Cell. They may kind of piggyback on a non-used function and this kind of thing. So it's unclear at the moment. But right now, it's going to be you can add data or you can change data, but you can't remove data as part of these. And as I said, it's not yet finalized or available for testing. So a quick example, it looks very similar to what we've already seen. We've got the same sort of match constraints. So in this example, we are looking at when pods are created in our cluster, so any new ones. The example that I'm showing you here, what we're going to do is we're going to inject proxy environment variables into all containers within our cluster. So in an air-gapped environment, for example, in a private cluster, we can make sure that all of our containers know where the proxy lives so that they can get out to the internet without us having to tell all of the deployment teams, you need to include this in your YAML. So we've also replaced validations with mutations, which makes sense. We use the patch type, like I said earlier. There's two options, apply configuration or JSON patch. This is exactly the same as what kubecontrol will use when you do a server-side apply, so it's whichever one. And then we look at the mutation. So something a bit new here is we've got this introduction of named types. So this is a Cell feature that allows you to have types within your expression. As of right now, it's currently unclear whether this capital O object is going to remain or whether it might change to something more like v1.pod.spec rather than this. But for now, this is what's in the KEP, so I'm going to keep with this. But this just says this is the resource, this is the object that I'm going to apply. And the object here refers to whatever the type of the incoming object was. In this example, it's pods, because that's what we're matching against. So on that, we've then got spec, so object.spec, and then containers within that, which is where we then want to make our mutation. So in our object, we have then, for every container, we want to inject these environment variables. So we're saying here, we've got the name and the value, so HTTP proxy, and then proxy.proxy.service, whatever. And we're going to append that to the rest of our environments within the containers. And obviously, if I have more space, init containers and ephemeral containers will also be shown here. Policy binding, pretty much exactly the same thing. All that's different here is we don't have validation actions because it's not a validation, but we reference the policy name and we have match resources. So, mutations hopefully coming in 131. Additional releases will hopefully see that fleshed out much more. What might the future beyond that look like? So basically, what is my wish list for the future? None of this is set in stone, none of this is concrete, this is all theoretical at this point, but things that I can see coming are generative policies, so being able to create new resources based on API requests. So tools such as Caverno, for example, already have this functionality through webhooks. They can create a brand new resource based on a particular API call coming in. Resource lookup. So we've got parameters where we can kind of define this is a specific resource that we want to be able to get values from. But sometimes you may want to look at the status of another resource, for example, and use that as part of your mutation or whatever. I can see that as being something that comes in the future. Something I know a lot of security teams are interested in is policy exceptions. So none of the validation or mutation or anything around that yet has any concept of being able to create exceptions to policies other than building those into the initial policy binding and stuff, which gets quite complex quite quickly. The abstraction tools such as Caverno and OPA and stuff already has this sort of concept of an exception resource that can tell you against that. Hopefully that's going to come in the future. And then I can also see quite a lot of abstractions coming. So Caverno, I know, are already working on abstractions on top of validating emission policies, and I can see additional tools and stuff coming later that will also add additional niceties and user-friendly stuff on top. So, in summary, I think it's time that we all start replacing some of those risky webhooks with in-process policies where possible. If we can get away with running more pods in our clusters and rely on the API server to do the work for us, all good. More resources for us to use for other things. As I said, VAP will be generally available in 1.30 for you to start using. If you want to use it today, use those feature flags. Keep an eye on KEP 3962 for mutation admission policies. I think we're going to see it as an alpha release in 1.31, but not sure as of yet, because the PR is still open. And I think we're going to get more of these abstractions and generative policies and stuff in the future. And with that, I'd like to say thank you. If you want any links to the resources and the slides and stuff, it's all there. Get in touch with me, ask me questions later in the day, whatever you'd like. Thank you.
Do we have any questions? Come on. I have a question, but I wait for the...
Hi, thanks for this talk. Super great presentation. With regards to, there was some talks about stale reads in Kubernetes.
It's what, sorry?
There was some talks about stale reads some time ago, and do you know if the old object coming in, is it served from cache or from actual consistent read? It just got me thinking when you...
I think it's from consistent read, but I'm not entirely sure. It's server side, so I would hope it was consistent read. I don't think it's from the cache, but I don't know for certain.
Okay, yeah, just...
I would hope it's not from the cache, because that's not entirely useful in all circumstances.
Any more questions?
James?
In your very first example that you showed, you were doing operations on, it was right at the beginning, you were doing operations on create and update. Mm-hmm. Does that mean it would miss patch?
Yeah, good catch.
I didn't know if patch was rolled in to update in this context or something.
It's whatever the API server classes it as, and I can't remember. Anybody know?
Is
patch different? I know it is from the client side, but I can't remember whether the API server bundles it as an update.
Yeah. But, okay, cool.
Maybe then.
Maybe. We'll find out.
I don't care. If people want to use patch, then they can bypass it, right? Whatever.
Okay, one question for me. How is your opinion with the mutating and the generative hooks in the future in terms of GitOps? So, do you think it's going to be...
I don't think it's going to be any different than today. We already see this logic with mutating webhooks. Like, there's plenty running in clusters everywhere that do this sort of thing. Most of the time, you'll see these, like a lot of defaulting logic, right? Things that you, we saw some talks earlier, you don't want to define everything in your YAML. Like, you don't want to define every single spec in your pod. Some of that stuff you just want cluster to deal with, right? The example of the HTTP proxy environment variables, like I don't want every single team within my organization to have to know that and have to update that if it changes. If I can do that at the cluster level, that's all good. Most GitOps tools allow for that kind of merge effect, and if not, there are options where you can kind of say ignore this value. But as we've already got it today, I can't see it being a huge problem.
So no danger for split brain because people can do this currently also.
I mean, there is a potential danger, but no more than today.
Okay, okay. Then if there's, oh yeah, another question. Good, good.
I'm sorry, but that got me thinking. Is there anything like the storage version migrator that if you apply a new policy, then it takes all of those deployments, daemon sets, stateful sets, and runs it through the mutating one or the validating one to actually check that?
Yes. So with both the admission webhooks and the admission policies, there is an order that they go through, that the API server, for every single API request, goes through these. First it does, let me get this right, I think it's validating admission policies, and it iterates through all of those. Then it does the validating admission webhooks, iterates through all of those. Then it does CRD validation, if needed. Then it does the mutating ones. If the mutating changes anything, it goes back and runs through again.
But I meant the stuff that it's an etcd already.
Is the final value that comes out of the end of that pipe.
Yeah, yes, but so say that you have some really bad data, and then you add this latest tag, for example, but you already have lots of.
Oh, sorry, it doesn't retroactively apply.
Right,
no.
but there's
it's based on API requests.
Right, but there's nothing that actually pokes those resources. No. Something for the future.
Sorry.
First, you jump to him, and second, he cannot film you anymore. So, okay. Any further questions?
I like to wander.
Just look out for Marcus, and thanks again for the nice talk. And
thank you.
Next up, we have Kim with Open Source Project Growth. So stay here, please. Okay, everyone, welcome. Welcome back. And I'm very happy to now present to you maybe today's non-technical talk. I don't want to say anything wrong, but still a very interesting talk. Everybody talks about open source. So I'm welcome Kim McMahon with, I did change the title, Parallel Paths, Raising Puppies and Growing Your Own Open Source Project. So a welcome for Kim.
Thank you. Thank you. So we have a couple QR codes up there. The one next to my picture is going to go to all of my social profiles, so feel free to click on that if you want to connect with me or email me. And then the one on the right is my slides, and it will have the slide notes that I can't see. So if I miss something and you read those notes, you say, don't forget to say that, go ahead and raise your hand. But I did this talk a month ago, and I just felt it was a real big snoozer. It was really about the non-technical needs of growing an open source project. And I was going into, you need a business strategy, and you need your messaging, and blah, 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 all this kind of boring stuff. And then I started thinking, well, there's parallels. I have this puppy, and if any of you follow me at all on social media, you know that I have this puppy. I talk a lot about her. She's like on every one of my shots in my social media. And I started thinking that some of the things about nurturing an open source project and making it healthy and helping it grow up to be a responsible open source project was kind of a parallel to raising this puppy and helping her be a responsible puppy in puppyland. So we're going to do a comparison here. I'm going to mirror these together, and the one on the left is Cece, the chocolate lab. She's 16 months old, and she is the puppy that we're going to raise and compare to nurturing and growing an open source project. And when you think about an open source project, this is really simplified. We have governance, technical, and advocacy and community. Obviously, there's all kinds of nuances to an open source project. But for the purpose of this presentation, when you think about an open source project, you have your governance, your leadership, those type of things. You have all your technical, that most of the things that most of you in this audience do. And then you have your advocacy and community things, your messaging, your branding, going to market, your product launches, for example, that are important and that often get kind of left to the end or maybe not even done at all. And the point of this talk is that you need to be thinking about those marketing and advocacy things because that is going to help make your open source project more healthy. So when you think about an open source project, you have the components. You got your code, you got your resourcing, your documentation, your community, and all of that's going to flow into new users, right? And all of these things are really, really important. And when you think about a puppy, you're going to have things like food and water, and those things are really important. And if we don't think about with a project that that you're spending time on community, that you're writing good documentation, your project will have some gaps and may not be as successful. So the other thing important for a puppy is the exercise, and that's where we're just going to have more. We're going to have more users, we're going to have more contributors, we're going to have more of a happy dog. So the first thing when raising a puppy or raising an open source project is to make sure that you have the strategy in place. What are your goals for the project? Like, why are you even doing this open source project? What is it trying to solve? What's going on out there in the technical community that's not happening that you need this open source project for? And you're going to kind of outline and know why you're doing it. You're going to have an idea of what it might be when it grows up. You're going to set those expectations, and you're also going to secure your resource commitments. So anytime that you're setting a strategy for a project, you need to do all of those things, your goals, your reason, your business case, and your resource commitments. With a puppy, do you want something that is small, that's going to fit in your arms and you're going to get to cuddle? Or do you want something that's going to go on a hike with you? And if you don't do all those things, if you don't sit there and plan ahead, if you don't plan ahead with a puppy, you might get something that looks like this. So you really want to make sure that you've given it some thought when you're thinking about your project. Know why it is that you want to develop it. Technology is super cool. I get it. We all love technology. We were spending a lot of time earlier, a couple of us, trying to figure out how to get some technology working. And it is really cool, but really think about what is it going to be, what's it going to offer out, what do you want to accomplish with this project, which is going to help you with the best chance of success. So, and when you get it right, there's always leaders. There are some open source projects that are just done by, yourself, right? But most of the time, an open source project is coming out of an organization. So when you do it and you get it right, you're going to have leaders that are excited and committed. When you're able to communicate why you're doing it, you're going to get buy-in from the extended team. And you're going to have a community that understanding why you're doing this open source project, that hopefully and frankly, you need them to get behind your open source project. And when you get it right with a puppy, you're going to have a lot of fun, and you have somebody to share. As many of you who know me, my favorite food, French fries. Next thing we're going to do is we're going to describe the project. What's the technology? What does the technology do? Who is going to benefit from the technology? Is it the developer? Is it going to be the security team? Is DevOps, platform engineering? Who is going to benefit from this technology? What type of organizations are going to use it? Is it going to be like a Netflix type organization, a big company, a big streaming service? Is it going to be a foundation that can benefit and make it healthy for all their other open source projects? What is that organization that is most likely to get the benefit out of the project? And then the differentiation. And it's not only differentiation from what might else be out there. The biggest differentiation you need to worry about with an open source project is the status quo. How are people doing it now? What is that pain point they have for how they're getting this technology thing that your project is going to solve? How are they getting it done now? Because a rip and replace, changing anybody's mind to do something new, it has to be pretty compelling. So really think about what's the difference between how you're doing it now and how you can do it in the future. So tying it back to the dog, I know this breed. This is like our 6th Labrador. Only one of these is ours, but they're energetic and they're friendly and they need a lot of exercise. So I can describe them. I can describe the benefit of why you would want a Labrador, and I can tell you the kind of people that would get a Labrador and the kind of people that should never get a Labrador. So it's a similar thing, like you all have dogs, or cats. You know why you brought this mammal into your house, and you know how they will fit. Same thing for your project. So when you're building the plan, you now know what you're going to do. Now you're going to build out the plan for communicating out your open source project. The first thing I always want to say is you just have to start. Just do something. You don't have to build out this grand old plan. It doesn't have to be perfect. You don't have to sit there and outline, this is what we're going to do for emails and campaigns and social media. You just, what's the biggest thing that's going to have impact for your project right now? Do you have a big event coming up? Like an event like this. So what do you want to do at an event like this, or even the KubeCon coming up in a couple days here? What do you want to do at those events that's going to help your project? So think about that impactful thing. What are you going to do post-event? What kind of emails are you going to do? What kind of touch communications are you going to do? What are those most impactful things? Write them down, execute them, and continue to build your plan. So tying it back to a puppy, You're going to teach them the most impactful things: sit, stay. I live in Arizona. Leave it is a big one for us, so that I teach her to leave the rattlesnake and the really disgusting toads that are poisonous. Or you get to teach them a super fun little trick, like this is actually my grand Labrador. This dog is picking a coin up off the table and giving it back. So we're going to continue. This is one of those parts of your marketing plan that are a little more advanced. This little skill here on this Labrador is a little more advanced. And you will be adding those to your plan. Write it down, save it in your shared doc, and before you know it, you have a full marketing plan. So I'm going to cover just a couple, I'm going to go a little deeper into a couple things within your plan. There's a ton of things you're going to do with an open source project. I'm going to cover events and community. I could cover branding, I can cover email campaigns, all of those, but I just picked these two that I'm going to cover today. And when you're doing an event, know what your goals are for that event. Like, why did you come, Sousa Rancher, why are you here sponsoring Rejekts? Why are any of you that are going out to KubeCon and participating in the Project Pavilion or as a sponsor, what are you hoping to accomplish? And some of those things most likely are awareness that you have a project. You want to find users who are going to try it and increase your adoption. You're going to want to engage with the community, maybe to find those partnerships. And a lot of times you're going to events to talk to your existing users. Find out, get some product feedback. How are they liking it? How's the experience? How can I keep you using the project? How can I make this better? So that's a couple ideas of reasons that you would do an event. With the dog, what kind of things am I going to do what kind of things do I want to do with my puppy? I want to maybe have her sit nicely at a restaurant. I want her to maybe, walk heel nicely with me. So I know what it is that I want to do with her. This, again, we were in Arizona. It was a hot day, so she has her booties on. So we planned ahead. We knew what we were doing when we got to the event. What you can't see is the whole big bag of treats that keep her sitting there nicely and the little things on her paws to keep her feet from burning on the pavement. But coming back to your event, know what you're trying to get out of it. So some of the specific activities that you would do in an event, you're going to announce something, for example, you want to educate through demos and trying the project, talking to your users to get product feedback, community building. As much as this introvert in probably most of us is, we are going to get out there and we are going to talk with the community and building that community and talking about our project. We're going to build those relationships, and we're going to see what other new technologies are out there to keep up with those trends and how they might help our project. But for the best practices, just kind of make this list of all these different things you can do. You don't have to do all of these, but mix it up and just try them and see how they work, and measure them, and know what you want to do for your next event. So we're going to talk about the other part of your advocacy and community plan that I'm going to touch on in specifics is your community engagement. And when you think about a community engagement, I put them into these 4 pillars. One is content. And any time that you're going to engage with the community, you are going to be giving them something. It's not about them giving you anything. It's about you giving them something, and it's going to be in the form of high-value content. And what is a high-value content? Well, it's going to kind of depend on your community. It's going to be good how-tos. It's going to be good demos. It's going to be short-form, long-form videos. But know continue to build those content pieces that are going to help your community use your project, as well as understand what it is and why it's important to them. You need to talk to your community. You need to have those conversations, and you're going to be doing that via your forums or your Slack and your Discord type things. You're going to be doing it via social media, at events. Kind of have an idea what you want to learn from your community when you have those conversations. How was your download experience? Have you ever filed a support ticket? Did you ask a question on Slack? Do we get back to you in timely? So think about those different conversations where you're asking them how it's going for them while you're getting information that you're going to bring back to your project. You're going to engage with your community on all of those same platforms. And I guess it's probably in my notes, but don't start a forum unless you have resources to answer the questions on the forums, right? Don't try to build a big Slack following or Discord following if you don't have the resources to be out there and interacting with the community. So there's a lot of ways you can engage. Know what those are, and then make sure that you're resourced it and that you can continue doing that for your project. The biggest thing that's going to turn people off is when they get ignored. They ask a question and they get ignored. And then the last part of your project are your rewards. And there are two types. There's intrinsic, which are shout-outs, thank yous, social media shout-outs, inviting somebody to come speak maybe. And then you, of course, have your extrinsic rewards, such as swag and T-shirts and things like that. And there's no right or wrong way to do rewards or really any of this. And I would say that one of the #1 questions I get asked is, Kim, what's the one thing we can do to build our community? And there is not one thing you can do to build your community. It's a group of people and humans that are all very different. And you just have to tie it back to what are you hoping to get out of your project, and how can you work with your community to make it a better experience for them? So through this, I'm trying to give you some ideas of things that you can do to engage with your community. And for the life of me, someone's going to have to read the notes. I don't know why I put a picture of the dog with a toy here, but I think it's, yeah, no, I can't remember. But anyway, that's her baby. The important thing is, and I don't know if you can see this on this video, there is a rope here. They have this rope. And as these dogs are, will this go again? Let's see if this will loop again. Yep. As these dogs are all working together, that is what you are going to do with your community. You are going to get together and you're going to run in sync, working together to be growing your open source project. And with that, that's all I got. Thank you. How'd I do on time? I have no idea. How'd I do on time?
First, enough time for questions.
Okay.
It's unbelievable how people not asking questions. You get a free opportunity to ask questions.
Okay.
No, we have a question, so.
Hi, Kim. Ed from Equinix.
Hi.
I have a question about open source projects. All of your examples were related to your dog. One typical counter example is open source projects are like herding cats. Can you? I mean, metaphors go a long way, right? There's a sense of independence as opposed to following direction. There's a sense that the group might split at some point, and you'd have a fork in your project because things had gone a different way. And I just want to, like riff on some aspect of dog behavior versus cat behavior in open source projects.
Oh, like when they run the other way. I had a big old conversation about whether to really put the air tag on the dog or not because she runs away. And yes, so I do have an air tag on my dog because like open source projects, you are beholden to the community. You are beholden to the open source community, and we can't make anybody do anything. And so with your open source project, it comes back to that community building and engaging with them and letting them know this is what our view of the project is. This is why we think we're doing it. What this technology, how it's going to benefit the planet or the community or this industry, and this is how we think we're going to go about doing it. And actually probably one of the #1 things in building a community, and what I have advised the big organizations when I went and worked for them, is you got to let go of control. You got to let the community do what they're going to do. The best chance of the community doing what's in your vision is when you know what your vision is, coming back to your business strategy, you know what your project is doing and what you're hoping to accomplish, and then you communicate that. And then you will have the best chance of everybody working together, the same direction as your vision as well. But then you also have to listen during your engagement, because somebody may just call you out and say your whole vision is wrong, right? Like the people who tell me, whether you use a shock collar or not, I'm not going to pass judgment, but the people who tell me I should put a shock collar on my dog, and I'm like, no, I won't do that, right? So you always have somebody who will come and say something that isn't in line, and you need to be able to answer why that won't work for the project. Did I answer it? Great to see you again.
So in the parallel with the puppy, what's the equivalent of the CNCF, and at what point is the right stage to put your puppy into the CNCF?
Oh my gosh. Wow, okay.
If at all.
I don't know. So let's see. Would putting my puppy in the CNCF would be like giving her back to Labrador Rescue to find her a new home because I can't take it anymore? No. How do you know when to give a... You know, that's a really great question. As I've talked to some founders who have open source projects that are not in a foundation, so for people who don't know me, I came from the CNCF, right? So I'm like, yeah, the projects are great in there. The foundation gives them a lot of support. It has been a bunch of years since I've been gone, so I don't know how much of that is still true. I do want to caveat that. But you know, we really wanted to, we were growing projects. We were adding lots of projects into the foundation. We were providing them with support. I was part of the team that was helping them with their marketing and their branding and making sure that the person was doing the stickers. This was like a pre-Amy when I was there. And so there were a lot of benefits to getting your project in there and getting that awareness. What I can't answer, because I haven't dug into enough, is with some of the founders who have open source projects and don't want to donate them. And so I don't have an answer, but I'll tell you what, when I get that, I'll write a blog on it and I'll let you know. Unless anybody has anything they want to share with the audience on why you would not donate your project. Yeah, save it for a happy hour, yeah. That's a great question, and yeah.
Any more questions? Other than that, I learned a lot about the CNCF and the animal shelter and the picture of the dog with the prey in the mouth. Was it his puppet, or what was it?
It's a stuffed snow leopard that she had de-stuffed.
He hunted it really down.
Yeah, that's
okay. Then thanks, Kim, and yeah.
Thank you all
for the next talk. Thanks. Okay, last talk of today. Really, that's a cool talk. Gateway API. What's new on Gateway API of Abdel Fattah? C'est quoi?
Good enough. Good enough.
Good
Thank
enough,
you.
good
Thank
enough.
you.
So I tried, so.
Good job.
Thank you very much. So looking forward for this one. And yeah, welcome, Abdel Fattah.
Thank you. Well, hello everyone. Bonjour. Bonsoir. Happy to be here. My name is Abdel. I'm a cloud developer advocate. Most of you probably don't know me by my Twitter board, Abdel, but I think a lot of you probably know me by my voice on the Kubernetes podcast. I had a very funny story today. I was actually walking to the venue with my girlfriend, and my girlfriend speaks English and French. So we were switching between English and French, and somewhere on the street near the Louvre, somebody stopped in the middle of the street and turned to me and said, "I know you." And I was like, "I never stole anything from you." I was like, "No, you do a podcast." And I was like, "Sure." So, let's start with raise your hand if you have used Ingress before. OK, good. Raise your hands if you have tried or used or planning to use Gateway API. Anybody, keep your hands raised. Drop your hand if you're not planning to use it anytime soon. OK, good, cool, nice. So we're in the right group. So let's start very quickly. What is Ingress? Ingress is an API object that was introduced to Kubernetes very, very early when it was created. The idea of Ingress was basically creating external services to the cluster of typically type HTTP. A lot of times when people talk about Ingress, they confuse Ingress with Ingress controllers with Ingress, the object itself. But basically, the TLDR is that Ingress is the object inside Kubernetes, and Ingress controller is the piece of components that integrates the API in Kubernetes with whatever load balancer, whether it's a cloud load balancer or an in-cluster load balancer. And the Ingress proxy is whatever load balancer. They could be outside the cluster if you're using a cloud provider, or they could be inside the cluster if you're using something like Nginx or HA proxy. And typically, this is how people use the Ingress API, right? You deploy an Ingress object, you point it to a service, the service points to a bunch of pods, and then that provisions a load balancer. The integration between the Ingress and the load balancer is what we call the controller. So that's the Ingress controller. There are actually multiple Ingress controllers, hence the S at the end. I think last time I checked, there was something like 50 of them, because every single proxy just developed their own controller, and then every single cloud provider have their own controllers, and then every single cloud provider have more than one version of the actual controllers. So basically, an Ingress controller, what it does is, so this is just some of the lists. You have Nginx, HA proxy, traffic, but then you also have some like cloud provider-specific ones. So take a look about how an Ingress looks like. Typically, this is how it looks like. It's just an object. It has the Ingress type, name, blah, blah. But this is where things start getting a little bit complicated. It's all these annotations. Because the Ingress controller was not, and is not actually a very flexible API, a lot of times, specific cloud providers and also proxy people that make proxies, they had to add certain annotations to make you customize the Ingress. Those annotations could be things like disable HTTP, set like a specific certificate, set a specific IP address, et cetera, et cetera. And those annotations behind are picked up by CRDs that would basically make that annotation happen, right? Or make that annotation do something. And then some cloud providers like Google, guilty in charge, we have integrated more CRDs that allows you to do more customizations. And we're not the only ones. Like a lot of other cloud providers have more specific CRDs. Then all your traffic rules are here. So this is where you say, if my rule matches host service1.foo.bar, path whatever, you go to this backend. A couple of limitations or a couple of problems. First of all, the Ingress controller have been designed such a way that whatever is behind it has to be in the same namespace. You cannot do cross namespace pointing with Ingress, right? It was designed to solve the lowest common denominator. It has about, actually that number is wrong. It's more than 22 implementations. But the key thing with Ingress is that a lot of like built-in features were not portable. Like the way you would do traffic splitting with Ingress depends on which cloud provider you use and depends on which Ingress controller you would use. You have no single way to just do traffic splitting and make sure that that object can be just applied to a different cloud environment and just works consistently, right? Annotations cannot be validated. There is actually no way to validate an annotation. So a lot of times people just write an annotation and then it doesn't work. They get frustrated. They open a GitHub repository and someone goes like, oh, you forgot an I here or something like that, right? And there is no such thing as a permission model. Actually, this last limitation, I think, was one of the biggest problems that the Ingress controller have, or Ingress as an API has, which is basically, if you are running on top of a cloud provider, you can only enable or disable Ingress. You don't have any other type of permissions. And if you enable it, anybody can deploy an Ingress and get the public load balancer exposed for their application. So in 2019, San Diego, a group of contributors to Kubernetes from different companies got together, and they started touring with the idea of building a new API. They set some goals. Initially, the goals were, this has to be generic, it has to be expressive, it has to be extensible, and it has to be role-oriented. Generic does not necessarily always mean portable, but it has to be as portable as possible across implementations. Expressive means it has to be easy to understand. Extensible means you can add things to it, right? And role-oriented is a key feature in the Gateway API, which I'm going to talk about in a bit. So the Gateway API got introduced. It became GA in October 2023. And with that, a bunch of objects, which are part of the Gateway API model, became GA. I'm going to talk about all this in a bit. There is about 26 implementations right now. And it comes with expressiveness and extensibility, but also it comes with role-oriented resource model. So it can do a lot of things. You can do TLS configuration. You can do HTTP matching based on patterns or host. But there is actually a bunch of things. So the top features are features that already existed in Ingress, so these are not new. But there were some things that were added to the Gateway API that were specific to the Gateway API. For example, header, method, or query parameter-based traffic splitting. You can only do that with the Gateway API. If you are doing it with Ingress, you will have to implement specific annotations for that specific Ingress you are doing. It can do cross-name role binding, or rule binding, or route binding. So you can have the Ingress, the gateway itself, or an object called gateway deployed in one namespace and pointed to backends in a different namespace. It comes also with like HTTP filtering, so you can filter based on headers, you can filter requests, blah, blah. You can do weight-based traffic splitting, et cetera, et cetera. There's actually a lot of features coming. And the key thing here is that all these features are built into the Gateway API. So they are consistent across implementations. They work the same way. And with that, the team that built actually the initial design, they came up with this thing called the conformance level. So the Ingress or the Gateway API is built in 3 layers. So it is the core, which is portable, and that's essentially the base of what makes the Gateway API work. You have the extended part, which can be extended, and sometimes it's portable if they conform to the tests. And then the custom part is essentially features that are only specific to a specific cloud provider or to a specific proxy, or sometimes to even a specific mesh, because it does also mesh. So this is how it looks like. You basically create what we call a gateway. A gateway typically is the actual object that will deploy the load balancer. Again, a load balancer if this is a cloud-based load balancer, but if you are using it with a proxy, the gateway will result in deploying actual proxy. So if it's Nginx or HA proxy, the gateway essentially maps to a proxy or a set of proxies, right? Then you can, the example here is that you have the gateway inside the infra namespace, and then you can point it to services in a different namespace. And the way you would link a specific gateway to various services is using something called the route. And there are multiple types. HTTP route is the most straightforward, but you have also TCP route, UDP route, SSL route, and then a bunch of other routes coming down the line. So this is essentially what we call the role-oriented model, where essentially you can have the infrastructure team responsible for deploying all the gateways for you, and then the developer team will consume the gateway through the routes to point that load balancer to their services. And there is even built into the Gateway API, there is a way where you can cross-reference. You can say this gateway can only be selected by routes in namespace ABC. And then when you are using a route, you can point it to one specific gateway. So a route can only point to one gateway. A gateway can point to multiple routes, which makes sense because when you deploy a load balancer, you do something called fan out, right? One load balancer pointing to multiple backends. There is one more object which is not clear here. Sorry, yeah, here we go. So you have, we talked about the gateway, we talked about the routes, we talked about the services. Services with capital S, basically we talked about Kubernetes services that you already know. The other object that is typically not something you will have to care about if you are using a cloud provider or a managed infrastructure is we call a gateway class. So you can think about gateway class similar to a storage class in the CSI, where a storage class defines the type of storage you get, whether you want spinning disks or SSD or NFS or whatever, right? So a gateway class is basically an object that will basically be available in the cluster for you, provided by the infrastructure provider. And that gateway class specifies what types of load balancer do you get. Do you have a layer 4 load balancer, a layer 7 load balancer, internal load balancer, external load balancer, multi-cluster load balancer, et cetera, right? Then somewhere down the line, I think 2020, they introduced something called policies. They were attempts to introduce policies. There is still an object called LB policy or load balancer policy, which was deprecated very quickly because they realized that the implementation was not possible or was not portable. These are the three main policies that today exist. There is a timeout policy that can be attached to the gateway, and that basically just tells the load balancer the timeout, right? Very straightforward. There is actually a retry policy that can be attached to the HTTP route, which can tell the route how many times to do retries toward the backend before failing. And there is a health check policy that can be attached to the service itself. This is very important because a lot of times when you are deploying cloud-native applications, your application might serve traffic on port 8080/, but health check might be served on port 2020/health-z. Very famously, the very famous example here is service mesh with Istio. So the envoy, the proxy, it doesn't actually serve health check on the same port it sells traffic on. So you will have to tell the load balancer where to send health check requests to versus where to send the regular traffic to, right? There was also this, so when the Gateway API got introduced, it was introduced with the same kind of model that most Kubernetes APIs follow, which is like alpha, beta, and then GA. And then very quickly, they actually deprecated that idea because they didn't really see, the team did not really see that much value in carrying beta. So instead, they introduced something called release channels. So there is a release channel, standard one, and there is an experimental one. And so inside the release channel standard, you basically have, there is still technically a beta and GA just because of the way Kubernetes versions APIs, but there is no such thing as GA. Once an API passes all the requirements, it will just become GA automatically, right? And there is an experimental channel, and the experimental channel is where you typically have your alpha APIs if you want. That's where you have the stuff that are being built. So where is this heading? So everything I talked about so far is almost, well, it's GA. So gateway class, gateway, and HTTP routes, those are GA since October last year. Where are we heading now? Where are we going? There is a bunch of new APIs or CRDs that are being introduced. There is one thing called backend TLS policy. So what does that mean? Essentially, well, sometimes you want to have encryption from the client to the server, to the load balancer. So that's essentially the load balancer itself only listening on port 443 and serving a certificate. But you might have requirements where you want encryption to be done by the load balancer all the way down to the backend, because you might not trust your cloud provider network, right? So the reason why you would configure the front-end encryption or TLS different than the backend TLS is because the front-end TLS is internet-facing, so you want your certificate to be trusted by a CA, et cetera, et cetera. The backend TLS is not very important. I mean, you can do self-signed certificates for your backends, right? So with the backend TLS policy, you will be able to define an object called backend TLS policy. You can point it to a certificate, which can be a secret, a Kubernetes secret. And then, again, that certificate can be provisioned by cert manager, could be self-signed certificate. The point here is that your backend, your service, will just expose a TLS toward the load balancer. So if you are using, why this is important? If you are doing in-cluster load balancing, this is not very important, because in-cluster load balancing means that the proxies are inside the cluster. When you are doing cloud-based load balancing, typically the proxies that are acting as the load balancer, they don't sit inside the cluster. They sit somewhere outside in the cloud provider infrastructure. So if you want to encrypt traffic from the load balancers themselves all the way back to your backend, you would use a backend TLS policy. These are all available in experimental, by the way. There is an HTTP route timeout. I talked about this, so I think we can. There is actually, this exists, but they're adding a bunch of improvements to it. Specifically, they're adding the duration format, like respect the duration format the same way it's respected in most of Kubernetes APIs, 10 seconds, 10 minutes, 20 minutes, whatever. There is a gateway infrastructure labels, which is being added. Essentially, you will be able to label the specific, the gateway object, and those labels will be applied on the underlying resources that are created by the gateway object, or that are created by the controller. Why this is important? If you are doing multi-tenancy on Kubernetes, sometimes what you want to do is you want to be able to do cost allocation, right? You want to be able to say this specific load balancer is consumed by this team, and the way I would know that this load balancer is consumed by team A is I have a label on it that I can then export in my billing data later. Most cloud providers have this kind of requirements. So you'll be able to basically label the gateway, which then will label the actual load balancer and all the resources that are allocated to it or assigned to that load balancer. This is one of my favorites, which is coming. It's a backend protocol. You'll be able to specify if your backend talks something that is not HTTP. This is very important for things like WebSockets. or WebSockets over TLS, for example. There is a command line that was introduced called the gateway CTL. Some of you might ask, why do we want a gateway CTL, which is not kubectl? Well, kubectl is great, but with custom CRDs, kubectl doesn't give you, it lacks a lot of capabilities. One of them is being able to list nested content. You saw earlier, I can show you an example here. So you see here, for example, in the HTTP route, where you have in the rules, you have the backend reference, and in the backend reference, you have the service and the port. If you just kubectl describe this, this is what you will see. But with the gateway CTL, you'll be able to see also the details about that backend service. So it will basically be able to show you the nested objects inside a higher level object. So that's essentially the gateway CTL. Then there is the service mesh implementation. So everything I showed so far talks about essentially north-south, right? Traffic, outside the cluster, getting through a load balancer, and then hitting a backend, and then getting propagated inside the cluster. But technically, all these objects that end with route, HTTP route, TCP route, SSL route, etc., they also can be used to define east-west traffic, right? And that's essentially what an object like a virtual service or a destination rule in Istio do, which is east-west. So there is an initiative called Gamma, which is essentially a new version of an existing initiative that was called SMI, Service Mesh Interface. But Gamma essentially is the initiative by which some service mesh tools are trying to leverage the gateway API implementation for the specific things that the service mesh needs to do. So you'll be able to use an HTTP route or a TCP route to define traffic inside the mesh. So that's everything east-west. And then upstream, this was the last, well, this was introduced last year, actually. There is actually a tool called Ingress to Gateway. Have anybody tried it? Does it work? Good. Thank you. Because if you said no, I would have just left. Because I helped build it. There is a tool that will basically, you can just run it. It will pick up your Kubernetes context, query the cluster, and then figure out all the Ingress objects, and then output the equivalent gateway objects for you. If you are crazy, you can just pipe that into kubectl-f if you want. I don't recommend you to do that. I still recommend you to still read those objects, clean them up before you apply them to your cluster. Sorry? Yes, thank you. That's what you should do. And that's it. Thank you very much. I hope you have any questions for me. How did I do on time? Okay. Perfect. Okay, thank you.
Your talk. Any questions? This is your chance. The master of Gateway API. 3 questions.
Not sure about the master, but
yeah,
I'll try to bullshit my way into an answer. Yeah. Yes.
Okay. Great.
If you got custom described support in CRDs, would you drop Gateway CTL, or would there still be use for it?
Yes. Yes, that's the only reason why they built the
Is there somebody who has a KEP for that already?
I don't think so, but I think we can figure that out.
We have a couple old ones that we could resurrect because we have those tools now for it. So that'd be
good. Then I can point the person who is working on Gateway CTL toward that.
That'd be great.
Good. Thank you.
Any more? Hiya.
Hello, please could you explain the difference between the readiness probe on the pod and the health check?
Can you repeat?
Can you describe what is the difference in the meaning between the readiness probe on the pod and the liveness check that is provided in the Gateway API?
Yeah, so the readiness probe is a probe that is exposed to the kubelet. So when you create a readiness probe, it's the kubelet that executes those readiness probe toward your pod. The health check backend policy is the health checks coming from the actual load balancer. And there is some correlation between them depending on the implementation, but you will typically want to use both, right? Especially if you have your application exposed to outside, you want to be able to customize the actual health check coming from the external load balancer toward your backend.
Thank you.
No worries.
Hi, is there a deprecation timeline for Ingress or any point at which it's envisaged to be removed?
Tim, is there a deprecation timeline? I'll let Tim answer this question.
Ingress is a V1 API. We don't get rid of V1 APIs.
Good. It's a good question. Well,
kind of similar. To my knowledge, the gateway API is something you need to add to Kubernetes. It's not mainstream. So any plans to make it more like included by default?
It's going to be at some point eventually available, yes, as mainstream API. It's not today. I mean, if you self-deploy Kubernetes, you will still need to deploy the CRDs yourself. But eventually, I mean, on Google Cloud, we just deployed them for you, starting, I don't know, 1.28. I don't know what the plans are, honestly, to make them part of the upstream API. No? Never?
So we have discussed it, but there's no firm plans as yet. So,
Okay.
but it is on the list to talk about. Probably.
I should have let the maintainers do the talk. Why am I? Why am I here?
You did a great job. It's fun.
Thank you. Tim has some.
Just to add to that, Gateway has pushed the bounds of what can be done in CRDs, which has been hugely valuable. It didn't always play out exactly the way we wanted it to, but it has been incredibly valuable. And you saw earlier a talk on validating admission policies. Like those come out partly in direct response to things that Gateway has been doing. I doubt very much that we will want to bring it back in as a quote built-in API. Whether we'll ever put it into conformance and say thou shalt have a gateway implementation is an open question, but even Ingress isn't really covered by conformance.
That's okay. That's a very valid point.
I had one more. Are there any examples of non-HTTP TCP routes that folks are looking at today?
I don't have. I might have examples in hidden slides.
Sorry, and gRPC. Yeah, because there's definitely some room for, I think, in the AI.
No, sorry. So I didn't hear the question.
Well, I said I think there's some use cases starting to come up in the AML side that might actually align to a new type of route. And it would actually be interesting to talk about what other people are doing.
Very good. I don't have any examples, but we can have a conversation, yes?
I also really want to see L4 routes really take root so that I can kill off good chunks of service.
I think TCP and UDP routes are in the experimental channel.
Yes, that's right.
And gRPC, I think, is already there as well. And there is
gRPC is an experimental and probably will move to standard in the next release.
And there is SSL route as well, right?
Pardon?
There is an SSL route.
TLS route, yes.
TLS route, yeah, thank you.
So TLS route is only waiting on some performance tests to move to standard as well.
Yeah, so this is something I probably should have mentioned. Like the goal also with the Gateway API is to support layer 4. So TCP,
yes,
UDP,
definitely.
TLS, gRPC. Well, that's arguably whether it's layer 4 or not. And then I will open a cap because I want to add something called a serverless route.
Sorry?
Just serverless route.
Serverless route, okay.
Being able to point to something that is not like a non-Kubernetes object, right? Non-Kubernetes pod or non-Kubernetes backend.
Yeah, definitely open the gap for that. Yep. We'll have an interesting.
We'll
have an interesting discussion.
Yes. All right. Any other questions?
Then I say thank you.
Thank you very much.
Just a note from the organizer of the event: there is a happy hour. I was told to tell you, please go to the happy hour. So, thank you.